Hello, good morning and welcome to the live stream coming to you live from the 2025 convention here at Milton Keynes. We've got a packed program again for you today and I hope you'll stay with us for at least some of these talks. Let's have a look at the program for Sunday's live stream. So we start at 9:15 very shortly with PCB design for low voltage switch mode power supplies. At 10:30, radio industry, STEM and engaging youngsters. 11:30, the biggest nerd she's ever met, my TV adventures with Hannah Fry. At 1:30, polar modulation SSB, high performance and efficiency at low cost. At 2:30, was that solar cycle 25? What do we learn? And then at 3:15, the closing remarks from our president, Bob Beebe, GU4YOX. So, as I said, a packed program, and as well as all of these lectures, we've got lots of other interviews and people to meet in between all of the lectures. And we've also got a special event station called GB3HQ, which is coming from the Cam Hams Outside Broadcast vehicle. And we're going to go over to them now live. If you do manage to work that station as well, you should see your call sign coming up on the log. We'll see you very soon.
CQ40, CQ40, this is Golf Bravo 3, Hotel Quebec. GB3HQ, Golf Bravo 3, Hotel Quebec, calling CQ. CQ40, CQ40, this is Golf Bravo 3, Hotel Quebec. GB3HQ, Golf Bravo 3, Hotel Quebec, calling CQ. CQ40, CQ40, CQ40 meters, Golf Bravo 3, Hotel Quebec. GB3HQ, special event station for the RSGB convention, calling CQ. CQ40, CQ40 meters. This is Golf Bravo 3, Hotel Quebec. GB3HQ calling CQ. CQ40, CQ40, CQ40 meters, Golf Bravo 3, Hotel Quebec. GB3HQ, Golf Bravo 3, Hotel Quebec calling CQ. Mike Whiskey 0, Sierra Alpha Whiskey. Good morning to you, 5-9 in the clear.
Yeah, good morning there. The name is Steve, Sierra Tango Echo Victor Echo. And yeah, nice 5 and 9 signal into South Wales, alright?
Yeah, thanks for the 5 and 9. You're good sake. Good 5 and 9. Nice audio here over at Milton Keynes at the special event station for the RSGB convention. This is GB3HQ. My name is Rob, Radio Oscar Bravo, operating with a Flex 6400 Handicraft KPA 500, bet 500 watts into a dipole at 10 metres over.
Yeah, fine business, Rob. Lovely to work with you. Actually, you're probably about 5-9 plus 20. Having a second look at the meter, so cracking signal there. Well, good luck with the special event station, and have a cracking rest of your weekend there. Best 73.
Yep, thanks very much for the call. 7-3. This is GB3HQ, Golf Bravo 3, Hotel Quebec. CQ. CQ40, CQ40. This is Golf Bravo 3, Hotel Quebec. GB3HQ calling CQ. GB3HQ, Golf Bravo 3, Hotel Quebec. GB3HQ, the special event station for the RSGB convention, calling CQ. CQ40, CQ40, this is Golf Bravo 3, Hotel Quebec. GB3HQ, Golf Bravo 3, Hotel Quebec, calling CQ. CQ40, CQ40, this is Golf Bravo 3, Hotel Quebec. GB3HQ, Golf Bravo 3, Hotel Quebec, calling CQ. CQ40, CQ40, this is Golf Bravo 3, Hotel Quebec. GB3HQ, Golf Bravo 3, Hotel Quebec, calling CQ.
Golf Bravo 3, Hotel Quebec. Golf Bravo 3, Hotel Quebec. This is Germany, Mexico 3, Uniform Papa Golf, Maritime Mobile. Golf Mike 3, Uniform Papa Golf, Maritime Mobile. Over.
Thanks very much for the call. Golf Mike 3, Uniform Papa Golf, Maritime Mobile. You're 5-9 in the clear into Milton Keynes at the special event station for the RSGB convention, GB3HQ. My name's Rob, currently using a Flex 6400 with an Handicraft KPA 500 amp, 500 watts and dipole at about 10 metres over.
Okay, fine, Rob. From TI3, Maritime Mobile, slip of the tongue there. My own call sign is actually TI3 UPG. I'm over in Scotland at the moment, in the boat. We're actually in Port Patrick, in the harbour at Port Patrick. And you're 5-9 plus 10, 5-9 plus 10 from and it's trap dipole about 30 feet up in the air at the centre point to be going for 3 bands, 40, 20 and 10 metres. But you did signal, I had you calling 60 a few times, I wasn't going to bother, but nobody came back to you, so I thought I'd let you know if you're getting out well here into Scotland. The handle here, I think it says Robin, Radio Oscar Baker Ida Nancy, Robin. So back to you again there, Golf Bravo 3, HQ, GI3, Golf Mexico 3, Uniform Papa Golf, Maritime Mobile.
GM3 UPG, Maritime Mobile. This is GB3HQ. Okay, Robin, all copied. And it sounds like you got a reasonable station there on the ship. And yeah, okay, fine on the normal call and where you are now, all noted. And yeah, lovely to hear you. Thank you very much for the call, and keeps us all going here. This is GB3HQ, over.
Okay, fine, Rob. Yeah, no problem. problem. I think the skip is probably ideal between us because the strongest stations are here coming in here all seem to be up to the skip distance. I hear a lot of southern Irish stations coming in, so it's probably about whatever distance is between us is probably about the best skip at the moment. But we'll try. Good luck with catch up with you later. GB3H2, GI3U, Gulf Mexico 3, Uniform Papa Golf, Maritime Mobile Clear listening.
Yeah, 7-3, thanks very much for the call. And yes, I concur on the conditions. They're definitely not they're not very into G. They're more longer distance. 7-3, this is GB3HQ, Golf Bravo 3, Hotel Quebec, special event station for the RSGB convention here in Milton Keynes. CQ. The station just called. I think it was a Golf 3. Go ahead. Golf 3 Sierra Echo, was that? Golf 3 Sierra Echo Whiskey. Yeah, you're about 4 and 6 here into Milton Keynes. Conditions not over brilliant for us today. Over. Yeah, I missed some of that. Did a bit of QRM, but yeah, we've got say a lot of noise here on the band, and also the Scandinavian Activity Contest, and of course conditions are not over brilliant for 40 metres for into G. But thanks very much for the call. Most welcome. This is GB3HQ. Over. Yeah, 7-3, thanks very much for the call. This is GB3HQ, Golf Bravo 3, Hotel Quebec. CQ.
Yeah, Mike 7, Mike Papa Yankee.
Sorry about that slight technical delay. Good morning, welcome to the live stream. We're now going to go to our first lecture, which is PCB design for low voltage switch mode power supplies with Dan McGraw, M0WUT.
Good morning and welcome to the first talk of the day. For those of you that were here last night, we are going to be talking, or Dan is going to be talking about PCB design for low voltage switch mode power supplies. So just to check you're in the right room after the amount you drank last night. And welcome to those who are online. We're delighted that you can join us this morning. So Dan McGraw. Dan was first licensed at the age of 11 and since then has enjoyed nearly every aspect of it. His main interests are construction and HF contesting with the cam-hams. He carried on his enthusiasm for radio into his professional life, where he spent 7 years designing high-performance SDRs with a major focus on design for EMC. He now works at ARM, focusing on the design, simulation and verification of PCBs containing a large number of high-speed data buses. So his talk is about low-voltage switch-mode power supplies, which are an essential part of modern-day electronics, yet many radio amateurs choose not to use them in their projects. This is because of their fear of them being noisy. As Dan describes it, EMC cause monsters that must be kept far away from their delicate sine waves. Whilst they require slightly more careful handling than the classic 7805, they can achieve similar levels of output noise while offering much higher efficiency if used properly. One of the dominating and often overlooked aspects of noise coming off an SMPS is the layout of the PCB. This talk aims to draw on the author's experience in the design of ultra-low emission devices to explain the root cause of many of the EMC issues encountered by amateurs and how you can avoid them in your next project. Dan.
Right, thank you very much for that introduction. So, just a brief overview of what we're covering and not. The whole field of switch mode power supplies is, you okay, Dom? Is like too big to fit in a 45-minute lecture. So what we are going to cover is the mechanisms by which they generate noise and the things you have to be thinking about whilst doing your design and layout. And then what I'm actually going to do is take you through a worked example where I've taken a DC-DC converter, redone the layout, only the layout, and then remeasured the performance and seen how much better we can make it. I'm afraid I'm not going to have time to deal with like component selection, you know, picking input-output capacitors, what switch mode converter can you use. For the most part, if you go to any reputable manufacturer's website, you know, TI, Analog Devices, Monolithic Power, anything, and search by I want a thing with the input and output voltage characteristics and the output current I want, then sort by cheapest, you're probably onto a pretty good start, and they'll generally give you, like, here are the component values we used in our reference design, or they'll be quite hand-holdy on the schematic. And we're not going to cover all the different types of DC-DC. There's a whole world of different architectures. We're just going to focus on one, but the techniques that apply here, you can apply to basically all of them. You know, some of the sort of positions of stuff change, but the techniques are still applicable. So, quick recap on linear regulators, like mainly focusing on how noise is generated. So the way a linear regulator works is effectively they're variable resistors that are changing their resistance to keep the output voltage as what you want. You have your input current, it's roughly equal to your output current, and this is effectively adjusting its internal resistance to drop the voltage to keep the voltage on the output side constant. The problem with this is you're burning the voltage drop between input and output times the current you're flowing through it. That is power which you're dissipating inside your linear regulator. So this tends to cause problems on any sort of devices where the current draw is high or your ratio of input out to output voltage is substantial. And what this really means is because it's just a variable resistor that's sort of adjusting itself, they have no real mechanism for generating significant quantities of noise. Generally, your output noise is less than your input noise under most conditions. However, switching regulators are an entirely different beast. Today we're going to be focusing on buck or step-down converters. So these have the property that the output voltage is generally less than the input voltage, but there are similar types that you can get the output voltage higher. You can have both. You can put transformers in and have isolation, but we're just going to worry about this today. And the way this works in an analog domain is you have a switching element, and that is turning on and off, and then you have a low-pass filter on the output. So, as a simple example, if your switch is on half the time and off half the time, the LC on the output will then average that out and give you a DC voltage. And by changing the duty cycle of that switch, you can vary your output voltage. So if we look at this example here, what we've got, so we're looking at the voltage waveforms on the three different nodes. So we've got input in blue, the switching node between the switch and the inductor in orange, and the output in grey. So we can see our switching node, when the switch is on and switch is off, is switching between more or less the input voltage and 0 the whole time. Our input voltage will also change slightly. This is because we will have some sort of resistance in the cable supplying this, so you will have IR drop across that. So when the switch is on and we're drawing current, the input voltage will sag slightly. And we have our output voltage. And what this is doing is when the switch is closed, we're charging up the output capacitor, so we can see the output voltage rises. And when the switch is open, we are then drawing energy from the capacitor and the output voltage falls. All of these mean that these different rails all get noise generated on them at the switching frequency of our converter. So what we're going to do is look at the converter in the state when the switch is on and when the switch is off, still staying in the world of perfect components. So when the switch is open, we've got essentially the full input voltage across it, but no current flowing through it. So the power dissipated in that switching element is 0. You know, P equals IV. If one of them's 0, the power dissipated is 0. when the switch is closed, staying in our perfect theoretical world, well, we have no voltage across the switch, lots of current going through, but assuming our switch has no internal resistance, we get no voltage dropped across that switching element. So again, the power dissipated in the switch is low. The times when we are burning power in that switching element and wasting it as heat are when the switch is transitioning from on to off. At that point, it will go through a region where it behaves like a resistor for a short period of time, and you'll both have current flowing through it and voltage dropped across it. So every time you change between the switch being on and the switch being off, you will dissipate power in that switch. So what this means is that manufacturers of switch mode power supplies, the main headline feature you'll see in any switch mode power supply datasheet is generally the efficiency. Normally on the front page there is the plot of efficiency. That's the big thing they're going for. So given that any time the switch is in a half in between state, it's burning power, they want to turn that switch on and off as fast as possible. And what that means is the rise and fall time of the voltage on that switching node is incredibly quick. So, and the problem is that you have a tendency to, you look at the fundamental switching frequency and you go, that's far away from my RF. You know, I've got a switching converter at 100 kilohertz. I'm trying to do DX on VHF. There's no way this is going to cause me a problem. Anyone have noise problems on VHF? And the problem is essentially due to this. Your power of your square wave, your amplitude of each harmonic only decays as 1 over n. If you plot that in dB, so we've got sort of which number harmonic is along the bottom and the dBs of attenuation on a perfect square wave up the y-axis, you can see that by the 1000th harmonic, you're only 60 dB down. So if your buck converter is sloshing around, you know, amps, 5 amps, 10 amps, 60 dB down is still very loud relative to the signals you're trying to receive. And as an example, I actually went and measured one. So I grabbed a random switch mode converter. It's switching at 116 kilohertz, yet the rise time they've engineered to be 2.5 nanoseconds. 1 over that is 400 megahertz, and I suspect it might be faster than that. I only have a 200 megahertz scope, and I couldn't, so I definitely need a new one to do more accurate measurements. That's what I tell myself anyway. And you know, this was not a crazy high performance thing. This was bought for £3 on eBay, so we're not, you know, it is relatively trivial nowadays to get silicon to switch at a few hundred megahertz. It's fairly straightforward. Even cheap regulators are doing it to try and push up the efficiency. So, given that we have this noise source at our switching frequency and all its harmonics in the effort of pushing up the rise time, how does that get out into the world? How does that get out into our radios? Now, from the previous slide, I've shown you that you will get voltage noise on the input and output nodes that will be conducted into your various systems. I'm not going to worry too much about conducted noise. For the most part, conducted noise can be dealt with by filtering, and it generally, you know, if it's in your wires and you can control where it's going, you can put conducted filters in. Where it gets tricky is when it starts radiating or coupling through fields. And the problem with that is it becomes difficult to predict where it is, sort of how it's getting in there, and it becomes quite difficult to actually isolate different parts of your circuit. Conducted noise, you know, you can put an LC pi filter or something like that, ferrite beads, more decoupling caps, all of these will deal with conducted noise. But if it's going around all of that, either through free space or coupling between layers in your board, that's very difficult to fix. So there are two major mechanisms of emissions in a switching power supply. So we can either emit a strong electric field or we can emit a strong magnetic field. For electric field, there's only really one culprit, and it's that switching node there. Ability of an E field to radiate comes from sort of rapidly changing voltage, and that's the only point in the system where the voltage is really changing rapidly. You know, we have a big swing. It's going between roughly 0 volts and roughly your input voltage. That's a substantial swing, and it's changing fast. And in the near field, so in close proximity to it, you can sort of think that as it's forming a rubbish capacitor with the things around it. So the things that sort of matter are how big the plate area is, so how big the node on your circuit board is that's that switching node. Once you've got sort of past your input and output capacitors and you've hopefully dealt with the sort of high frequency noise and you're back to something that approximates DC, you can be more liberal, you can have bigger planes, because in theory, if you've filtered all the noise out, you're giving a better you can then have a big plane, You've given a bigger patch that's more able to radiate, but you're injecting less noise into it. The problem with that particular node in your circuit, it has got a lot of noise on it, it's high frequency, and it is happy to radiate. The more interesting problem, and the one that I see more often messed up, is H-field coupling, so magnetic coupling. So this is caused by high-frequency currents flowing around a loop. And in the near field, you can treat this as sort of inductive coupling or a sort of low-coupled transformer is the sort of way to think about it. And how well it radiates comes from how big the loop is that this high-frequency current is flowing around. You're effectively making a loop antenna. Before we assess which points are critical to this loop, there's something missing from this circuit diagram. I've kept it as simple as possible, but it's not quite correct. The problem comes is when the switch is closed, we build up current through the inductor. And then we try and open this perfect switch, and we try and drop the inductor current to 0 instantly in this theoretical model. Now, the voltage across an inductor is its inductance times the rate of change of current going through it, and we have suddenly tried to collapse the current to 0 very quickly. So if you put this into a simulator, apologies, this axis is probably a little bit small, so this is effectively the bottom trace is whether or not the switch is on. If it's at the top, it's on. If it's at the bottom, it's off. The top trace is the voltage on that switching node if I live in a perfect world. And this is full of huge amounts of numerical errors because I'm trying to make perfect things stop current infinitely quickly. So having a bit of a hard time. But LT Spice is predicting somewhere in the region of -5 kilovolts on that switching node if you can stop that inductor. So what we need to add, and it'll be important later, is an extra element to our circuit so that inductor current can fall gracefully. And what we tend to do in most cases is we have a sort of diode element that we put in there, and that gives us a path for our loop to flow. So now we want to analyze where our loops are when the switch is on and when the switch is off. And we just kind of have to accept that in the transition region, we're not there for very long, and it's a bit of a mess. So like, treat the two steady states as important. And if you've got those right, the in-between, should fix itself. So when the switch is open, our switching loop is going around here. So that is the path our high-frequency current is taking. We'll still have some sort of DC current flowing out the V-out node, but for EMC purposes, we don't really care about DC currents. It has no real ability to radiate at DC. So that is our switching loop when the switch is off. When the switch is closed, we get a slightly different switching loop. So this is between our input capacitor, through the switch, through the inductor, and through the output capacitors. So both of those loops in each state of the switch have the ability to radiate, and they both need to be taken care of. The problem with this is you end up it's becoming more and more difficult to test EMC in that things used to have two fairly simple states. They were off or they were on. The problem is with this sort of architecture is if you change the ability of each loop's area, the amount it radiates depends on the duty cycle, because that's setting how much time the switch is in each state. So it's quite common that, like at DC-DCs, you actually have to test at multiple load currents if you're doing it properly, because if you're running with relatively low output current, the switch is open most of the time. So the critical loop is the loop that happens when the switch is open. If you're running at reasonably high output current, or ratio of V out to V in is relatively close, your switch closed loop becomes more important. The correct answer is you have to fix both of them, but it makes it tricky to test in that actually what your software is doing, if say this is powering a processor, can really affect EMC. But as a hardware engineer, all we can do is try and make it the best of all cases. There is one last mechanism which isn't normally considered in EMC, and because EMC cares about the interference between your device and other devices, it doesn't care about your device interfering with itself for the most part. That's a functional test. So what I've got here is I've got a board in cross-section, and I've got an input and output sort of electrolytic capacitor. And what I'm doing is I'm forcing my high-frequency ground current to return on layer 2. So these capacitors, we're looking at the ground terminal, and then it's going through a via into layer 2, back to the input capacitor, and back up to the outer layer where my capacitor is soldered. The problem here is it's actually quite rare that we're doing two-layer boards nowadays. Often they're multi-layer, up to sort of 20 layers is now becoming a semi-common occurrence sort of thing. And the problem comes of what happens if I have another trace on layer 3. Well, it's also going to have ground return currents, and I put my ground return currents on layer 2 because I have a nice ground plane there. My return currents can flow through it. The problem now is that I've got two different currents flowing through a common impedance. That plane on layer 2 has some resistance, and the current flowing through it is the sum of whatever the return current from my signal on layer 3 is and my high-frequency switch mode supply return current. The problem is that the voltage noise on that plane will be the sum of those two currents times the plane resistance. That voltage drop will then appear on both signals. Your power supply probably doesn't care, but your signal might be getting really upset that you've suddenly put 50 millivolts of noise at your switching frequency on it. So, and a lot of people think of it and go, look, I've got a ground plane, why is this happening? Like, I've got a shield, right? And the problem is that at the frequencies where your switch mode converter is running, the sort of your ground plane shields, it works if you have enough skin depths in the conductor that the two currents are effectively flowing through different impedances. If this was crazy high frequency, your switch mode converter would all be flowing on the top surface of layer 2 because of skin effect. And if your signal trace on layer 3 was really high frequency, it would all be flowing on the bottom of layer 2, and never the two shall cross. The problem is that in copper, even at something like 4 megahertz, which for a switch mode converter is reasonably speedy, the skin depth is 15 microns. So 5 skin depths will be 75 microns. That's thicker than you're going to have on your inner layer, even if you use 2-ounce copper. So you will have substantial switching components of your switch mode converter appearing on your high-speed signal. And your high-speed signal probably is a lot less tolerant of voltage noise. So, I've stood here and I've waffled and I've gone, here are the things that matter. And a classic problem with sort of when you see white papers on this is they come up with a contrived example and go, it should be better honest. And I felt you deserved better than that. So, what I've decided to do is I went and bought, I spent £3 whole on a DC-DC converter on eBay. And I went, right, I'm going to reverse engineer how this works. I'm going to lay it out properly, and then I'm going to show you the results. You know, as some efforts to prove that what I'm doing actually does make a meaningful difference. So, don't worry, you don't need to actually see any detail on this slide. This is the reverse engineered thing on the DC-DC converter. As an observation, actually, the prevalence of Chinese component suppliers is amazing for reverse engineering efforts, because I had a chip, this main switcher chip had the part number lasered off. Whereas actually it's surprisingly easy, sort of one of the big suppliers is JLC. Because I know what the part does, instead of wildly guessing data sheets, you can just go, right, I know it's a DC-DC, I know it's in this package, I know it's about this size, I know it's not made by TI or Analog Devices, I paid £3 for the thing delivered. At which point you actually only get 5 or 6 options left, and you go through them, look at the data sheet and go, nah, that's not pin 1. So like actually reverse engineering this was less than an hour for a part with lasered off part numbers. So I'm quite happy with that. But yeah, you can see that compared to like a 7805 or something, it is quite a lot more complicated. But then again, if you start having to bolt massive great heat sinks and fans to something, actually sometimes the trade-off works. You know, this is a 12 volt to 5 volt 5 amp converter. So, you know, if you were burning that in linear, you'd have 35 watts of heat to deal with. All of a sudden, put a few capacitors down doesn't actually seem that great. That much of a burden. So, let's go analyze our loops. So, when the switch is on, we have our input capacitor, this big electrolytic. We have our input switch, that's that Q1 at the top. We have our inductor, and we have our output capacitors. So that is the loop we care about, going around there. And hopefully you can see the sort of schematic to how it's been implemented in the real world link. And when we have the switch off, so in order to improve efficiency on this slightly, instead of using a diode that just starts conducting when the switch node tries to go negative, they've actually put a second FET in it. That's better because you don't have the diode forward voltage drop, dissipating power. The expense is you need a slightly more intelligent controller because you've now got 2 FETs to turn on and off, and if you turn them both on, you're going to have a really bad time. So like, you know, but we're now at the point that putting that sort of intelligence in a controller is relatively trivial, and we'll take the efficiency boost where we can get it. So this is kind of a key part, is when you take someone's schematic, if you're designing it or you're taking the reference design, work out where those loops are, because those are going to be the things that should be guiding your layout. So, 3 golden rules of good layout of an EMC. We want to minimize loop area, both on switch on and switch off. Those are our core mechanisms for H-field radiating. We want to minimize the copper area of the switching node. That's our core mechanism for E-field radiation. And it's a bit of a tricky one. For that inner layer coupling, most of the boards I work on are multi-layer. So I will try and keep all my HF current return path flowing on the outer layer. And that means it doesn't have a mechanism to couple to stuff on layer 3 anything like as easily. This sometimes ends up as a bit of a conflict in that keeping it on the outer layer sometimes results in a bigger loop area. The gotcha is that if you keep it all on if you have coupling between your layers, you're respinning your board most likely. If you have slightly bigger H-field radiation, if you put space for a shield on it, you can fix that radiation without respinning the board. In a professional environment, that's often more critical. One note that is important to know is if you have near-field H-field radiation, aluminium does very little to stop it. If you're doing magnetic shielding, you need something that's permeable. In the far field, anything conductive will do a good job of dealing with it. If you have near-field magnetic field, you need something permeable to actually attenuate it significantly. Aluminium will do a bit, but you need thicker than you think, several millimeters to get reasonable impact. So, here is the supply in all its glory. I've gone and taken all the parts off just for ease of seeing. And so what we have here, apologies. So, our input capacitor is way over here. Here is our switching element. Our inductor is here. And then it goes around the houses, and our 2 output capacitors are there. There's a device here. That is effectively our diode, our shorting to ground. So what this means is our radiating patch, our switch node, is across all of this section here. So now we've identified that. Let's have a look at the hot loop. So this is going input capacitor, through our switching transistor, through our inductor, background, through our output capacitors, and then at low frequency we'll be returning on the ground plane on layer 2. It's kind of why it's dotted on the bottom. That's quite a big loop area. It's using most of the board. It's using both layers. If we look at the hot loop on the switch off, it's a bit better. So we have, this is our switching FET to ground, through our inductor, through our output cap, and back to a common return. So we, set out with the task of can we do better? And this is the design I've come up with. So what we have here, looking at the same key points, here is our input capacitor, here is our sort of main switching device, here is our sort of short to ground, through the inductor, and back through our output capacitor. And then all of these are resolving themselves on the outer layers, and then it's just stitched to ground very well at the sort of common 0 volt point. So by the time it's got to that point, all our high frequency currents have sort of resolved themselves, the loop is closed, and therefore our high frequency current shouldn't be flowing through that via. The return path is not to the other side of that via, it's all on the outer layer. So, highlighting our switching node is here. If I bring the old design back in at roughly the same scale, based on sort of lining up components, and then compare the two, it's a bit better. It's not a world of difference. The kind of improvement comes when we start looking at the switching loops. And it is worth saying that this board is actually smaller than the original design, so when you're looking at things fractionally, it is a bit better. So when we look at our switch-on loop, we come, from our input capacitor, through our switching FET, out our switching FET, through our inductor, back through our output capacitor, and back to ground. When we look, and this is kind of, I had a bit of a play with this. This is kind of as good as I think you can do. Your main limitation at this point is actually component size. Although the pads are small, these sort of pink outlines are where the components start and stop. And you can see this inductor, although the pad's here, the inductor comes out to here. So these are very much butted up together and dominated by component geometry. and the loop on switching off, given the parts, that's pretty tight. So what have we done? We've marginally reduced the area of the switching node. We should get slightly better E-field coupling. H-field, we've got substantially reduced loop area, and sort of interlayer coupling within our board. It was a 2-layer board with no other signals, but in theory it should be better. All our HF loops are on the output side. So let's go make one. So this is the slightly stressful process of you buy a board, you put the whole thing on a hot plate, and then you try and pull all the components off in the time window between the solder melting and your components getting heat damaged. So it's a slightly stressful sort of 2 minutes or something, trying not to sort of accidentally launch resistors across the room. And, you know, the one on the top is from eBay, and the one on the bottom is mine. You can see marginally smaller, but, you know, overall similar sort of size, form factor, etc. So, went to turn it on, and suddenly went, that smells rather warm. So, this was at half load, and the device has a reverse polarity protection series diode on it, so dropping 0.7 volts. Yeah, half load, it hits 81 degrees within about 4 seconds of turning it on. So, you know, given that this was at half load, I'm not comfortable with this, so I took it off and shorted it out and just made sure I didn't plug the power supply in backwards. So, if we have a squint at conducted noise, measuring it on the output capacitor, you can see that actually we've got a bit of an improvement in it. I know we said we weren't really focusing on it, but for no component changes, you know, these are the same parts, I took them off a board and put them on another one, there is a reasonable improvement on that. And you can kind of see 2 noise sources on that. The relatively slow one is actually the switching period of the controller. So you can see the output capacitors charging up and the output capacitors discharging. And that's kind of the slow triangle wave with about 2.5 cycles across the thing. And then you get that high frequency noise, and that is the instance where the switch is turning on and off. So like the frequency of the triangle wave comes from your switching frequency of your controller. The frequency content of that spike at turn on and turn off comes from your rise time. So, if we plot a Fourier transform of this, these are the same graph. I've just switched over which line is at the front, because otherwise you can hide results behind the other graph and make it look like I'm always better. So you can see, you know, around this sort of 100 megahertz mark, the original, you know, we've got a substantial improvement. You know, we're at 10 dB a division, order of 10 dB improvement. And, you know, at the expense of, it is a little bit worse at low frequency. I confess I don't know where that comes from, but I think overall on the amount of, and this is conducted noise, that is probably a bit better, you know, averaged over all F. Now, radiated noise is a bit of a trickier beast to measure. There's kind of 3 ways you can do it. So, one of which is you can get near field probes. So, effectively, these form low efficiency. They form relatively rubbish capacitors and sort of transformers with the circuit you're measuring. So if we run out of here, pray this all works. Cool. So if we look at the original design, this is an E-field probe. If we go and hold it over the board, you can sort of see the different areas have different. Oh, sorry. I can't see it. Cool. Apologies. So if we look at the E-field, if we go over the switching node, you can see it increases a bit. If we go sort of over the transistor doing the switching, you can see it goes up a bit. If we go over the input cap, it also goes up a bit. If we go over the output cap, it also goes up a bit. So this is generally coupling in the E-field, we're forming poor capacitors. If we look on the output cable, you know, you can kind of see it's all fairly similar. However, if we put an H-field probe on, so this is looking at magnetic field coming out those loops, you can see that this is substantially worse. But it's only worse around the areas where our switching loop is. So if we look sort of on our input cable and around our input connector, which is here, you know, it's not too bad. If we go over to where our switching devices are, you can see it goes a lot higher. So these devices are useful for sort of debugging which part of your circuit is misbehaving, but it's not great for, where's my mouse? But it doesn't really give you anything quantitative. It's more a tool for working out which bits are radiating, which are doing worse. A slight step up, and it's only a marginal one, is a thing called a TEM cell. So what this is you have a sort of coaxial port here, a dummy load here, and these are predominantly designed for immunity testing. And what you do, sorry, I'll get the laser pointer back. What you do is you sort of shove a fairly strong RF signal in there when you're doing immunity, and it effectively becomes a strip line. So you've got your center conductor, if this were coax here, and ground plane top and bottom, and you subject your device under test to a field. These are not great for doing radiated emissions, but kind of within the context of a home lab is probably about as good as you're going to get. And so you place your device in, and you try and measure the coupled power out. And now I have the problem that, as I suspect with most amateurs, my shack is full of electrical noise, and it was an absolute nightmare. Hence the reason for taking over my sitting room one evening, and it was the place with the fewest electronic junk that I could find to try and drop my noise floor. How does this look if we have a look? So blue at the bottom is my noise floor. So you can see we've got a bit of breakthrough. So you kind of got FM stations and then either DAB or band 3 TV up at 200 and something megahertz. And you can kind of see that similar hump at 100 meg that we saw in the conducted noise is substantially improved in the relayed out one, so that's in green. One thing you don't see here, based on what I told you before, is you'd expect to see spikes at the switching frequency. You know, that is where most of the noise comes from, it's harmonics of your switcher. The reason you don't see this looking very spiky like a sort of comb generator output that you'd expect is that the sort of relevant standard for doing measurements of these frequencies specifies 120 kilohertz resolution bandwidth, and we have 116 kilohertz switching frequency. So as you sweep 120 kilohertz wide filter across frequency, it basically nearly always has one switching harmonic in it, which is why you don't get the spikiness and the resolution. So, you know, it's order of 10 dB improvement, so I'll take that. And then I was feeling a bit cocky at this point. I was like, I've done a thing, I can prove it. Let's go slap some limits on. So the red lines are limits from a standard called EN 55025 or CISPA 25 if you're American. And it's the standard for dealing with interference to radio things in vehicles. So if you're putting something in a vehicle, you're meant to be lower than these limits to not interfere with the radios, which is why you have all the sort of different limits for each radio technology. They've worked out a limit, and I was looking at that and feeling a bit sad. I'm not even passing on my noise floor most of the time. So what went wrong? Well, TEM cells are not really designed for emissions measurements. They're reasonably good for comparative, but the conversion from power that you measure at the port to what the field strength in the TEM cell is isn't really accurate. They're primarily an immunity test. And if you work out what the TEM cell's gain is if it were an antenna, it's stupidly high. So what that means is when you measure a low noise power at your input, it's as if your device is radiating an awful lot of power. And the problem you get is that coupling is nearly always, in a device that small at least, is near field. So you're making assumptions that your coupling is a sort of far field coupling, but then it's actually near field and all the maths is broken. So I was like, well, I'm pretty confident that my setup is repeatable and it's better. But if you want to do it properly, you go and grovel to your local EMC test house and go, can I have half an hour? So a huge thank you to Steve, Claire, and Peter, and the staff at DB Technologies in Cottenham for letting me go in and put such a hideous switch mode converter in their wonderful chamber. So let's see what the experts say. And once again, about 10 dB improvement. So measurement setup, absolutely not that great. However, you know, order of 10 dB improvement. And the red line you see there is the sort of from the generic EMC limits, so not the 55025. It's a generic 61,000 device that consumer devices get tested to. So I'm having that as a win. Thoughts on it? You know, we were trying to dash in at the end of a Friday. I suspect the input cable, looking at where it radiated as you rotate the device, I suspect the input cable was one of your big radiators. So we've got switch mode here. This is a load resistor. These devices are at the front if anyone wants to look afterwards, and a battery pack here. Didn't want to use a power supply. It has its own radiated emissions. And one of the big complaints with this board, I said I wasn't going to look at components or filtering. This board only has an electrolytic on its input. An electrolytic is not going to look like a nice high-frequency sort of return path at anywhere near 100 megahertz. It's going to look highly inductive, highly resistive. So that high frequency current on the input node is probably flowing all the way around that input cable. So it's slightly tricky to quantify in that I suspect some of the improvement you see at DB Tech is more coming from the conducted noise off the input cable rather than radiated straight off the PCB. And if we put the results on top of each other, yeah, you know, similar shape-ish, you know, but both generally agreeing on the improvement. So why is this still a problem? Well, let's take the limits from DB Tech, you know, proper calibrated results, and put the EN55025 limits on. Bearing in mind that the one I relayed out was marginally failing, but very marginally, sort of less than a dB, given that that's the spec for not interfering with radio systems, oops, like, this is a problem. Not all devices that interfere with radios are junk. It is simply that the commercial standards that you have to pass do not envisage you having a very high sensitivity receiver. So to upset you even more, I decided to add to this graph the field strength you need for S9 and S1, renormalized for 120 kilohertz bandwidth. Oh dear. Given that a device with the orange trace is marginally legal, marginally not quite legal, but if it was a little bit better, it would be. Yeah. And this is 3 meters away. So, you know, if you go, yes, it will drop off with distance, but it's only going to drop off by sort of 6 dB for every time you double the distance. So this was at 3 meters. We've got an awful lot of walking away to do before we're getting an S1 noise floor. So hopefully that was a useful insight. And the only thing I would say is don't believe everything you're told. So like most of the reputable switch mode power supply manufacturers will give you reference layouts. So yeah, you can just about see that. So in this, they've tried to take all the pain out of it. They've put the switching inductor, they've put the high frequency caps all in a module for you, which is kind of this BGA thing in the middle. And they've gone, right, you slap on some output caps, it will work because we've controlled all the high frequency performance. And so here's all the ground pins on a device. Here's our V-in pins, and our V-out pins are split across the device. But anyway, they've said to put the caps here. So we have our V-in pin, and it returns to the ground pins on the device. And we have our V-out caps here, and it doesn't. Like, turn them around. Sort of, you know, if they put these, you know, going from here to this plane, that would be substantially better. Like, just because, and like, they've written this in a datasheet from a reputable company. So always treat the sort of recommended layout with just a pinch of salt, because it seems to often be quite poorly done, and I've seen much worse offenders than this. So, this is the last slide I promised, because Graham's looking at his watch and wanting to get some Q&A in. So, nearly all energy is at the harmonics of the switching frequency. It's coming from that rise time. That is what's giving you your high frequency noise. If you can, go up your switching frequency as much as possible. Like, it will reduce your efficiency a little bit because you're switching that switch on and off more times, so you have more transitions. But it means all your harmonics, instead of being spaced 100 kilohertz apart, it's not that hard to space them 2.5 megahertz apart, at which if you can control your switching frequency, you can start picking it to like miss amateur bands. And also you'll have fewer harmonics before your filtering starts getting rid of them. Minimize the area of your switching node, that's E field. Minimize the loop area of both switching loops, switch on and switch off. And if you are doing multi-layer design, try and keep your currents on the outer layer so that the sort of currents going through your board and coupling into everything else in your design, you know, is generally low frequency DC stuff. That is an absolute whistle-stop tour of quite a lot of EMC layout, but thank you all so much for your time, and enjoy the rest of the convention.
Thank you, Dan. We have probably time for 2 or 3 questions. Questions, anyone? Dear, oh dear, you've told them everything. No, here we are.
One question. M0WTP. I've worked on switch mode power supplies on basically what was a spectrum analyzer. What improvement do you get from multi-earth planes? So I'm talking about an analog earth, RF earth, and taking them back to a star point.
So that's a question which is like each circumstance is different.
Yes.
Generally, if you're at a high enough frequency that your return currents will follow underneath your track and be, you know, and you've got enough copper in it that you can have your 5 or 6 skin depths and they do not couple. For the most part, if you only have high frequency noise, it doesn't make that much of a difference generally. Often designs with poorly implemented split ground planes are often worse than just tying them all together because you've upped that loop area. You can get a difference at low frequency noise if you're being very careful, but if your concern is high frequency, like the top and bottom layer of layer 2 doesn't make that much difference. But the problem is, like, it's a specific thing to your design and what frequency content you have in your thing. But as a guide for beginners, and obviously, if you're getting advice on how to design for EMC from a 45-minute talk, you know, if you're doing it properly, please simulate it. You know, as a most part, I've seen more designs broken by split ground planes than I have by them fixed.
Right. Okay. Just it seemed a sort of simple get out of jail one, but obviously it isn't.
It's not that straightforward,
No.
I'm afraid.
Thanks.
Given that all you've changed here is PCB layout, and presumably not a significant, well, no change in bill of materials cost.
Correct.
Why, I guess maybe we can excuse the AliExpress specials. Why is it that certainly in published data sheets, we see this non-optimal so often? What is it that makes it more expensive to do it correct? Or is it just a lack of good EMC engineers?
I think it's a two-parter. Certainly I've seen on high-volume products, you do... Ow. Am I still... So, for some parts, when you take things to high-volume manufacture, you sometimes get weird design rules. Like, sometimes in high-volume products, they specify stuff like all electrolytic caps must be the same way round. This allows for very easy sort of inspection of the panel. You know, the negative stripe is always at the bottom for every panel on the board, and they panelize multi-stuff up, which might be an explanation for why on the sort of eBay design, the caps are, rotating one of them 180 would have fixed quite a lot of stuff. Sometimes it is just sort of, you know, lack of understanding. Sometimes it's like people don't care half as much as you do. Like the EMC performance, you'll just get like, sometimes you'll see a single bullet point that says low EMI, scroll down. I can't find a single graph. Like when you make a switch mode chip, you care about efficiency, and good layout for the most part does not really affect efficiency. In fact, sometimes good EMC performance makes it worse because you're making it harder for high frequency currents to turn on that switch on and off. So it's not in their interest when 90% of your customers, their EMC requirements are good enough is good enough, and good enough is not that great.
Okay, one last one.
Basically mean we should throw away all the switching power supplies out of our shacks?
Absolutely not. Like, the alternative is we live in a world where, you know, we've got 50 kilos of metal to heat sink everything. Like, they require more careful handling, but there are tricks you can play, like, you know, if you run at a fairly high switching frequency and pick it so your harmonics are out of band, and then say, if you use a switching regulator to go, say you have a 3.3 volt supply, you can use like a switching regulator to go from 12 volts to 3.5 volts, and then put a linear regulator after it, which will reject an awful lot of that switching ripple better than you can with like LCs at those kind of frequencies. And the faster you switch it, also, the more chance your filter has to roll off. Like a filter with low DC resistance, you're not doing with like a 10 hertz cutoff frequency. Whereas like if you're switching at 4 megahertz, you can have many dB of attenuation, even just with sort of, you know, ferrite beads and a few input caps. So all I'm saying is they need to be treated with a bit more care, but it can be done. And here are some of the ways that the layout can affect that. But this is by no means a definitive tutorial.
Okay, Dan. Am I on? Thank you very much. I suspect everyone will go home and buy a £3 eBay regulator, take it apart, put it back together, and tomorrow they'll have no RF interference in their shack. Well, I think that's what I learned from it. No, seriously, a great talk. Thank you very much indeed. And if we can all show our appreciation.
At the convention, there's one man in charge who's planning it all and everything, and it's this man here for the first time. Pete Joyce, M0OFM, you are the convention chair. Thanks for joining us.
Thank you, David.
My first question, into day 2, how's it going?
Very well. I've really, as someone that's new to the role, I had lots of worries, a few sleepless nights, I'll admit that. There's that whole horrible fear that it won't be convention and the things you've done just won't gel together. I have really enjoyed convention this year. Lots of really positive, happy, smiley people in the room. Lots of youth here, lots of ladies here. Really good conversations, really good feedback from the delegates. And really, I think the members are really enjoying this. I think we got the mix about right this year. It's a mix, as you know, comes from a lot of hard work. Lots and lots of volunteers, putting lots of time in, lots of planning. And it's lovely to see that come together for the members. It's been a real pleasure and honour to say that. And you say I'm the person in charge. I'm not. I'm just.
Well,
I
you're
am
the
a
team
nominal,
leader.
We'll go with team leader. I don't want to be known as the person in charge. I think team leader because the team I just really want to acknowledge that there is a massive team behind this. There's a lot of volunteers give up a lot of time to bring this together for the members, and I think that what we see in convention and what we're seeing in person this year and on the live stream is just the passion of the volunteers to deliver for the membership as a whole.
Can I take us back a year when actually Steve Thomas, who's been the convention chair for several years, said, I'm not going to do it again, I want someone to step forward. So did you immediately, were you kind of thinking I might like that role, or is this something you thought I'd like to make a difference? Because you're a volunteer yourself, aren't you?
Yeah, no, I am a volunteer. I think, like everyone, when Steve said he was going to step down, I think we all looked at each other.
Yes.
And I remember being sat in the room, and I remember there was like whiplash around the room as people looked at each other. And Steve was quite cryptic because I know that the venue is a topic, and we have to look at that every year, and I know it is looked at every year. And there was that feeling that, is Steve saying something? Is there a subliminal message in this? Is Steve stepping back because there's something as the members we don't know something there? And no, I didn't. And they put out the advert and they said we need someone to do it. And I said, you need someone. You know, this isn't a role for me. And I think there's a lot of people out there that feel that about volunteering with the RSGB. It feels very daunting to volunteer. And so I didn't put anything forward. And then there was another call. It was like, really, we want people to apply. So I wrote an email to Steve and I just said, look, Steve, I said, you know me, I've been at convention for 11 years. I did my foundation and my full licence exams when we used to do exams at convention. I won I think it was the Novice Constructors Championship many years back at convention. And for those that know me know that JJ was inspired through convention. So I have a very deep passion for convention. But I can also be quite critical. And
so that's what you've got to be, isn't it, Rick? Because the minute you're not critical, really, and then maybe you don't care, you don't maybe change things that need to be changed and improved.
Yeah, and I wrote to Steve, I said, look, I've criticised things in the past, and I just feel that I need to put my head above the parapet and be fair and say, look, actually, if you can't find anyone, do. And then Steve and I had a long chat. And chat with a number of other people. Steve put me in contact with various other people around the convention, and we had a chat. And in the end, Steve said, would you like to take it on? And therefore I was invited by Steve and the board to take the role on. And I hope I've done well. And the proof in the pudding will be as we move forward from this point.
A lot of people maybe that it's not practical for them to come here in person, but they're looking at it on the live stream. Of course, that's only really a small part of actually what's going on here, isn't it? Just can you give a quick overview of what there really is at the convention, which starts on a sort of Friday, doesn't it, actually, and goes through right till this afternoon, later this afternoon?
So, yeah, I mean, we started on Friday this year. One of the things I'm keen on is practical, so we brought in a new workshop format on the Friday. We extended through Martin Baker and his team at the NRC have been absolutely brilliant and facilitated the tour at the MRC, and then Patrick did his talk on Leo stuff, which was really good. So that goes Friday something and then into the welcome buffet in the evening. So already by the time we get to Saturday morning, when convention proper, as some people would say, kicks off, there was already a good feel and a good buzz, and we was on a roll, which really helped. Saturday, obviously, we've got what you got on the live stream is very limited, really, in terms of talks.
We just take a selection of talks.
Yeah,
really,
and
it's
just a taster, isn't it? It's just a little bit there. So you have all the talks, you have a lot more freedom to move around. But I think the thing that we have, and the one thing that I've really tried to emphasise, is the community. And yes, I understand why people watch on the live stream. I understand it's very difficult for people to come. I understand that there are various reasons, lots of reasons that we're all aware of in life for why people can't be here. But I think the one thing you get when you get here is the community, and not so much going to the talks, it's the conversations in corridors, as we say.
Yeah.
It's the people you bump into. And then when you do go to a talk, you're with a group of people that are seeking the same as you. They're in the room because they're seeking a knowledge or a conversation around something you're interested in. Whereas sometimes when you watch on YouTube or you watch a live stream, you're not getting that intermix. So
No.
I think that's
you don't get that feel, do you?
No,
the same? No.
It's very hard, and it's very hard for us to. We're aware that there are people that cannot come to convention. I'm very aware of that.
Practical reasons.
And the live stream, we try very hard to bring people into that conversation, but there are practicality limits and logistic limits to where we can get with that. So
we're into the first or the morning of the last day.
Yep.
A third day, we should call it, really, because there is much more happens on the Friday now than there used to be. Is it fair to ask you little changes that you might make for next year, little things yet that you've seen, and now you've been part of that decision-making process and planning? Anything stands out for you that you might want to change?
I don't think there's anything that I would change major. As with all these events, there are things, there's a lot goes on in the background. There's a lot of moments when I've run around and I've gone like that. That's to be expected, so some of those things I would change. What I would like to see is I'd like to see more input from the members. We this year again, and in previous years, the members are asked to contribute. I'd like to see more input from the members. I'd like to see it more member driven. So if if you're watching on the live stream, you think, oh well, I didn't come to convention this year because the programme didn't have X, or it doesn't cover this, or it doesn't cover that. Please just reach out to the convention team and tell us.
We've actually got a slide which we're going to put now on the screen, a link which people can see to contact, which is rsgb.org/convention. And you really are looking for feedback, aren't you?
Yeah, no, I really feedback, and whether it's good or poor, I'm not really worried. But I can't change anything if I don't know what members need changing.
So feedback, but constructive. There aren't enough talks of this, or I'd like to have been that, or whatever.
Yeah. And even the practical workshops, I'd like, we've done antenna building this year, we've done microcontrollers, we've done AI programming.
And they were all sold out, weren't they?
And they were all sold out, and they were funded by the Legacy Fund, who was extremely generous, so we managed to keep them at an affordable price. And they were not so much the Friday workshop, but certainly the microcontroller on Saturday and the antenna workshop this morning are very entry level, if that's the word. I'm not sure it is the entry level, because
if you don't know.
I think, as someone said to me at dinner last night, I've been in the hobby for 40 odd years, and I started doing the new, I've just started looking back and doing foundation because I'm doing training, and I'm relearning the hobby. I'm relearning things that I'd forgotten and I just took for granted. So I think even the fact they're entry level means you can still go and learn from them. So I think that's really important.
Yeah, I mean, the
But yeah.
microcontroller, for example, a lot of us may have soldered on a chip or a microprocessor or a microcontroller, but never known how to program it. And I know that, particularly that workshop, I'd love to go myself, but we're working on this. You know, that really does give you an insight into programming, doesn't it? For example.
It does. And one of the things in the microcontroller community is we know that 95% of code is ripped off or thereabouts or something like that. Someone told me the figure. Not ripped off, that's the wrong term, isn't it? It's a careless term. Is borrowed.
Yeah.
So we talk
Well,
about borrowed code.
But not
and
understanding
yet
what it
people
does.
don't understand it. So, and I think that's what was brought in the controller workshop, is understanding what you're doing. And I'd like to see more of that sort of stuff, and I'd like to see that more with practical. I mean, there's this whole conversation that hovers around that, we're all black box operators. But who has the conversation that goes, well, do you actually know how an oscillator works? Do you know how the RF amp works? Or do you know that? So there's that level. And then, of course, there is at convention, there is that level that people that want really exceptionally technical stuff. You know, Hans is here, Mike's here from Flex Radio. I mean, Hans is after dinner speech last night when he was saying about this 9-month journey he had with the QMX. You know, I have to admit I'd have quit a long time before him, but you know, all credit to it.
There's lots of stuff at the convention this year. Thank you for all the hard work you put in.
Thank you, Tom.
I don't know if they've asked you yet if you're going to do next year, but I hope you may be tempted. But don't commit now.
I'd be tempted. I'd be tempted.
Give it a couple of days rest first. Pete Joyce, thanks very much for joining us.
Thank you, though. Thank you for everything you do.
Thank you. So now, actually, we're going to GB3HQ, and not only GB3HQ, but as it happens, Pete's son, JJ, is working on GB3HQ.
QRP station. Again. We'll be calling you in 5 minutes. Over. Please call in 5 minutes. Over. GB3HQ got CQ. This is Golf Bravo 3 Hotel Quebec. Golf Bravo 3 Hotel Quebec. Special event station for the RSGB convention here at Kent Hill, Milton Keynes. CQ. CQ. This is Golf Bravo 3 Hotel Quebec. Golf Bravo 3 Hotel Quebec. Special event station for the RSGB convention here at Kent Hill and Milton Keynes. CQ. CQ. This is Golf Bravo 3 Hotel Quebec. Golf Bravo 3 Hotel Quebec. Special event station for the RSGB convention here at Kent Hill and Milton Keynes. CQ. CQ. This is Golf Bravo 3 Hotel Quebec. Golf Bravo 3 Hotel Quebec. Special event station for the RSGB convention here at Kent Hill and Milton Keynes. CQ. November Fox, go ahead.
2 Echo 0 Mike November Fox. You're at 5 and 9:59.
2 Echo 0 Mike November Fox. Thanks for your call. My name is JJ. Juliet. Your report on the next over. So how do you copy? This is Golf Bravo 3 Hotel Quebec. Over.
Yeah, good morning, Joseph. My name is Nick, November India Charlie Kilo, and your report is 5 and 9:59.
Thanks for the 2 Echo 0 Mike November Foxtrot. Thanks for the report. Your report is 5 and 9:59 at the RSGB convention. Thanks for your call. 73 Golf Bravo 3 Hotel Quebec. QRZ. QRZ. CQ, this is Golf Bravo 3 Hotel Quebec. Golf Bravo 3 Hotel Quebec, special event station for the RSGB convention here at Kent Hill and Milton Keynes. CQ. CQ, this is Golf Bravo 3 Hotel Quebec. Golf Bravo 3 Hotel Quebec, special event station for the RSGB convention here at the Kent Hill and Milton Keynes. CQ.
Mike 0 Delta Victor Zulu.
Mike 0 Delta Victor Zulu. Thanks for your call. My name is JJ Juliet. You will report on the next over. So how do you copy? This is Golf Bravo 3 Hotel Quebec. Over.
Yeah, Golf Bravo 3 Hotel Quebec from Mike 0 Delta Victor Zulu. Very good indeed. Lovely signal. You're 5 and 9 here. And the name here is John, Juliet Oscar Hotel November. And located up in the northeast of Scotland, just south of Fraserburgh. Thank you for putting on the station. Thanks for your call and wish you all the very best for the rest of the day. 7 Cs.
Mike 0 Delta Victor Zulu. Thanks, John. Thanks for the report. You are 5 and 9:59 at the RSGB convention. Thanks for your call. 73 Golf Bravo 3 Hotel Quebec. QRZ. Am I doing well? QRZ. CQ. Station calling.
November 5 Delta November.
Oscar November 5 Delta November. This is Golf. Thanks for the call. My name is JJ Juliet. Your report on the next over. So how do you copy? This is Golf Bravo.
Hello and welcome to Sam, who is the RSGB Youth Champion for Scouts, Guiding and Cadets. Sam is here today to talk to me about Jamboree on the Air and what's going to be happening next weekend. So Sam, for people that may not have heard of JOTA before, can you give me a little bit of information about what it is and most importantly when it's going to be taking place?
Yeah, of course. So Jamboree on the Air is a scouting event that's been going on for years and years now. It's the third full weekend in October every year. So obviously this year that would make it. Next weekend it's Friday through Sunday. Most stations try and operate during the day, but there's no restriction on doing so. It's the whole weekend. The whole goal is basically to get lots of people talking to lots of scouts. There's lots of scout groups that are getting on the air. We've got a list of, I believe, almost 20 now, and there's more coming in all the time. So it's basically try and get everyone on the air and just try and get everyone talking, really. There's no scoring system particularly, although there are, of course, stations that everyone wants to try and get. So Hotel Bravo 9 Sierra over in Switzerland and GB2 GP are very popular, but it's just a game of trying to speak to everyone, really, if you can.
Brilliant. And you mentioned GB2 GP there, which is the Scout headquarters over in Gilwell Park. Yeah. And I believe you're going to be joining them there next weekend.
Yes, so I'll be attending Gilwell from Saturday to Sunday next weekend, helping just generally run the station, help with the activities. So there'll be a couple of HF rigs, there's some satellite going on, they've got some kit building activities. It looks like it's going to be a very well-rounded weekend. This is my first time attending Gilwell Park specifically, obviously for a radio event, and I'm very much looking forward to it. It sounds like it'll be an amazing opportunity. By the sounds of it, there's a good number of young people that come through it, and there's of course lots of people that we'll end up speaking to are seeking us out, so hopefully lots of good fun with that.
Brilliant. No, it sounds like a really exciting event. And if people are watching this at the moment and wondering how to let you know what stations they may be operating, what do they need to do?
Yeah, of course. So there is the RSGB website, which is listing all of the stations that we've got. So that's available, I believe you just, RSGB JOTA. There's not a direct link, I don't believe, but it's off of the scouting page on the RSGB website. and to get added to it, they just need to send me an email at youthchampion.scouts@rsgb.org.uk.
Brilliant, and they'll need to send information on the call sign, any details of when they might be operating, any other sort of information that they can send across to you?
Yeah, just as much information as possible. So the basics that are helpful are call sign, band at least, preferably some modes as well, and rough times they'll be operating, or even just days. Just the more information the possible, because it gives people the chance to look out for them. Although hopefully they'll see them on all the spots, and we'll get lots of contacts for everyone, hopefully.
Brilliant, yeah, and that list is on the website, which is rsgb.org/JOTA, and on the right-hand side of the menu, you'll be able to select JOTA stations on the air. And are you taking details right up until the end of the week?
Yeah, so obviously the sooner the better. I will try and forward details on for as long as I'll be allowed to. Personally, I don't oversee the uploading of them, of course, but I'm hoping that we'll get them all throughout the week, and obviously the sooner the better, because you'll get higher up the list.
Brilliant, yeah, and the more people that are getting in touch, the better. It's a great opportunity for young radio amateurs to get on the air, and also encouraging everybody at home to get on the air and welcoming them to amateur radio as well.
Yeah, of course, and obviously I'd fully encourage anybody who isn't doing so with a scout group to get on the air, do so. You don't have to be a scout group. Of course, if a scout group local to you would like to, it's a perfect opportunity to get some youngsters involved, but it's not at all a requirement. It's very nice for them to just get on the air and speak to somebody. So if you've got access to, there's even a fair number of groups doing VHF, UHF, local repeaters, or if you've got an HF rig, just try and get on the air and speak to them.
Brilliant, and just sort of one last question. YOTA month is taking place in December. Can we expect to hear you on the air in December?
Yeah, personally I'll definitely be on there. I'm hoping to get some time with the GB25 YOTA station that we've got going on. I try my best to compete in the YOTA contest every year. I'm hoping to do so with our new university club that I'm part of, so we'll hopefully be promoting some new youth activity that way. But I'm very much hoping as well that these scout groups who have now either got radio stations themselves or have created contacts with them will be able to do something for that as well, because it's a nice, more indoor activity they can do over the colder months.
That's great, some really exciting activity taking place for younger radio amateurs at the moment. Lovely. Well, thank you very much for joining us, and thank you for your time.
Of course.
Well, we're now going to take a look back at the historic ARIS contact that happened on 5th of October 2024 with 100 members of Girl Guiding in the presence of HRH, the Duchess of Edinburgh. It was a very special day that inspired many of the girls to realise that they actually enjoyed STEM activities. It was also a springboard for the RSGB to continue demonstrating amateur radio at various Girl Guiding events this year.
So today we've been here at Brooklands Museum talking to Sunny Williams on the International Space Station with another ARIS contact. It's gone superbly well, really good response, got 16 questions through, including a greeting message from Her Royal Highness, which as I believe inspired the girls quite heavily, and it would be great to see the Duchess take the time to participate in something as special as this, even though it was a rushed 10 minutes contact.
Today was fantastic. I've loved every single minute of it. Seeing the Girl Guides on stage with Her Royal Highness was a really special moment, and having Sunny speak to us from the International Space Station flying overhead was absolutely phenomenal. I don't think I've ever heard an astronaut speak so casually and so open with our young people today. So yeah, all in all, top tier day.
Very important from an RSGB point of view, because we are interested in getting young people into amateur radio and then into engineering and STEM, which is what this day was all about.
today I think it's fantastic. I mean, seeing the engagement in the room at the moment, you might not be able to hear on the microphone, but everyone's tapping away with Morse keys. People had fun as well, seeing the CubeSat we have here, and of course, especially with the International Space Station contact talking to the astronaut. I think everyone's really enjoyed that today.
I thought it was great to hear the Girl Guide's questions to the astronauts, and there were some really interesting answers.
I think today's been a truly wonderful experience for the girls. It's amazing to have spoken to an astronaut that's not on this planet, and something that I think people will remember, particularly the girls, for a long, long time. I know I will. And I think it inspires a new generation of youngsters to come forward and proceed with these STEM technologies.
It would take 9 months for somebody to arrive with an exchange to change a part for us. So
today has been a fantastic day and almost a little bit nostalgic, because I was a Girl Guide myself, and so thinking back to how I was inspired back then, and hopefully now doing my little bit to try and inspire girls to get involved in science and engineering like I have.
Today's been really lovely, seeing so many young girls getting involved with learning coding on the microbit, more about Morse code, playing with Morse keys and just enjoying learning.
It's been a really inspiring and humbling day today, seeing so many potential young engineers and technicians coming past us building the Morse keys, just the enthusiasm, the skill actually in a lot of them when they were putting them together, and immediately wanting to send their names and have their certificates and just enjoying the whole day.
I think today's been a really great opportunity to talk about my passion for radio and to hopefully inspire the Girl Guides to go on and do their own radio stuff in the future.
Today has been my best day at Brooklands. Having worked here now for a few years, all this hard planning that we've done recently to get to this day, and the moment when the contact happened, the hairs stood up on the back of my neck like somebody told me it would, and the moment of history that we've made together with those girls for Girl Guiding, with the Duchess here, we couldn't ask for more. They will remember this day for the rest of their lives.
Amazing. Inspiring. Fascinating. Scientific.
Welcome back to the live stream. Great work being done there with Girl Guiding. We've just got time to have a quick look at our programme for today. Here it is. So we have in a few moments radio industry STEM and engaging youngsters. At 11:30, the biggest nerd she's ever met, my adventures with TV's Hannah Fry. At 1:30, polar modulation SSB, high performance and efficiency at low cost. At 2:30 was that solar cycle 25, what did we learn? And then finally at 3:15 we have the closing remarks from Bob Beebe, our president, GU4YOX. So lots still to happen here on the live stream, plus of course lots of interviews and things. We'll be going to visit the special interest group as well around about lunchtime. But now we're going to our next talk, which is Radio Industry STEM and Engaging Youngsters, with our RCF Trustee Andy Webster, G7UHN.
Andy is a communication engineer who's worked for over 20 years in research and development, systems engineering and support to science operations. His professional experience in communications spans across the spectrum from shortwave radio in remote regions through to cutting-edge broadband satellite communications. He was drawn into communications engineering by an early interest in amateur radio and is now an active volunteer providing STEM opportunities for young people. He's a trustee of the Radio Communications Foundation, the RCF, which is a charity, as I'm sure you all know, that provides support to people and projects encouraging interest in radio communications and its associated careers. This morning, he will explain that amateur radio in the modern world is about understanding technology, the application of science, computers, programming and problem solving to achieve exciting results. It's a hobby with many facets, as I'm sure we all know, and activities including electronics, satellites, experimentation, construction, systems thinking, acquiring knowledge and learning new skills. It has a rich toolbox that can inspire people. In his talk, Andy will give examples of how radio technology can be used to engage non-radio amateurs in science, technology, engineering and maths, and as well as how it can connect people to the invisible world of the signals around them. Andy, over to you.
Thank you. Good morning. Right, morning everyone. Thanks for the introduction. I won't labour too much on that, because it's a familiar story. It's probably a familiar thing to most people around the room. I got interested in electronics and things I was around about sort of 14. I started to think about what I might be when I grow up, what I was interested in, and somebody put me in front of amateur radio, and there was blinky lights and scratchy noises and voices from far away, and I was hooked because it was a good excuse to start melting solder and building things and all that exciting good stuff. So I became a radio amateur, and then without kind of thinking about it, that interest, having a hobby that was basically electronics, that pulled me into being a comms engineer. So I've been doing this for 25 years. It's taken me all over the world, done lots of interesting things. There are moments of my job, more than moments. There's lots of parts of my job where I love it. I really enjoy my job, and so that thought that it was my hobby that started when I was in the teens, that pulled me into a job that I really enjoy, that led to me becoming a STEM ambassador around about 2016, because I kind of wanted to give some of that back and sprinkle some of that experience in front of young people of a certain age and give them the opportunities to go, oh, that's exciting. Oh, that's quite interesting. How do I learn more about that? And point out this link between hobbies as an extracurricular thing that you might do that enhances your CV and takes you into a career that you really enjoy. I should point out that the views I express in this presentation are my own. The RCF Trustee thing has been mentioned, but this is not an RCF presentation. This is just me as a STEM ambassador looking to reach out to like-minded folk. Okay, so what I'll do is I'll talk a little bit about industry and the skills shortage. I won't labour too much on that because it's probably a familiar story, but I'll make some links to education and the curriculum and try and sort of put that picture together as I see it. I'll talk a little bit about what's changed since the old days, because there are some new things that I think some of us probably take for granted that are actually really exciting in an education setting. And I'll talk about what you can do to sort of be a part of moving the needle on this. I'll talk through 3 outreach activities that I've done with young people that will hopefully give you some food for thought as to things you might take away into other STEM outreach situations. Okay, quick poll in the room. How many STEM ambassadors in the room? Okay, right, what have we got? Okay, we've got five or six STEM ambassadors. That's pretty good. Who's spoken about RF to like young people as a STEM ambassador? Not as a STEM ambassador, as a club. Yeah, okay. There's quite a few people speak about RF to maybe students, maybe the general public. Okay, so we like doing that. Who's got a spectrum analyzer at home? This is the most hand count of all of the questions so far. I was expecting this to be the least. Okay, I got another challenging question in a minute. Right, I wanted a picture of the old HP 8591 that you've got in every RF lab in the world, you know, like a bird watt meter. But that was the one I found off Wikipedia with the appropriate credit. Okay, who's got an SDR receiver at home? Right, this should be pretty much everyone, right? Everyone's got an SDR in their pocket now. Okay, who's got one that covers up to 2.4 gigs? Oh, Okay, right. This is a great crowd. This is so much better than I thought. Okay, cool. Right, we'll come back to these. Right, industry and the skills shortage. You're not necessarily meant to read all the text on this slide, but I don't think it's a surprise that you don't have to go searching very far to find lots of talk of the UK skills agenda. Science and technology has a shortfall in the talent pipeline. Not so many people choosing to do engineering and technology and going into university to fill this kind of talent gap that we have, that the UK has kind of declared its intent to be a science and technology superpower. Okay, but we haven't got the talent coming in. We haven't got enough engineers, so we need to encourage more people into engineering. And that's all about artificial intelligence and quantum computers and all of these cool, sexy things that everyone's talking about in the news every day. Okay, but it can't all be about AI and quantum and apps. But that's where a lot of the press is. So we've got a bit of a challenge. Radio is a critical technology. This is what connects most things together. Okay, and we're absolutely addicted to it. We use it all the time. We know this, but most of the general public have forgotten. Okay, since the antennas disappeared off these things. Okay, where's the antenna? People would tell you it doesn't have one. Of course it does. It's just hidden. People don't want to see the antennas, but they do want to use them. They can't get enough of it. Radio. If you say radio to a room full of students and you say, who uses the radio these days? Who uses the radio? No hands. Maybe the teacher at the back. Oh, I listened to Radio 4 on the drive in this morning. Yeah. Okay. So radio is viewed as old hat. I would say there's not necessarily really a radio industry now. So maybe the talk on the title on the program was a little bit misleading and pulled you in. I would say radio is part of a technology mix in systems these days. That's the more common use of radio. It's usually alongside computing and networking systems. That's certainly been the story of my job. It mixes hardware and software. It's not a software job. It's not a hardware job. It can be both. It's a domain. It's something that links things together, and there's lots of different parts of it. So I would say radio isn't so much a technology with a career path. I would say radio is a niche skill, and there's sustainable demand for that skill well into the future. I'd also point out that there are lots of other skills shortages in industry, and so radio as a technology, as an interest, that kind of has to compete a little bit or complement other things. So you can't sort of say, right, get interested in radio and you're going to be a radio engineer and that's going to be your future. It's definitely a mixed landscape, so you kind of have to show its part in other technologies and why it's useful, and then point out that lots of people don't know how this works, and that's fading off. Okay, so let's switch back to the STEM thing. Right, how do you introduce radio? Wireless technology, I might call it. I don't actually use the word radio very often when I'm doing STEM stuff. I tend to use the word wireless because that's now what people are kind of more familiar with. Oh, I like Wi-Fi. I like the internet. That's wireless, isn't it? Radio, no one listens to the radio anymore. So ask yourself, if you're doing STEM things, if you want to get in touch with your schools, if you want to become a STEM ambassador, if your work is interested in doing STEM outreach and things like that, think, right, what is the purpose of this engagement? Is it amateur radio recruitment? Or is it STEM outreach? And they're kind of different. They probably overlap. There's definitely a Venn diagram there somewhere, which I was thinking about last night, thinking, oh, shall I sketch this out? But I think we've kind of probably all got our own thoughts about how the two are kind of symbiotic. That's my own story. That's how I got into my career. There's been some great talks this weekend so far about amateur radio recruitment and about sort of changing and modernizing our image and our outward presence that the world sees, and how we can pull people into amateur radio for the growth of the hobby, which actually fuels more people working in these things. Amateur radio is a rich toolbox. There are loads of skills and experience you can build up in this hobby, but there's definitely an image problem. We know this. We're talking about it this weekend. That's great. So there's lots of really good work going on to try and solve that problem. But in the STEM world, you kind of got to recognize right now, radio is old hat. Wireless technology? Okay, yeah, that sounds useful. Okay, one last thing about the amateur radio thing. I won't label on this because I think I'm preaching to the converted. We all know if you go into a school and you say, "Hey, I'd love to do some amateur radio with your STEM club," that's a tough sell, right? No one listens to the radio these days. I can just use my smartphone. I can call anyone around the world, whenever I want. I can just WhatsApp, Skype. Yeah, that's that thing my granddad used to do. You type okay, what is amateur radio anyway? You type it into Google. These are the images. It's people sat, in front of loads of expensive equipment and radio, old-fashioned radios with dials, holding a microphone, talking to people. That's our image. We've got to really work on that. And so I would say, don't sort of lead with that. Think about what is the purpose of your STEM engagement. What are students expecting from a STEM event? They're interested in careers. They're hoping that people are going to show them something that has got a career path and that is exciting and they can get into and learn about and is going to be well paid and in demand and give them job security. So CW contesting, that's a stretch. And don't get me wrong, my favourite bit of amateur radio is sat at the tail end of contest by the water down on the south coast with a bit of wire and 5 watts trying to pick up the last remnants of people as they're getting desperate at the end of the contest. But that's not what I lead with on STEM. Okay, so people are looking for finding links to the skills gaps and tomorrow's jobs. And amateur, that's a risky word in a STEM thing. They want professional stuff, right? This is about careers. So find a way to start conversations that people recognize as important. And these are the conversations you might be having with the students when you're starting to do an event, but they might be the conversations you're having with teachers or other STEM professionals and saying, hey, I've got some really good stuff here. I'd love to bring this to your STEM program. So these are the kind of, this is my suggestion on ways you might start those conversations. Make links to things like Wi-Fi, 5G comms, space. Everybody loves space, right? That was definitely how I led for the last few years when I worked for a space industry company. And draw attention to the spectrum skills shortage. Okay, so right, with that in mind, I would point to this as another thing of how you can start conversations with schools and teachers, the 8 Gatsby benchmarks. This is a framework for schools' careers guidance that most of the schools in the UK follow because it's all about metrics and results and things like that. The point number 4 here, linking the curriculum to careers. This is a key point that they are trying to do with their careers guidance, and that is something that we can bring to the table. Okay. And it's on the national curriculum, right? Radio is actually on the national curriculum. We all recognize a drawing like this over on the right-hand side, right? Okay, we've all seen this before. This is what radio is, right? Oh, it's there. It's AM and FM. And yeah, okay, but let's talk about the electromagnetic spectrum. And light. We can do light. That's much easier to do in the classroom. Okay, so radio gets this brief mention in a lesson at Key Stage 4 as this thing when they're talking about this thing called the spectrum, and then quickly they're trying to drive it to light, because then you can get the prisms out, the diffraction grating, the laser, the lamps, and you can work with that. Okay, so we get this little footnote. It's in the lessons, but it's just a brief mention, because radio waves, you can't see or handle that so easily in the classroom, and no one listens to radio anymore. So why would you bother talking about AM and FM? I'm listening to like my podcasts with the phone plugged in the car. You know, I'm not even listening to that. Am I? Wait, that's wrong. Okay. Or handled easily. We can do that. So this is what's different, and this is what I want to kind of pull the attention to.
Hello, Martin. Thanks very much for sending that in. That's great. So you are, so like I say, your report is 5 and 9 here up at the RSGB convention today. So thanks very much for the call. I'll bid you 7-3. Golf Bravo 3, Hotel Quebec. Over.
I was into the classroom. Another point. Every classroom these days, every room that you'll do a STEM engagement in has got a big video screen. Okay, so we can put the spectrum up there and we can show them that magic. Okay, and we can make that hands-on as well. How? This is the part where it goes slightly sideways. And I need some volunteers. Okay, so I'm going to quickly point at Martin and Anna. Okay, if you can come up with me, and I need two more volunteers, please. And don't worry, it's just for a couple of moments, and it won't be terribly embarrassing. I have another one here. Because I don't think the camera can really pick this up, but I'm just going to talk. Just going to talk you through it, okay? So, yeah, lovely. If you just like sort of want to stand around here somewhere, I'm going to put the cards down. Okay, and if you each take a controller and let the mayhem commence.
Oh no, they're all going to be the same one, is it?
Off you go.
Oh, yes.
Right, okay.
You know, that's the cool thing. You could do this with microwaves as well.
Right, so the point of this isn't so much as what's going on the floor. I think you can probably imagine it's chaos. And normally I might sort of lay out a little track or something like this. And if they were standing a little bit closer to the receiver on the desk, then it becomes more obvious. I think that's one of them there. And then, yeah, okay. So basically, this is an example of the kind of icebreaker I might start one of these sessions with a school group. Yeah, and it's always chaos, and that's actually the point. How I might start is spectrum up on the screen, cars on the floor, maybe a little track, and just pull them in, and just give them the controllers, and let them have it. And I just sit there and watch. And I'd probably give them maybe 5 minutes or something like that, and there'll be chatter, and there'll be crashes, and basically the gag is they're all on 40 megs apart from one of them. One's on 27. Okay, right. And so that's the one that's freely driving around the track going, I don't know what you losers are talking about. And everyone else is just completely clashing and colliding. And you can see it on the SDR display. Okay, you probably need if I had a slightly longer antenna or closer to the controllers, it would be slightly better. But there you go. That is that's my little icebreaker. Thank you very much. A big hand for our brave volunteers. Lovely. Right. So what just happened? Okay, I had some toys. I have what we sort of call these Coke can RC cars. These things cost about £10 on you know, eBay, Amazon, whatever your low-cost supplier of cheap electronics is on the web. You can kind of get things like this. And the sort of key to that sort of thing is, like, if you can try and get them on different frequencies, even better if you can just get like one on a single frequency, you know, that's kind of fun. But it's an example of a kind of hands-on icebreaker type activity. People are always asking for hands-on activities, and I'm like, oh, oh no, what am I going to do? You mean I can't just stand up in front of them and bore them with 30 minutes of slides? Oh, that's not really my bag. Okay, so it's an activity that if you stage it correctly, it can lead in, and you can zoom in on those signals, and you can start talking about signals in the spectrum. You can see the carriers. You can see the change in modulation on those carriers. You can talk about interference, and so you can talk about lots of different spectrum topics. It's a bit crude, so how I use that one really is more of a lead into, okay, right, so we've seen the radio spectrum now, we can see it. Okay, what else can we see? Right, and this is where I think things get really cool. Most SDRs will go a lot further up than 40 megs. I have on the bench here, this is a Lime SDR Mini. In my box of tricks somewhere, I also have a Pluto SDR. So I've got a couple of SDRs that will go up really high in frequency. And this is a thing that we've done this year as a public talk as well, what I kind of call my spectrum safari. And so we start with something familiar, and then we kind of go for a little tour through the spectrum and see what we can kind of find. So you might talk about HF. Okay, HF is pretty easy to talk and get lots of flashy things up on a spectrum. By the way, I'm doing this with canned video today, so this is kind of like you can do it live with an SDR. That's really cool. You are slightly at mercy to all the interference that's in the room, but that might actually be an exciting part of it. Okay, you'll just have to think quickly on your feet and kind of explain stuff away. But accurate explanation is not necessarily what this is all about. This is about putting spectrum in front of people. Now, obviously, lots of signals at HF, so you can zoom in on these things, and you can go really, really sharp in, talk about carrier waves and turning them on and off, and modulation. Morse code, obviously, being an excellent demonstration of that. But you can go the other way and start doing things that people use in their daily lives, and visualize things like FM broadcasts. And when you look at FM spectrum on the display, you see some really good features, like, what can we tell about, I've obviously got the RDS information on there, but what can we tell about what's going on these 3 radio stations right now? What's going on here? Speech, right? Yeah. More talking. And Radio 1, as you might expect, is just a wall of noise. I have proof. But here we've got visualization of carriers, radio carrier waves and subcarriers being modulated with information, and you can directly relate that to what's happening. Okay, so you're starting to get hands-on with radio science and the technology. Push the wrong button. Okay. The analogy that I kind of use at this point is of tuning the radio dial, and I'm kind of moving the SDR up in frequency as if you're tuning the dial and kind of exploring the spectrum. Flipping between canned video doesn't work quite so well, but if I had more than a couple of minutes to demo this, I would sort of labor on this idea of the spectrum being a continuous sort of view, and we're kind of moving our way along it. Anyone know what we're looking at here? DAB, right, yeah. It's pretty easy for this audience to recognize that kind of thing. But this gets quite interesting, because what we're now looking at is pretty much what we were looking at just there, but now we've multiplexed it and digitized it and bundled a bunch of stations into one block. And if you zoom out, if you've got an SDR that's got a bit of width, I was probably doing this with my Lime Mini. Now you're looking at a larger chunk of spectrum, and you can see the multiplexes, and you can point at which one is the BBC multiplex, and you can say all of the BBC radio channels are in this block, and you start talking about DSP and all those other good things. Okay, so DAB, it's getting more relevant to people. Okay, and now we kind of wind it up, and as we go further up through the spectrum, you can talk about other things that you might find on the way. But I would encourage you to get to 2.4 gigs. Any idea what we're looking at here? Wi-Fi. Pretty obvious to us, but most people that you're talking to in a STEM setting probably haven't thought about that, let alone seen it. And this is where things get really cool, because you're starting to work with signals that people actually have that eye-opening moment of, this is a thing I use all the time that's in my pocket, and it's doing that. What is that? And we got some great questions when we were talking this through with a group of students at Bletchley Park earlier in the year. And kind of put this in front of them. And I'll do more asking questions than lecturing. I tried to just sort of do this kind of tutorial style. Wrong button. Okay. Next level of the demo is you turn on a Bluetooth speaker. Okay. And now we're seeing Bluetooth hopping all over the same bit of spectrum as Wi-Fi. Okay. How does that work? How are they both working? You can talk about interference mitigation, different coding. You can go quite deep if you want. But mostly, what I like is that we're visualizing the spectrum. It's become exciting. It's not a dry thing. And slightly unexpected things might happen. What happened when that? What was that all about? They'll ask the questions, and you can try and explain it. That might well be the sort of rapid intensification of the Wi-Fi signal. That might be me starting to stream a YouTube thing, which is one of the questions that we got kind of live when we did this. The student made the link of, wait, that's your laptop talking to that Wi-Fi router. What happens if you start streaming a video? He said, oh, great point, great question. Fire it up, and you watch the duty cycle on that Wi-Fi channel rapidly ramp up. Bluetooth still streaming, still working, music still playing out the speaker. Okay, so that is kind of my sort of spectrum safari idea, which we've run that as a public talk at Bletchley Park. I tend to run it in sort of small groups with students, kind of tutorial style. And there's there's so much you could talk about. I could talk about this bit all day. I'll make a brief sort of nod to the SDR software. I'm using SDR++. It's a version of SDR Sharp, I think, which we're probably all familiar with. If anyone's played with SDR Angel, that's a great bit of SDR software. It comes up with this sort of digital phosphor display we've got up there on the screen. Looks awesome, great eye candy. A little bit hard to drive though. The buttons are very small. So I find that a little bit too intense for me, to be honest. I don't have enough practice to be good with that in front of an audience. Loads of things you can talk about doing a spectrum safari. Challenge is probably the SDR, but actually, I'm preaching to the converted here. I lost count of how many people had an SDR that can get up to 2.4 gigs, so you guys are already there. Right, I would make the point of less slides. I'm boring you to death with slides so far, so thank you for bearing with me. More spectrum. Get the spectrum in front of them. That is the exciting thing. That's the star of the show, having them sit there and go, oh, wow, that's interesting. Oh, I used that. Oh, I didn't know that. How does that work? Okay, that's what you're trying to do. Okay, cool. Right, so little icebreaker material. We've talked about a kind of spectrum safari, which you can do with small or large groups. Get that spectrum up on a big screen. Finally, I'll give you an example of an in-depth project. If you've got kind of an enduring engagement with STEM clubs or something like that. Anyone played with weather satellites? Ooh, okay, that's the lowest number of hands. Okay, you need to get on this, right? Weather satellites are awesome. When I was playing around with weather satellites, I was doing it myself. I was getting excited about it, and I was like, this is cool. And that was when I had my sort of light bulb moment, that I was doing something with basically 20 pounds of SDR that was totally awesome. I was doing it on Linux. I was using free software, gpredict, GQRX, WX2Image, pretty much a wet bit of string for an antenna, but starting to think about building a quadrifilar helix. And I was like, this is awesome. And I'm only doing it with like basic cast-off computers and 20 pounds worth of gear. Wouldn't that make a great schools project? So this was a sketch that I kind of like drew up as an idea of, wow, wouldn't it be great? Imagine on the wall of the school science block, there's an antenna and it comes in and it feeds this SDR that's giving them a live display of the satellites going overhead and the weather imagery. And I sort of sketched this out, and this was the first thing I put out there as a STEM ambassador. So my local secondary got back in touch with me, and this was around about the time Tim Peake was up on the ISS, and so everyone was frothing at the mouth about space. And so they bit my arm off, pulled me in, and then ensued some absolutely manic weeks where I was coaching a small group of students with an after-school club through building antennas with, you know, the usual sort of tape measures and plumbing, getting some cast-off computers from the IT department, chuck a couple of RTL SDRs at them, and then coaching them through receiving the weather satellites. And that moment when those signal lines start coming up from the noise is unbeatable. And the look on their face as they realize they're actually tracking the satellite as it goes overhead is superb. So coached them through, you know, pulling down their own imagery. That was one they pulled on a Saturday afternoon. Lots of time spent in the lab and sort of troubleshooting things with them. But they kind of bundled together all of their hard work and put that into a STEM competition, and then sort of get invited to the Mission Principia conference down at Portsmouth, and, you know, dreams came true, and, you know, Tim Peake comes along and everything like that. So I won't labour on the sort of in-depth details of that kind of project, but it's an example of something that you may do if you get you know, more time to spend with students. There are some great things. That vision that I had of the sort of screen on the side of the school science block, yeah, they did that. Got the antenna plumbed onto the side of the school science block, fed in through the window and over the ceiling, and then into the Raspberry Pi, and the RTL dongle and the LNAs tucked behind the ceiling tiles, and they did all that. And you know, it was there on the school open day. Oh, you know, got all misty-eyed. But yeah, great project, weather satellites, so much you can do with this. You know, it's hands-on interaction with satellites and space. You can talk about all these physics concepts, timing and orbit. You can't just pop out and go and do it right now. You've got to wait for the right pass. So you need to understand schedules and orbits, Dopplers clearly visible on the spectrum. You can go deep in lots of different sub-projects depending on what their skills are and what their interests might be. So there's loads of mileage you can get out of weather satellites. I can't say enough about it. It's totally awesome. Okay, right, thank you. So wrapping up, right, I've given you some examples of things you can do, like in a STEM setting with young people. None of them are amateur radio. I've not said amateur radio to any of the students. I haven't. I've tried to stay away from that. If it sparks their interest in radio, okay, then obviously that's the natural playground to sort of draw them towards. But first, I'm starting big, or I was trying to start wide with, this is a thing everyone does all the time. You're addicted to it. It's everywhere. It's really important. Let's have a look at it. Let's have a look at this invisible dimension to our world, okay, and try and sort of bring the curiosity. 2.4 gigahertz, I think, is a really worthy challenge. If you can kind of visualize that and get that into the classroom, I think that's a real eye-popping moment. And I've shown how you can link that, the link between careers and the curriculum, and that's an important thing that schools are looking for with their careers guidance. Okay, so the final thoughts, I would say, you know, we must show radio as today's technology and tomorrow's. Okay, so think about that when you're planning your STEM outreach. You've got to make it relevant to the audience. You've got to meet them where they are and draw attention to the skill shortage. We know that there's a skill shortage. It's not going away, RF technology. So we need people to be interested and excited by that. Let's show them something exciting. Okay, the spectrum, that is our invisible playground. It's wonderful, and you know how to make this dynamic and visual and exciting. Couple of quick pointers. A whole bunch of STEM ambassadors in here already, but you know, if you're interested in this kind of thing and STEM outreach in schools, STEM Ambassadors is the scheme in the UK. That's run by a company called STEM Learning. So if you search STEM Ambassadors and you see STEM Learning, you're on the right track. Head down there. If you have STEM projects, if you have big ideas about STEM projects that kind of jive with this, but you know, money is a blocker, write something down. Talk to the Radio Communications Foundation. Talk to the RCF. That's what it's there for. And a couple of Google pointers of some of the things I've shown you. That is it. Thank you very much.
Thank you, Andy. Questions? No questions.
Done silent.
Ah, here's one.
Only a quick one.
Ben.
Do you fancy joining the outreach team?
You've got John Hislop on the outreach team, haven't you, right? He probably taught me half of this.
Another one here, Andy.
If the children you work with show an interest in amateur radio, do you think you would schedule a contact with the ISS?
Oh, it's probably a question for Anna. I was at her talk yesterday, so yeah. I mean, what a great opportunity. Yeah, I think you've probably got to build a sort of critical mass of interest at a school, haven't you?
You just have to be very persistent. I mean, the answer that I will give him is like, you should, like, if you have, even if you don't have them interested originally in amateur radio, if they are interested in the spectrum, organize, like if you're already doing this, organize a contact. Yeah. Like the window open, like you have a whole year to plan, a whole year to get more people into it. And even if you have one kid, then it kind of, it's like a virus, it sort of spreads. So,
yeah. I
mean, and the only downside is just the amount of gray hairs that you get afterwards. But like, yeah, I know there is a limit to that as well.
Yeah. High work, but high impact. Yeah, no, great question. I mean, another amazing opportunity that's available to us.
Hi, JNG4HLZ. Well, first of all, on the ISS front, of course, you can always just receive signals from the ISS. It flies over you a couple of times every day. And they're just starting the TV transmissions for schools links. There's one coming up shortly, actually. Anyway, talk to the BATC folks downstairs more about that. There are radio transmissions that you can pick up on FM radio as well. Yeah, interesting, actually. I just proposed to my local air cadets, which I must feel and volunteer for, about just that project. Let's receive some NOAA images. Oh. And then what happens? NOAA 19 stops broadcasting. So I'm looking for a new satellite.
You've still got 15 and 18, haven't you?
I don't know, but it all seems to be a bit weak at the moment. But absolutely.
Are they out with 137, or do we all have to go to L-band now?
It may well be L-band or higher, actually. Okay. Maybe even 2 gigs. That would be good.
Well, there you see, there's the fun, right? Because STEM outreach can be a lot of hard work. Personally, my STEM outreach efforts, I feel I'm not so good at building towers out of spaghetti, right? The blue tack spaghetti, all that, building bridges, it's not my thing. I want to be doing something that I enjoy, slightly selfish, okay? But I want to be like learning and doing and stuff like that, so.
And it's getting them to bend that wire coat hanger or whatever it is to make a shape that will work as an antenna, because it's all black magic, literally, but it's not really. We know that. It's just simple radio. Anyway, thank you very much for a brilliant talk.
Pleasure.
One at the back and another one here. I'll go back first.
Yeah, so Manuel, ON6RF. Just wanted to give feedback that absolutely loved your presentation and really gave me a lot of ideas for some workshops I'm giving as well in terms of making common stuff visible to them, and I think this is really something I really want to explore. Just coming back to the SDR++ software that you're using, there are plenty of things you can also add on top of that, like plugins that are installed straight into the software, because nowadays, I mean, the NOAA satellites are not transmitting anymore, so that's gone, sadly, but there are many other satellites on the same frequencies that do that, and there are many plugins in there that can really make your life easier and more accessible for others to reach to. And I had one last question, and people that know me might know where I'm hinting to, but have you tried or showed radio sondes, like weather sondes, because they're quite easy to track as well, and there's a whole hunting part, going after them and finding them, which is a bit like a mix between geocaching and, I mean.
No, I haven't. But I should, and that's a great link. There is another great project or STEM activity that you can dive into and go way down the rabbit hole with all sorts of different skills. It's not amateur radio, you know. Everyone's talking their call signs this weekend. The call sign culture is like, it's not, that's not necessarily appropriate for the STEM setting, because I feel there's a bit of gatekeeping there, and it's like, oh, well, you know, join amateur radio and get the call sign, and then you can play with this stuff. There's so much stuff you can do before you go there if you want to. So yeah, HAB tracking, radio sons. I think I did have a look at this when I was kind of starting to get into the STEM club, and I was like, and they were hungry for more. They were like, what else we can do? I think the challenge with the HAB tracking was like, inevitably you're going to want to go out and chase, or you want to get up, or sort of go mobile, and kind of getting the students out of school at certain times to sort of chime in with the events and stuff like that was probably a bit too much of a challenge for me at that time. But that's a great area of projects to sort of dive into in STEM, for sure.
One last question.
Malcolm Grisdale, M0VNA. My affiliation's more sort of hack spaces than amateur radio almost. And one thing that got a whole subset of us, to some of who already had licenses and some like me who went off and got one, was really when the LoRa technology came along. We'd already been messing with ZigBee, we were messing with various shortwave RF. I think the question I was going to ask is to what extent you'd considered those technologies which are easily and cheaply accessible, and as soon as you say mesh-tastic, maybe a lot of us would go, well, yeah, we can go further than that, but it is something that is easily accessible, and you can get modules for less than 20 quid, and people can get real distances, and maybe that's another thing to consider.
Yeah, 100%. That's actually, so I haven't done that myself in a STEM setting yet. I am playing with it myself for my own selfish gains. I'm trying to rig up some telemetry for my wife's allotment and get it 3 miles across the village. And the rule is no cellular. Okay, that's cheating. I can do this like organically, so LoRa I think is the tool of choice. So I'm playing with LoRa modules myself. I'm getting a lot out of it for fun, and that is no doubt going to sort of work its way into kind of STEM ideas. Yeah, just a small sprinkling of things that I have done personally, but HABs, radio sons, LoRa, you know, more great examples of technology areas.
FT8 is a good one because it's very, very visual if you use it with PSK Reporter. One of the stems that I did, set up a station running FT8, showed them the antenna outside, and then showed them where our signal was getting to, and the kids were just absolutely fascinated by it.
Yeah, it's another eye-popping moment, isn't it? Yeah, great suggestion, great link.
One very last question.
It's a great presentation, especially with the spectrum analyzer. And I sort of noticed that you said because of the STEM program, you tend not to mention about getting licenses to children. And I noticed that, is it possible for you to bring a couple of licensed or people on there and show them that, hey, there's a signal on the spectrum analyzer. You could get a license and own it yourself and motivate them.
Yeah, I think there's definitely room for that. I think so. When I was talking about kind of doing the sort of spectrum safari thing, and I'm kind of you know, I typically sort of start low and then kind of move up through the spectrum. I mean, I'm sort of hitting the skip button to go to my next video, but when I do this live, I'm actually working the controls on the SDR, so I'm trying as much as I can to sort of make a journey through the spectrum. And so you see things on the way, and you know, and with the SDR, you can put the band plan overlays and things like that, so it will clearly be marked there. You know, 2 meter ham band, 70 centimeter ham band. It's something you can kind of call out and just go, oh, what's this? Oh, well, you know, here's parts of the spectrum where actually you can get a license and you can generate your own signals, and you know, start to play and experiment there. But you know, let's keep going. Let's see what else we can find. So it's definitely it's all there on the spectrum to be seen. It's just up to you to kind of tell the story and link it together and make it relevant to people.
Okay, Andy, thank you very much. Radio, present, the future. When I joined the radio division of my company in 1970, I was told why on earth are you doing that? There is no future in radio. So we all know that there is plenty of future. Andy, thank you very much. Really inspiring.
Really good lecture. Actually, if you attend the convention in person, there are actually 4 streams of lectures that you can choose from while you're here. We're now going to drop into one of those other lectures just for a few minutes. George Fraser, GI4SJQ, is talking about coaxial cable and connectors, making the right choice.
With all the equipment you may already have in your shack at home, and then we're going to look at how to do it with an antenna analyzer. So, first one, wattmeter and dummy load. We need a transmitter that covers the frequency that you wish to measure, a known good wattmeter. Anything you buy nowadays is decent quality. Unlike what we had back in 40, 45 years ago, where you couldn't tell how much power was coming out because you had nothing to calibrate against. You've got nice switched ranges. You know, even the best commercial wattmeters like the Bird 43, they're only plus minus 5% at full scale. So there, you can't say they're the end all and be all. They're very good at full scale. But any wattmeter that you would have in the shack will do the job. You need a short patch cable. You need a back-to-back connector for the connections you're using. And you need a 50 ohm dummy load. So what do? We set our radio up and we put a short patch cable on it and we connect it to the wattmeter. We then connect our cable under test to the wattmeter with the barrel connector connected to it and the dummy load plugged into the end of the barrel connector. We transmit for a short period of time, let the meter stabilize, note down the power output. We then swap the barrel connector with the dummy load. We turn them around. We keep the short cable the short patch cable in circuit with the barrel connector on it and the cable under test, wattmeter, and then the dummy load. And we're now measuring the power at the far end of the cable. Once we've got that done, we can plug it into a reasonably simple formula, which will give us our loss. So the formula is 10 multiplied by the log of the power out divided by the power in. And we can convert that for our known length of cable. Say we've got 10 meters of cable. That'll give us the loss for that 10 meters of cable. Divide by 10, multiply by 100, and we've got it for 100 meters. We can then go to our book, look up the spec for the cable and see if our cable is in spec. If it's not in spec, it would be great if it was better than spec. But if it's worse than spec, well, maybe we've got a problem with that. Maybe this is a cable we've used for 20 years and it's been outside for 20 years. And maybe it's 3 dB worse, so we can look at that. You can use a VNA for this. And a few things you need to do with your VNA. You need an antenna analyzer with 2 ports. I'm not sure about the rig experts because they only have 1 port and I never looked at them to see what way it's done, but I'm sure you can do it with them. But with a 2-port VNA, set your sweep and your display settings up. Choose your start and stop frequencies of interest. Very important, always calibrate, do a full calibration. You're open, you're short, you're load, and you're through with the wee patch cable that comes with it. Save your calibration so you don't have to do it the next time on that frequency. Now on the VNAs, there's maybe up to 4 traces you can have. Select one of them and make sure it's set to S21 and that the reading is in dB. You then connect one end of the cable to port 1 and the other end to port 2, and it miraculously will tell you what the loss is. So you can see the setup that I had in the top right-hand photograph, and the middle photograph shows you that I was doing this at 435 megahertz, and then the loss at 435 megahertz is 1.51 dB for that length of cable. You could take a note of that. So, that length of cable in the photograph was 10.6 meters of Ultraflex 7. And as I've mentioned, Messi and Poloni spec it at 400 megahertz. So I redid this at 400 megahertz, recalibrated, set my frequency, ran through the same process. And I got 1.37 dB of loss in the same piece of cable. I then looked up the loss for that cable, and it's 11.8 dB per 100 meters at 400 megahertz. Divided by 100, multiplied by 10.6 to get the loss that Messi and Poloni specify for my cable length. Came out at 1.25 dB. Just over 0.1 of a dB difference, which I was really surprised about. I have a couple of PL to N type adapters on there, so there's going to be a wee bit of loss with those. But I was really impressed at how close it was to published specifications. The cable's never been outside, it's never been exposed, it's sat in the shack all its life, doing nothing, so pretty close. But if I was seeing a big difference there on a cable I had used for some time, that's an indication that cable's getting towards the end of its life and I need to think about replacing it. So some final thoughts. It's all down to you. It's what is your use case? What are you using it for? Is it HF? Is it UHF? VHF? Microwaves? How long's your cable run? It's amazing what you can get by with if you've got short cable runs. How much power are you running? Are you running a kilowatt? Are you running QRP? You could have the same considerations because QRP you want every watt out.
Oh, just a glimpse of one of the other lectures. Well, here on the live stream yesterday, the RSGB General Manager and the Communication Manager chatted about the RSGB digital platform and the new mobile app that was launched just this week. If you've downloaded the app or would like to find out more, take a look at this video that they recorded this weekend that explains how to get the most from the app.
Hello, I want to show you the RSGB's digital platform that's available on web and also an app that's available for mobile and tablet. We see Radcom here on the first screen, and an important thing to note is that we've actually got 25 years of Radcom available in the archive. So members can go back all of that time, 25 years. We also have in the app Radcom Plus, and we've got the archive of Radcom Plus. We have Radcom Basics as well. So this is what our RSGB members have access to. If we go back to Radcom, then we can actually search Radcoms across all of that archive that we've got. We go for the search button just at the bottom there. And if we go for LoRa, for instance, and hit search, then it brings up really quickly all of the instances of LoRa across that 25 years at the moment of archive within Radcom. And you can scroll back through those, and any of these, you can just click on it and you jump straight to that page, or in this case 2 pages, that related to that search. And we can come back out, we go back to the search. So it's really, really quick and easy to search back through the archive. And if we go back to the top level editions now, so at the archive, if we want to go into an edition, let's pick the September edition there. We just touch on that and we come to the front cover and we can just scroll or swipe to the left and we go to the 2-page view and we can go through the magazine like that. If at any point we think we'd like to just look at one page, then on this tablet I'm using, this iPad, we can just turn it sideways and it goes to the single-page view, which makes it a little bit easier to see, but you can still scroll through the pages left and right like that. But what you can do here, you can zoom in to some really high resolution. If you want to look in a bit more detail, you want to zoom up the size of the text. It's easy to do that, and you can zoom back out again. And if I go back to the 2-page view, if I just touch at the bottom here where it says View All Pages, I can bring up a scrolling bar at the bottom, and you can scroll through all of the pages in that edition. And it's very easy to go to any of those pages. And when you're on a page, so I've just selected that page, I can go back to the single page view like that. If I want to bookmark that page, I can do that. I just touch the page and it brings up the little menu at the top. And the second one there, I can just bookmark that page and it saves it as my content within the app. And we can go back to that page at any time you want to. While I'm here, you can also print up to 2 pages. You can just touch the print icon there. But what I want to show you here as well is that we can actually embed digital content in the app as well that you can access within the app. You haven't got to come out. So in this case, the review I'm showing here of the Momo 6 and 4 meter antenna that RSGB actually sells, then Fraser has written a review, which is what we're looking at here. So we've got the review, but he's also recorded a video as well. So a video of him building the antenna and reviewing it. And we've got that embedded in this digital version of Radcom. So if we just click the video and we can turn the sound on.
What have I got for you today? Well, in a break from...
There we go. And we have within the app then linking to Fraser's YouTube video that he's recorded for us that relates to that review. So very easy. And then if we go forward just another couple of pages, we find this is our advert from the RSGB for buying that antenna. And you can see just at the bottom, the bottom of the page, there's a link there to the RSGB shop, and you can go there and you can buy the antenna that's been mentioned in the review. So the whole app is designed to link together all these different parts of our digital media and everything that the RSGB produces, and external people as well. So if our advertisers include URLs in the advert, you can just click on that and it will go to wherever that URL is, off to their website, whatever we do like that. And it's just easy within the app. And all the way through our publications, you'll find that URLs are actually highlighted by the tool that we use to produce these. So if I zoom in here into our Tonight at 8 advert at the bottom, then as you can see rsgb.org/webinars is highlighted. I can just tap on that and it takes you straight to that part of our web page. Really easy. You never have to come out of the app. The other thing I want to show you, if we go to perhaps this page here, if you actually want to do a screenshot, then if your device lets you do it, then you can take a screenshot. And if you want to mark that page up, perhaps to read it later, and highlight something, then you can do that, and then you can print that page if you want to. So if that's the sort of thing you like to do to mark things up, you can absolutely do that. It does depend on the device you're using though, of course. And if you want to print some content, you can. So if I just turn this sideways and we see the 2-page view again, then we can just tap the screen. That brings up the menu at the top. We can go for the print icon there, and it lets me choose if I want to print 1 or 2 pages. And send that off to your own local printer. But it is just 1 or 2 pages. Hopefully this gives you a good overview of what you can do with this exciting RSGB members benefit.
Works great on a phone as well. Now we've got our next lecture today, The Biggest Nerd She's Ever Met, My TV Adventures with Hannah Fry by Neil Smith, G4DBN.
A very good morning, everyone, and welcome to Kent's Hill, the National Radio Society of Great Britain Convention for 2025. Good morning, good afternoon, good evening, wherever you're watching around the world. We are live streaming, or if you're watching this at a later date. Just for those people in the room, just a couple of things. Don't forget that in the breaks between lectures, and as well as chatting to the special interest groups, there are 4 RSGB committee rooms immediately above N130. So if you get a bit lost or bored, I think they're feeling a bit unloved. So please pop up there and find out. There's lots of things there, committees. And that's great. The health and safety information, you just noticed that on the screen just before that. So you've seen the exits and so on. And I'm absolutely delighted to welcome our next guest speaker, who was in Yorkshire at 11:30 last night with his string and sellotape trying to make it all work. And so I'm really delighted to welcome Neil, G4DBN, is it? DBN, yeah. who is going to give us a talk and share all of his experiences about the BBC Two's programme, The Secret Genius of Modern Life. I'm sure you've seen it. So without further ado, I won't go into, because I don't want to spoil what you're going to say, Neil. A big warm welcome. Show your appreciation now. Neil, over to you, and we're going to have some Q&As afterwards, which I'll look after you. So
Super.
There we go. Off
Thanks
you go.
So much, Bob. Right, back in the mists of time, sort of 2021, I was made an offer that I just couldn't refuse. Heather Parsons from the RSGB wondered if I'd be willing to give some advice to a BBC researcher. Sounded like an innocent question, but it opened up an entire new chapter of my life. It led me down rabbit holes that I didn't even know existed. The little project grew legs, and instead of some advice, I ended up spending 300 hours making a thing, fighting to get it to work in a totally terrible environment and getting grilled on camera by a certain well-known professor of mathematics. My mother was very proud. She could tell all of her mates that her little lad was going to be on the telly. Now, I've always tried to be an ambassador for the hobby. Many of the other attempts that I've seen trying to promote what we do in a positive light, it's fallen a bit flat. I mean, look at special event stations. Loads of blokes with their backs to the camera or visitors doing weird stuff to obscure kit in a world of their own. Some blame Tony Hancock. I mean, look what he did for blood donations. I've recruited a few folks who've gone on to get licenses, but a typical case of where a colleague heard me talking about some obscure bit of radio tech, then phoned me later, almost whispering, "Neil, are you a radio ham?" Well, dear reader, I made him one. It might not be obvious to you, but I've always been crushingly shy. I hate being photographed or videoed, and even phoning people I don't know is a nightmare for me. But after losing my wife of 37 years, I decided to start saying yes to things I found terrifying, to see if life became more exciting. Well, friends, the experiment was a resounding success. You could ask why on earth I have an amateur radio license if I'm not keen on talking to strangers, but when you're 13 and you've just been scolded yet again for making naughty, unlicensed, high-powered transmitters, getting a license and learning Morse was a really simple solution to keep me out of court. Anyway, after my baptism of fire with the BBC team, I found that I could easily adopt an imaginary persona and operate the G4DBN avatar without actually having to show the real me at all. It's all an act. Another inquiry from the team the next year, and then there was another one in 2024. Hundreds more hours were expended, and lots of my cash was, what should we say, invested in the necessary tooling and materials for two more absolutely fascinating projects. The detailed background to those projects eventually ends up on my YouTube channel, but there's a bigger picture that I want to address. How can we promote amateur radio and the associated hobby activities to folks in the broadcast and print media that have all got the wrong idea about what ham radio is and how we should interact with those folks to try and get a story across without excessive compromise and dumbing down? The first show started with a simple question. Did I know anything about the Great Seal bug that was discovered in the US ambassador's residence in Spaso-Speskovskaya Square in Moscow in 1952? Would I be able to provide some information for the show about the bug? Would I mind being interviewed on camera, perhaps? Had I ever thought of making a replica of the device? And then it escalated. Please, please, can you make one that actually works and demonstrate it to Professor Hannah Fry on location? Well, if you can get me back to Moscow in 1945 with the same equipment available to the NKVD in a radio environment that's empty, no electrical noise other than occasional car ignitions and unlimited time, then yeah, no problem at all. Of course, what the BBC heard was, okay. That was the critical turning point when my old life ended and a whole new world was laid open to me. It was also where the first gulf of misunderstanding opened between me and the production team. Trying to get over the concept of a radio quiet environment fell on ears that were not listening. The team had UHF radio mics, wireless video streaming, from cameras to monitors, switch mode lighting, and loads more noise sources. So I said it's nearly impossible. They proposed trying to do it inside a giant anechoic chamber at Imperial College. But the whole point of the Great Seal Bug system is that you need to do it in an environment where you can not only null out the direct signal from the signal source to the receiver, but you also need an additional 30 or 40 dB of building attenuation. So you need to have walls in the way or whatever to try and get you down to the point where you can actually decode the signal. So I needed to get something like 80 dB attenuation of the primary, and it was just going to be utterly hopeless. Then, of course, if anyone moves more than about a 1/16 of a wavelength at 1 gig, the entire setup has to be readjusted. So perhaps we could find a castle in Scotland in a deep glen with no radio signals. It might be just about possible, I suggested. Their compromise position was to suggest doing it in the council chamber at Broadcasting House in central London, behind the statue of Ariel and beneath the portrait of Lord Reith. Hard to imagine a more hostile radio environment outside of a war zone or a major contest site. Just to add spice, I decided to tune my setup in the 23 centimetre band to make it legal to operate. Sadly, the Port of London Authority have some mighty strong signals near that frequency. So trying to get a wide open, remotely excited homodyne receiver to work was more than impossible, if that's possible. Trying to bridge this vast yawning chasm of misunderstanding between engineering reality and the hopes and dreams of a hugely talented bunch of highly motivated and well-meaning creative experts was, they had no concept of the limitation of the laws of physics, but this was a proper doozy, it really was. So I set the likelihood of success at 1%, 99% certain it was never going to work. Those are the words that came out of my mouth. However, what went into their ears was, it's a 1,000,000 to 1 shot, but everyone knows 1,000,000 to 1 shots succeed 9 times out of 10. Rest in peace, Sir Terry Pratchett. Sadly, the laws of physics aren't amenable to negotiation or even the application of hopes and dreams, except for string theory and dark energy, obviously. Anyway, it all worked fine at my house, where there's no cell phone signal, and the only source of radio noise is me. Even there, though, it took me 5 or 6 hours to get it to work, and it was impossibly sensitive to being upset by passing chihuahuas. I did as much work as I could on managing down their expectations, but the folks at the Beebe were just so enthusiastic. I almost got carried away too. I worked on some backup plans involving some sort of cheating local powered oscillator to excite the cavity directly, but it was all just too damn hard. And it was cheating. They might not know, but I would. By now, I was right up against the deadline and running out of time and ideas. I decided to do my best with the disastrous mess that I got myself into and went into full-on denial mode. Perfect. So I made a 1.2 gigahertz signal source that could make about 2 watts. Built a pair of wide-spaced phased dipole arrays, which you'll have seen on the television program, but basically it's a hairpin loop with a dipole at each end. Now these things have a pattern like a hedgehog, lots and lots and lots of deep nulls and a few peaks. So by setting up the transmitter and the receiver and rotating them round so they're both in a null with each other, but both of them are seeing where the location of the bug is. The idea is that you might be able to get it to work. I knew I was going to have troubles with the homodyne receiver, but I had a Russian Malahit SDR, which I would put into AM slope detection mode, hoping that that might be a good fallback, and somehow that the spirit of Leon Theremin might appreciate the gesture, and smile upon my enterprise. I didn't even try and explain all that to the production team. Meanwhile, Hannah was swanning around the world interviewing experts in this and that for segments in this programme and loads of other programmes, blissfully unaware of what was going on and how my life and TV career were going down the plug hole. On the day of the recording session, I had a minder. Great lad. He could get me around the building and help with useful things like keeping me from panicking. I pulled my car up outside Broadcasting House, and the team helped me unload. The security team were very, very excited about all this weird and wonderful technical hardware that I was carrying into the building. Then one of them pointed at the box containing the replica bug. "What's in the box, sir?" he asked. "It's a fully operational Russian spy bug," I said. I'm going to install it under Lord Reith's portrait in the BBC Council chamber." "I'm sure it is, sir," he said, and waved me in. What a lad. Things actually started better than I expected. I set up the transmit station at one side of the room and the homodyne receiver at the other side. After an hour of intricate tweaking, I managed to get a signal. I was pretty stunned. My BBC minder heard it clearly. The producer wandered in and asked for a demo, but of course by then it had stopped working. The minder said he'd heard it no probs. Chris, the producer, asked why he couldn't hear anything, but we just shrugged and carried on trying. Sometime in the next half hour, I must have been slightly rough with the phase dipole and choke balun, but I didn't find that out until later. I couldn't get anything to work. Signals seemed terribly low. But instead of checking methodically, I just flapped about as time slipped away. Hannah was due soon. I hadn't noticed that the dipole array connection, which is a beautiful bit of engineering with a sleeve balun and all sorts of other stuff, the solder connection had fractured and shorted, killed the PA completely. So in the ensuing panic, I thought, oh, the PA's dead. So I put the other PA in and fired that up, and that died. So I was 18 dB short of signal, and I was already in a terrible mess as it was. The team had found a modern theremin instrument, but nobody knew how to make it work. I'd made a dozen theremin Vox machines back in secondary school, so I helped them set up the audio and got it all connected up to their mixing desk and gave them a quick demonstration with all the necessary hand-waving skills. You've noticed I'm good at hand-waving. There's another trick I noticed that the production team use. They don't seem to brief Hannah completely so that she can have a totally genuine response to surprising facts and things. If that's not what happens, she's a highly convincing actor. The sound engineer fixes up with hidden UHF mics, more QRM, and they fired up the fabulous cameras and the director's monitor and lots of auxiliary lights and all the kit. I was watching the SDR display. Well, it went from green to blue to red, and then it went white. And I thought, that is it. I knew I was completely sunk. Now, I didn't want to kill the mood, so I boosted the signal generator to max power and crossed my fingers. Of course, the antenna was still broken, but I had no idea. Anyway, the interview section went really well, and Hannah was exactly how she appears on camera. Everybody said, what's she like? She is the person you see on camera. But underneath it, there's a steely edge of professionalism. And the director was asking us to do some long shots. They wanted to take some shots of us just talking. So Hannah says, right, tell me exactly how this thing works. I'm fascinated. Don't pull any punches, tell me the lot. And she'd done her research, she understood. So that was fascinating. You know, so she might come across as giggly girl on camera, but good heavens, she knows her stuff. Anyway, the final denouement was approaching. The legendary Sunset Boulevard scene on the stone steps leading to the BBC Council chamber. Looking back at it, I looked like a condemned man, desperately fiddling with phasing and antenna orientation. The Tai Chi that me and her were doing to try and get the phase was stunning stuff. And then I had a sharp intake of breath because I heard something. Hannah heard it too. And we were all convinced. I was actually a bit sceptical because The source material was a production assistant who was singing Bar Bar Black Sheep into the bug over in the council chamber. We asked him to do the Declaration of Independence, but it was so boring. And there was no tune, so we thought, sing Bar Bar Black Sheep, that'll be brilliant, because we'll be able to detect that. So there he was, singing away under the steely gaze of Lord Reith. Anyway, it sounded more like Breakthrough from a World Service news broadcast, but there was a certain rhythm to it. Anyway, at that point, we burst into the council chamber to find that the lad was just about on his last legs. 40 minutes he'd been singing this. He didn't have a tune in his head. It was tuneless. He had no idea. So there's no wonder it sounded weird. Anyway, the director said, "Can you burst in and look excited properly this time, please?" 4 takes that took. Spontaneity takes a lot of practice. I still actually wonder to this day whether Hannah really did hear anything, or she was just cued by my gasp. It might have been premeditated. I mean, who knows how the media's brain works, but I really did hear something, but my ears are highly trained on decades of top band CWDX in microwave DX and NEME. So I'm leaving that as one of the mysteries of the universe. My mum was hugely impressed, so life goal achieved. She got all her mates round, they all watched it, and she was swanning about, serving biscuits. Good heavens. So that was my introduction. So the next project was connected with foxhole radios from the Anzio landings by US forces. I can't remember which one it was. It was something like the Fifth Army. And they were across the bogs that had been reclaimed from the Pontine Marshes, south of Rome. It was pretty much trench warfare. And some of the GIs wanted to try and keep in touch. So they were a bit miserable. They couldn't hear radio broadcasts. So they went on the scrounge. And they found telephone wire, high impedance headphones nicked from some poor devil, blue oxide razor safety razor blades, some US Army No. 2 pencils, and a few bits of wood screw and fence wire. By winding the telephone wire on the cardboard core from an empty grenade canister and running out an antenna and ground, they managed to tune something. It might have been on the 49 metre band, reports vary. The question from the BBC was whether it sounded realistic to use a pencil lead and a razor blade as a semiconducting diode. So after a bit of fact-checking, I told them it probably happened. Of course, that triggered the same old escalation. Can you get one working and demonstrate it in action, please? Leave it with me, I said. Anyway, I don't know if you can get the camera on here, please, Rob. I found some US Army issue headphones. I shall wave those around. So I found those on eBay. They were rather good, proper 1944 headphones. And I managed to find some razor blades. So this is a proper, actual, real, if it will focus. It should focus a bit better. There's not enough light. But these are, I can't remember which make they are, but they're proper, real oxide blue. And because they're oxide blue, they've got a semiconducting layer on them. And that's why they work. I couldn't find any Army No. 2 pencils. This was a bit depressing, but I found some that are very, very similar. These are 1950s issue, not quite period, but they're proper Skillcraft No. 2s. I did a load of experiments and I actually got some quite good results on 7 megahertz. Using my imitation Voice of America, just running about a milliwatt. I saw in Tom's most excellent microwave book that there was a particular South Korean coin that worked fabulously with making a crystal set using the semiconducting layer. So I went out and bought an enormous amount of South Korean currency. So I've got vast amounts of South Korean currency here. In that bag, there were actually 2, 5, I can't remember the name of the currency, but anyway, there were 2 of these little tiny things, and they worked really, really well. So I thought, this is brilliant. So anyway, having got to the point where I got it all working, I had another call. They wondered if it was possible instead to use loops of wire to excite an LED from a cell phone signal. No mention anymore of foxhole radios. So I gave them some advice and they managed to reproduce the phone lighting the LED up themselves, and that was the end of that project. Of course, I now had a huge amount of material for another YouTube video. So another lesson about media interactions: you're only useful and interesting to them while they need you. Don't expect any loyalty or ongoing sense of commitment, because you'll be disappointed. Another aspect is that long-running series tend to have regular changes of personnel, so expect to have to replay a lot of the earlier discussions you had with folks who've since moved on. They can't all have busy Baxter. A lot of assumptions will be made because the new team will only have brief project handovers with the old one, and that's where some of the feature creep happened in the Great Seal Bug Programme. It gets a bit tiring having to repeat yourself all the time, but beware of getting carried away on the waves of enthusiasm. Always under-promise and over-deliver. Anyway, third project. I had a call from the BBC. An innocent question. Did I know anything about the closed-circuit television camera system that Leon Theremin made in the 1920s? By a spooky coincidence, I'd been thinking about investigating the work that he did. It was at the State Physico-Technical Institute in what was, at the time, Petrograd, then Leningrad, and is now St. Petersburg again. I had this vague idea about building maybe a partial replica of some bits of it, but I didn't know an enormous about. Anyway, I set to work on researching what evidence there was, and found myself diving deep into some very, very deep rabbit holes. I'm going to keep calling him Leon Theremin, but that was a later adoption based on some sort of purported Huguenot ancestry. His proper name was Lev Sergeyevich Terman. During the research phase, I realised this was going to be a massive project. It involved optics, mechanical engineering, photoelectricity, electronic engineering, radio and electromagnetic apparatus, plus some chemistry, plasma deposition, and thermodynamics. Also, Theremin had made the thing work over several miles using HF radio, as well as over cabled links. Aiming for 2026 seemed just about achievable, but the BBC wanted something in 3 months. This time I was very clear about managing their expectations. I tried to deliver a work-in-progress model of the project and give Hannah a run-through of how the various parts of the system worked or may have worked. That was the limit, 0 scope creep allowed. I had the huge benefit of a terrible scan of his thesis at the Institute from June 1926. Although his handwriting leaves a little to the imagination, some of the typing is actually quite readable. Here he's talking about needing to have persistence of vision for about a 10 hertz repetition rate for 0.1 second. And he's also saying about the size of the view that he could get without distortion, about 1.5 degrees, and that he needed a 6-minute resolution. He reckoned that he could probably do that, but he had huge problems, and that's why he spent a lot of time researching photocells. Anyway, this system that he called he called it the Dalnovidenia, the far vision system. During the research, I discovered there's only one actually useful photograph of the final version of Leon's apparatus, and it's probably the last test version because there's still a G-clamp holding it together. And there's very little detail of what any of the components are. It gave me a fair bit of freedom in what I could do, of course, so nobody would know I'd done it wrong. Leon was looking for a project at the Institute as part of his studies. Abram Yoffe was the sort of founder of the Institute, which is still going, and actually still called the Yoffe Institute. It's one of the longest lived research outfits in Russia. He had some ideas about the early Russian television experiments done by Boris Rosing in 1907. Rosing was also a mentor of Zworykin, who, of course, did all his TV work in the States. Leon had been, I don't think he was actually, you wouldn't call him a radio amateur exactly, but he'd been messing with radio since he was about 9, and he had a lab at home, so he knew a lot about radio stuff. He also knew there were serious obstacles, because he had to make an imager, a synchronizer, transmission system, and a display. One of the things that was in, that's the only photo that we've got for how it might have looked, but you'll notice G-cramp. Yeah, very impressive. First he had to make an image formed by a lens, so I got a load of lenses, special lenses made. So there's one of my big lenses. I don't know if we can show that on the camera. It's a nice big lens. And he knew he had to measure the instantaneous intensity of every spot in the image. So instead of using the Nipkoff disc like everybody else was, where you have a sensor which picks up lines coming through holes in a disc, he decided that if he could move the image that was created by this lens and scan that in a raster, that he could just have a little tiny orifice and it would it would illuminate a sensor which he could then use. Unfortunately, there are a few defects in his reasoning to do with the fact that he only had selenium cells, and we all know how slow selenium cells are. But he decided that he could do this if he used a polygonal mirror drum and adjusted the mirrors so he could get the scans to overlap nicely. And then for projection, he was thinking about how on earth he could do that. He set himself a target. He said, I don't want this to be something that you just peer into. I want this to be on a 5-foot square display that we can have in a lecture room. Now, he knew a bit about biochemistry of vision and about cinematography. And so he knew that the interface could produce a flicker-free image at about 10 frames per second. I think he would have probably, if he'd done it to me, I'd have an epileptic fit. But anyway, it was still a massive challenge. So assuming that he could somehow detect the fast-changing intensity and amplify it enough, he still had to find a way to display it. And to get it on this big screen, it needed to be bright. He knew about movie projectors and arc lamps, so he decided that a carbon arc lamp was a brilliant solution to give a tiny source of high intensity. All he had to do was find a way of modulating that. Well, and then he needed to find a way of projecting it on the display. I'm not going to talk about the modulation today because that would be a whole talk, but think vibrating mirror, fingered gratings, and oh yes, very complicated. Worked beautifully. Anyway, so his idea of using this arc lamp sounded easy. So I found a source of morganite carbon arc electrodes, which just put those onto the camera a bit. So I found 3 or 4 boxes of these little things, nice copper coated ones, and they strike a fantastic arc. It's terrifying. So brilliant, just needs a kilowatt DC supply and a way to clear the smoke and some way to filter out the retina destroying ultraviolet radiation and deal with the immense broadband radio noise. Obviously no problem for our hero Leon. So I explained the ideas to the production team. Surprisingly, they had concerns. Whizzing mirror drums spinning at 6,000 RPM, a couple of feet from their valuable presenter's extremely expensive face. Yikes. Could I surround the thing with bulletproof polycarbonate sheets, please? And this carbon arc thing, wouldn't it interfere with the cameras, monitor, wireless controls, radio mics and recording system? Ha! I thought, gotcha, revenge for the Great Seal Bug. Also, this ultraviolet radiation and smoke and heat and all that electricity, it sounds a bit scary. Isn't it going to be dangerous? Hell yeah, that's the whole point of great art, my dudes. Media folk, eh? Health and safety gone mad, no fun at all. So I scrapped the joyous and terrifying experiments and tried high intensity 200 watt LEDs. I think I've got the smoking remains of one of those somewhere. They don't make them small enough. You need a really, really tiny area. This thing was 1 inch square. The flames that came out of it were spectacular. Yeah, I should have water cooled it, but that's what you get for buying things off AliExpress. Eventually, though, I found some xenon arc lamps with a 0.8mm light emitting area, and they produce in about 100 watts of light from that 0.8mm area. But by that time had run out. So I decided to use a green laser pointer to demonstrate the principle. And shone it through the mechanism. They did then sort of panic a bit and say, hang on a second, isn't that dangerous? I explained about how many milliwatts it wasn't. And I also added the polycarb sheeting to try and stop anybody being killed. There was never any hope of getting the imaging system working in time, and it's for 2026. I still haven't got it working yet. I tried cheating using a cesium vacuum photo cell, which is a marvel of 1929 technology, that particular one. But I felt that was cheating because he definitely used selenium. Leon had managed to get some selenium thin film cells from A.N. Boyko. I've tried to trace who A.N. Boyko was because he's mentioned in his notes, but I cannot find him anywhere. So it could be it's just Leon's really bad writing. Leon found a way to speed up the slow response to the cells, really using his radio skills. The initial system he built only needed 500 pixels. So at 10 frames a second, he needed about 5 kilohertz. Those notes earlier on suggested that he could probably do 3,200 hertz bandwidth and he might get away with it. But it was still really 2 orders of magnitude too slow. So he made another conceptual leap and tried turning the pixel to pixel variation as though it was an audio signal, ignoring the DC component. And he managed to get about 30 dB of amplification. And as a result, it was good enough to give a demonstration to the faculty in the lecture theatre. So, picture the scene. Leon presents his thesis and explains all the underlying physics and electronics to an audience of 200 staff and students at the Institute. He unveils his apparatus and powers it on. The screen lights up. He waves his hand in front of the camera scanner. The audience gasps and applauds as a giant ghostly real-time moving image of his hand appeared on the projector screen. What a showman the lad was, even back then. Yes, later on there's a bit about this. Anyway, Leon then found he could cheat because if he implemented a chopper and he treated the light variation as amplitude modulation of the chopper frequency in a radio IF strip, he could amplify the signal by 50 dB without instability. And that meant he could get huge increases in bandwidth. I think he got 20 kilohertz, but eventually he boosted it enough so he could get 100 lines interlaced, although the pixels per line were still a bit limited. Parts of that system are still on display in the Polytechnic Museum in Moscow. Somebody very kindly went and got me some photos of those. There was a chap doing a presentation about Leon. I tried to get in touch with him, but something had happened in Ukraine. So I had a pile of evidence, a CNC machine shop, and a vague idea of what I wanted to make. I built 2 near identical test rigs because I wanted one for the transmit and one for the receive. And here is one of them. Now, I don't know whether I can get the camera to do this, but I'm going to give it a try to give you a quick run round. So, extension lead needed. Let's zoom him out a bit. So we've got the giant mirror drum here, which has 16 mirrors all around the periphery. I've actually missed 2 out so we can see inside. And there's a bearing system, and then down underneath in the dark, I don't know if we'll be able to see this at all. No, that's too dark. But there's a belt tensioning mechanism. Can we get that to come up? It doesn't want to focus, does it? Yeah, so there's the bearing and belt tensioning mechanism. And then there's all sorts of other drives and mechanisms underneath. and there's a separate driven drum which has a set of mirrors on them, and these mirrors spin very fast. So in the real thing, those mirrors need to run at about 4,800 RPM. This doesn't go quite so fast, so you don't need hard hats. But let's just give it a quick go and see if we can get it to spin. So that gives you a little bit of an idea about how the thing goes. It's actually got a magnetic sensor and a set of 6 magnets here. Now, I don't know whether I can get this to work on my oscilloscope. I think it's probably going to be a little bit too fast, but let's see if we can get it to work. Oops. So let's put this on the camera and see if we can get that. So it's triggering just above the top of the screen. There's an awful lot of noise in here, obviously, but it's giving a reasonably consistent waveform, and we're getting, when it's absolutely flat out, yeah, it's triggering nicely there. So noisy as hell, but it does give me a way of knowing exactly how fast this thing's running. I'm going to turn it off before it flies off into the distance. It can go really... Yeah, it does need to go quite fast to get the maximum speed. So in this thing there's 300 plus machined parts. Some of them, let's see if we can get this one to work on the camera. I don't know if that's going to play, is it? Yeah. So my little CNC machine had to produce one of these for the top of every one of those. Well, there's 16 of those, 16 at the bottom, so 64 of those little parts. And I had a lot of fun making those. Trying to do that manually, I mean, like Leon's chums did, it would have taken forever. So, on the day of the filming, I was still in the machine shop at 2:30 a.m. I've got history of this not finishing until the night before. And as a result of accidents and road closures, I didn't get to the hotel until 9 a.m. I was booked in the night before. So I breezed in, said to the receptionist, this is going to sound mad, but I want to check in for last night, please. Anyway, they took my money, and so I had a shower and a shave, checked out, and then joined the London traffic. So I was pretty much at the ragged edge by now. I kept going on adrenaline, much as I am doing now. The shoot was in a weird little church hall in Camberwell, less than a mile from where Logie Baird had been working on the televisor a century before. I complimented the team on their clever choice of place. They looked puzzled. It was a total coincidence. We set everything up in the hall and moved 200 metal chairs, a bit like these, but sharp, off the stage. The acoustics were absolutely terrible. It had high windows that let loads of light in that made it impossible to see anything. The long-suffering PA that was working with me found a ladder and some giant sheets of paper to make some blinds, and he clambered up and he was sticking these things up, and of course there were, as he had finished 5 or 6, the first one peeled. It was great. Then the team turned up, the lighting team and the camera team, and they said, we need some chairs in the hall. Magic. We did mention that we knew where to find lots of chairs, so they dragged them all back in, they set them up theatre style. Whenever I get to watch real experts at work, these lighting and camera people, it's a humbling experience. I always watch exactly what they're doing because I want to nick all their ideas. But they are painting with light, they really are. It's an extraordinary thing. Eventually we got everything set up, only to find that Hannah had been delayed by 5 hours. By the time she finally arrived, I'd only had a 40-minute nap in the previous 36 hours. She had a page of briefing notes and we had a chat, And they just filmed us nattering. Literally, we had a corridor set up down the middle as though it was the aisle in a theatre, and we were just chatting across there. Occasionally, lighting people came and pointed new lights at us. Then it was time to play with the tackle up on stage. So we got these two set up, big red velvet curtain up on the stage, and they lit it so beautifully. I showed them the waveform of the magnetic timing sensor on the oscilloscope. In the final shot, they used a shot of the scope, but with the mirror drum stopped. So it just showed noise. Kind of missing the point there, folks, but they seemed to be perfectly happy. I used the green laser to demonstrate the raster scanning, but accidentally shone the beam on the inside reflective surfaces of the mirror drum, and the effect was absolutely outstanding. It was like a full 3D hologram. Let's just see if I can, I don't know if I can reproduce this. It's not dark enough in here. Can't quite get it, but there were some weird diffraction patterns going on. It looked absolutely magnificent. The camera guy yelled and said, "Do that again." Eventually, I managed to redo the happy accident, and we got some fabulous shots. None of them were used in the final show. There's an emerging theme here. While we were shooting the bit about, when I was saying about the hand appearing, the cameraman yelled and he said, "Stop, do that again." Do what? Anyway, he said, you moved your hand somehow. Well, of course, I'd moved my hand, and the projector, one of the lighting systems was onto the projector screen. And as I said, and a great hand appeared. Of course, a great hand appeared. He said, "We've got to film that." Well, trying to do that reaction shot and the hand waving all synchronized for the 4th or 5th time, it was very difficult, but they didn't use that either. Anyway, we descended regally from the stage to film a bit more of the discussion. Oops. This was the point where the entire project, with all of its pain and suffering and stress and agony, became totally worth it. Cue Professor Fry.
This in the most complimentary way possible. The biggest nerd I've ever met. I absolutely love it.
And with over 300 individually hand-machined parts, it's been a labour of love from Neil too.
Yeah, well, what can you say? That's my brand image and merchandise sorted for the foreseeable future. So, 4 hours of intense panic and stress finally subsided. Hannah breezed off with her enormous entourage, and then we just had to clear up the hall. The team were hugely concerned because of me not having slept, so they booked me into a nice comfy hotel nearby. So I crawled round to the hotel, slept the sleep of the just, and went for a walk across Tower Bridge at 6:30 a.m. on the Sunday. Drove home through Docklands just as the sun rose over the Essex marshes. It was gorgeous, if Essex can ever be gorgeous. Less than 5 minutes of the 4 hours of footage appeared in the broadcast show, and some of that was completely irrelevant. But this was about telling a story at a snapshot in time to support a wider narrative, not creating a historically and technically accurate documentary record. As a subject matter expert, your role is to help the director and producer to tell their story of their vision. It has to be accessible to their audience, and it needs impact. It's got to retain their attention. So many times they stopped me and they said, "Can you just rephrase that for the BBC Two audience, please?" I can't remember what I said 30 seconds ago, but Hannah has this amazing skill where she can remember exactly what she said. I wish I'd got that, but a fantastic experience, even on take 5. To say that my experiences of being a media sock puppet have changed my life completely is no understatement. It's changed me as a person and given me opportunities I never imagined. Thanks once more to Heather Parsons and to the RSGB for giving me that initial chance. It's been one heck of a journey.
Thank you very much, Neil. What a great, entertaining story, a journey through tragedy to success to nerdism. It's just fantastic. So congratulations. So we've got no time left, but I think we should have 5 minutes for Q&A. So if anybody's got any questions, I can have a quick whiz round. Any questions for Neil? Put your hands up. One over
there. Charlie, GI4FUE. Just thinking about all this stuff that you've done and all the time spent. What do your wife think about it?
My wife's the reason for all this. She died in 2021. We've been married 37 years. And all that time, if I'd have said I want to do this, she'd have said, yeah. Absolutely, she'd have said, yeah.
Yeah, because my wife thinks I'm a complete and utter geek.
Well,
and gives me a bye-ball, so I don't
yeah,
care.
She knew what I was like. She knew what I was like. She still married me.
Another question.
Neil, I think you've been mentioning occasionally on the microwaves group, but do you actually still do your machining by hand, or actually do any CNC?
I've got a Sile X5 CNC machine, which in all, with everything and the software and all the tooling, has cost me a thick end of 40,000 quid. But it was, I got all the money from one of my pensions, and I thought, I'm just going to invest it in that, why not? I've still got all the manual machines, but that CNC, total game changer, absolute game changer.
Good. And we had a rare incident of the red flash at the department, so Hannah says hi, by the way.
Any more questions? One over there.
Yeah, hi Neil, Reg, G8VHI, how are you? Just quickly for me, have you signed the official Secrets Act with the BBC, or could you say have you got anything else in the pipeline?
Right at this moment, there is absolutely nothing that I am allowed to be aware of.
Any more questions? Okay.
Thank you. I often hear the words in my local radio club, sadly. What did the RSGB ever do for me? And you have said it.
Yep. Changed my life, absolutely. Heather's a complete star. She thought of me because of my messing about on YouTube, and somehow the BBC were convinced, probably because there was nobody else willing to do it.
One last question? No, okay. Neil, thank you very much again, and thanks to everybody watching at home and all around the world. I hope you found that very entertaining. You can check on Neil's YouTube channel, is that right, Neil?
Yep.
And see all the clips there, and there you go at the top of the screen there. Once again, a big thanks. Neil Smith, thank you. Last minute note, the centre is panicking. Some people still haven't checked out. If you haven't checked out, you need to make a dash to do that. It's now lunchtime.
I'm with John Rogers, M0JV, and you are the EMC chair, John.
That's right.
Welcome. I mean, John, so tell us a little bit about what the EMC committee does first, please.
Okay, well, first of all, perhaps we should clarify what EMC is, because EMC is electromagnetic compatibility, and that is something that's set up to ensure that electronic devices can work without interfering with each other. So what we're primarily interested in is the causes of electromagnetic disturbance, in particular radio frequency interference. So we try to provide a service to all amateurs, and in particular to RSGB members, to help and advise them on any problems they have caused by EMC or caused by RFI.
John, just before we talk about, I'm sure, how you're going to do that, how do people know that they've got problems with RFI, though? Unless someone complains, like a neighbour complains, which is probably one of the most frequent things that happen. How do you know if you've got a problem with RFI?
Well, there are two types of RFI, of course, David. There's ingress, which is them interfering with your radio equipment, and there's egress, which is you causing interference perhaps to their TV. Now, the latter of those, egress, has got much less as we've gone from analog to digital for a lot of equipment. So we have far fewer reports of egress problems than we do of ingress.
Okay, thank you. Okay.
So people who have problems, generally amateurs complaining about somebody's solar panels or whatever interfering with their radio, the way to do that is via the help desk, which is helpdesk.emc@rsgb.org.uk. And also, if you want to get at all the other information that we provide on the internet to help members, then you go to rsgb.org/emcc.
Can I just take you back a tiny bit though? So say a neighbour does, say you're at home, you've got a problem on your HF band, a particular band, and you're pretty sure it's a neighbour's maybe solar panel inverter, something like that or whatever. What is the right thing to do? Is the right thing firstly to come to you, or should the amateur try and have a look first at their neighbour's setup?
Well, the best thing to do is to go onto the website and to pick up one of the leaflets that best describes the sort of problem you're doing and try to get more information yourself. Now, there are two problems you're trying to solve if you have a source of RFI nearby. One is where is it, and the other is what is it. Now, sometimes it's difficult to work out what it is. It's much easier to find out where it is. And one of the things that we encourage people to do is to build a DFing loop. And there are details about this.
And I've got a printout here of the sort of thing you can use, so yeah.
But you can use this in two ways. One, it's directional, so if you point it at something, that will be a maximum like that and a minimum like that. And in fact, the minimum is very low, so you can see that very quickly. Or you can move to and away.
And what would we have at the other end of that? What would that be plugged into?
You can connect it either to your radio, if you want to, an AM receiver, a normal transceiver receiver of some type, or what we normally do is connect it to an SDR. Most SDRs will take an input, and then that gives you a picture on the screen of the interference.
So the SDR, they're one of these little ones that you see sometimes for about £50 or so, something like that, from some of the Chinese website and eBay and that sort of thing. I mean, just to explain to everybody at home as well, this is really something you can build at home, and it's not particularly difficult. You've got 900 millimetres of RG213 coax there, so that's fairly standard and sort of almost an offcut, isn't it? You've got a couple of, you've got a T connector at the bottom, and then you've removed the outer jacket there and braid at the top. It's just that some of this EMC equipment can look quite expensive, can't it? But this is something you really can build at home to help you with it. Okay.
And we encourage you to do it.
Good.
So having either found it or tried to work out what it is, you will come to the stage where you actually want to report problems to Ofcom. And one of the things that we've done recently on the EMC committee is we've been fortunate to have John Livesey, who was an ex-Spectrum engineer with Ofcom, come and join us, and he now runs the help desk. And we produced a leaflet called EMC Leaflet 18, which is on the website, Guide to Reporting Harmful Interference to Ofcom. And what this does, in simple terms, is to tell you the sort of information that Ofcom need, and in the language that they understand. It's no good talking about interference on 20 metres and with FT8, they don't understand.
Right, okay. So we've got to talk about and define it in a way, as you say, in the terminology that they'll...
And this is a guy who's come from the other side of the fence, who knows
with
what they want to hear.
With Ofcom, come back here. That's lovely.
So that's great.
He's very useful then. And again, the website on this, by the way, is rsgb.org/EMC. So, yeah.
2C.
EMCC, sorry, EMCC.
Yeah, so that's that. But really, a lot of our work is involved in trying to prevent equipment being designed with too much RFI. So we work on the standards committee, both with BSI, and we join with the IARU, and a couple of our committee members are in fact have taken the lead in IARU as EMC coordinators. So currently it's David Taylor, who's our secretary. And eventually we need to lobby regulators. to try and make sure and lobby suppliers to make sure that equipment is designed to minimise EMC problems.
Isn't it being done at the moment though, John? Because I mean, since I think it was in 1996, was it when the CE mark came in, and things got much stricter then. I mean, you know, equipment should be, the equipment that's behind us actually on these wonderful posters behind us, those should all be already have been tested and complied, shouldn't they?
Yeah, but one of the problems we find is that there's a joke about does CE stand for Conformance European or Chinese export. A lot of cheaper stuff that you can buy via the internet has the EMC components missed out. So they put them in, do the compliance testing, prove it's okay, take them out because it saves a couple of pence. And the worry is, and this is where we actually manage to cooperate a bit more through trading standards, is that they do similar things to some of the safety components in there.
Oh, wow.
So when we can link those two together, it's much better.
Yes.
But the other two things that we're involved in is mitigation, which is if you have got interference, what can you do to reduce it? You know, put ferrites on or put it together in a certain way. And also investigations. I mean, at the moment we're quite worried about some of the green power stuff that's coming in. Green power's great, but when you start distributing lots and lots of energy via DC and then you have to chop it up again to make it into AC, then you create lots of RFI.
And there's some of the, I've certainly heard people talk about some of the inverters that are available, which are the things that take the DC electricity out of the solar panels and convert it into AC to put into the mains. Those boxes can be make a lot of interference, can't they? Yeah.
And the way you install them is critical as well.
Right.
But the thing we're more worried about at the moment is the big wind farms or the big solar farms, which are like 1,000 times worse in terms of the potential energy of a single solar
I mean,
panel.
how do you test for that or manage that though, John? Because I mean, testing a piece of equipment on a bench with spectrum analyzer and things like that here is one thing, but a whole big solar farm or a wind farm being built, how can we as amateurs get involved with any problems that are created by that?
All we can do is to actually try and measure the level of the interference and then try and take it up. I mean, there is a level, it's always going to be there. You're only going to mitigate it by lowering it. You can also try to make your equipment less susceptible. A lot of people are now using transceive mag loops and locating them a bit more remotely, or even remote receivers to help them get over the problem. One of the things we're hoping to do is we did some work on VDSL. We're trying to get rid of VDSL interference at the RF level. A lot of people have got noise cancellers at the audio level, and what we did was we built a program called Leilantos, Martin Sack wrote it for us, which actually extracted VDSL, and then you could hear what was left after VDSL had gone. But fortunately, VDSL is being replaced by fibre to the premises.
I was going to ask this. I mean, in the next 5 years, I think it is, BT is saying there will be no more copper to premises.
And you can see the difference when it comes out. The one problem we do slightly have sometimes is that some of the suppliers of the FTTP routers use very cheap power supplies, and those cheap power supplies radiate. Fortunately, it's local to the house, but if it happens to be in your house, of course, it can cause you.
I remember seeing an article in Radcom a little while ago which had the pictures of the sometimes called wall warts or whatever, the little plug-in power supplies. And although the equipment itself could be made well, those power supplies, which are normally switch mode nowadays, aren't they?
Yeah, they have
to be efficient. They can create a lot of interference themselves. And this area that you brought again, which I think is a wonderful thing, because it's something that pretty much all of us could build for a few pounds. That's the sort of thing we could start to home in and tell where we're getting interference. You think from something like that?
That'll help you do that.
Yeah, good.
And of course, the other thing we do in the EMC committee is EMF. We did a tremendous amount of work when Ofcom brought out the new EMF regulations, and it continues. I mean, we've got the calculator, rsgb.org/EMF.
Right.
And you can get into the calculator, and it will do the conformance that you are needed with your license for Ofcom.
That must have helped a lot, because a lot of people were very concerned about that. For the first time, really, we had to formally report the details of our station, didn't we, in terms of EMF. But I know that calculator, you put a lot of work in your
Yeah.
team. I remember interviewing you way back when it
Yeah.
first came in, and now it's a really refined bit of information. So again, it's there for use.
Yeah. And we're going to do a bit more work in the coming year. We're particularly worried about the new higher power levels, and the fact that buried radials for verticals actually still radiate. So we want to minimise the exclusion zone where you can't have people going for systems like that, high power and radials which perhaps stretch to the edges of your property. So we're going to do measurements which will hopefully allow us to reduce the exclusion zone recommended by the calculator, and also mag loops. I mean, more and more people are using mag loops to help noise, but they have different types of field patterns, and we want to actually measure those. So we've got a good team going with Pete Zollman, who does the modelling, and we do the actual measuring, and then we iterate together to try and come up with it. So that's good.
Well, fantastic.
One last word of warning to people. If you report an EMC problem, the first question often asked is, can I see your EMF compliance document assessment?
So don't
call in Ofcom
until you've done that.
Until you've done it.
Although really everybody should have done that by now anyway, and keep it up to date as well. John, thank you very much for all the work that you and your team, and you've mentioned lots of names there, so there's obviously not just you, but we know that you're leading this team. We're really grateful for all the work you've done for us, so keeping us safe over the years and keeping us able to enjoy our hobby with all of the challenges of modern electronics all around us.
And one last advert.
Yeah.
There's only 8 of us on the committee and 8 consultants. There must be loads more people in listening to this or watching this who could actually come and help us, and we'd really welcome volunteers to come and join the EMC committee.
All right, thank you, John. Well, I'm sure that's been well heard. If you can help the EMC committee, that would be welcome. But John, thanks once again to you and your team for all the work you do. Thank you.
Thanks, Dave.
Well, for me, it is a fantastic source of information about the hobby. I mean, I came into this hobby knowing virtually nothing, and I've learned such a lot just by being a member of RSGB. So, you know, getting Radcom every month, which is some great information in there. And of course, there's a new app, which is brilliant. I really love that. And this weekend especially is fantastic. So much information, so much to learn in one weekend. I love it.
I think it's important to be a member of the RSGB for 2 reasons. So I think the first one is that the RSGB arrange a number of activities and contests and things throughout the year, whether you operate on VHF, UHF, HF, there's something for everybody. Secondly, the RSGB also liaise closely with Ofcom to defend the amateur radio part of the spectrum. And that's really important. If you don't have that, we can't operate the radio. So I think it's really important to be a member, and I really enjoy it. So.
Well, I've been a member of the RSGB for about 45 years now. I used to live in the UK, I've now moved to Ireland, but I find being a member and receiving a magazine is a very good way to keep in touch with what's happening generally in the hobby. I think the RSGB does a very good job in supporting the hobby nationally and internationally. I'm also a very active contester, VHF and to a lesser degree HF. I think the RSGB runs an excellent array of contests, and I'm at the RSGB convention this weekend, and it's great to put faces to the call signs I've been making contact with all year round.
Because I'm a member of a local radio club, and there's enough work in running a radio club, we need the national body to be overarching so that we've got another group to refer to. We haven't got to resolve all the questions within our local club without coming to a national body. So that makes life easier.
There's so many reasons. I've been a member for as long as I can remember, and I think recently the most important thing is the app. We can now get rid of that mountain of Radcom that it's been harder and harder to find a place to store. The app's brilliant. It goes through 25 years plus of Radcom. There's even some TR bulletins for those who remember them. I don't, obviously, I'm far too young for that. But I think that's one of the most exciting things of recent times. to support the organisation that supports us.
I'm with Bob Titterington, G3ORY. Bob, hello. You are chair of the ARDF committee, the Amateur Radio Direction Finding Committee.
That's right.
I'm sure most people know what amateur radio direction finding is, but for those who don't, can you just tell us a bit about it, please?
Okay. Well, it's a fairly straightforward concept. In general, competitions have 5 very small transmitters hidden in the countryside somewhere, a wood, a country park, whatever. And then the people taking part have to go and find them by using direction finding techniques. The fact that they have found them can be recorded by either having a control card and a needle punch, which they operate at the or it can be done electronically by a system called SI punching, where you have a chip on your finger and just put it into the box of where the transmitter is located, and that will record not only the identity of the transmitter, but also the exact time that you got there. 5 transmitters to find, each sending for 1 minute in a 5-minute cycle. And you normally have a time limit, usually about 2 or 2.5 hours, because what you don't want is some very eager, keen competitor still out there as darkness falls.
So this sounds quite serious. I mean, the beacons you're talking about, I know some people do build their own, but this is a specific one, is it, that your committee recommends or loans out, I believe?
Yes, the designs are fairly well established. The 80-metre design, for example, was designed by ON7YD, a Belgian amateur, at least 20 years ago, if not 30 years ago. And that's very widely used today.
And that's the beacon that sends out the transmission? And
that's right, that's the transmitter that has to be found. The other band that is used is 2 metres, and a rather different design, of course, for use on that VHF frequency.
And what is that sending out? I know that the people who are in the team have got receivers and things, and they've got to find these things, but what sort of information are these beacons sending out?
Right, they transmit a sequence of Morse letters, which might seem intimidating at first. They're an M, da-da, an O, da-da-da, and a number of dots dependent on the number of the transmitter. So number 1 will send out da-da, da-da-da, dit, 1 dot for number 1. Whereas number 5 will send da-da, da-da-da, dit, with the 5 dots. The da-da keeps the transmitter on the air quite a lot of the time, and that means you can, the competitors can rotate their receivers to sense the exact direction that they're receiving the signals. Okay,
well, it's obviously a really lovely hobby, and I remember when I last talked to you, probably a couple of years ago now, we were just coming out of COVID, and this was a wonderful hobby that, of course, part of the hobby that you could use with other people but do it safely outside. And I guess that's one of the attractions of it as well, that it's an outdoor part of the hobby?
The hobby has been recovering very, very slowly from the COVID restrictions. It's been one of the, it's been hard work to build the hobby back up. Although this year we've been particularly fortunate in that John, G0JJL, up in Lancashire, has started a good ARDF summer series of competitions for North Cheshire, Lancashire, Cumbria, Greater Manchester and so on. He's done a great job, and they this year, for the first time, had competitions in the summer months of 2025, May through to September. And hopefully in the future John will be able to build this and establish ARDF more positively in that part of the country.
Yeah, let's hope so. And I believe you've done rather well in a recent competition within the world of ARDF.
Well, that's right. The ARDF World Championships is held under the auspices of the IARU, the International Amateur Radio Union, and this year it was being held in Lithuania. And we sent out a very small team, but we're particularly strong in the M60 category. That is to say, people, men, that's the M, whose birthday age in the year begins with a 6, and in other words 60 to 69, and in that age category we came runners up to the Slovakian team in the team competition on 80 metres, and the boys brought home a silver medal.
Wow, that's really good. Is this the sort of hobby that is open to everybody? We've just mentioned some of the older members of our community, but I mean, I guess this is something that young people would find interesting and fun too.
You'd think so, but the age profile of amateur radio is changing, and the COVID crisis brought a lot of people from midlife into radio when suddenly they found they had rather more leisure time than they'd bargained for. And overall, at this convention, if you look around, then the age profile is very slewed to the older age groups. And if you come to an ARDF event, there's every chance that the largest 10-year age group that is represented is M70. And there's just a sprinkling of the younger age groups.
Well, it's still an inspiration, I'm sure, for people watching this who are of the younger age. Maybe they would like to get involved. I guess find your local club will be a good way. And also, of course, you've got a part of the website as well, Bob, which we're now putting on the screen. If you're interested in ARDF and want to find out more, you can contact Bob and see what your team do through that.
Just mention there's also an ARDF reflector, which is RSGB-ARDF at groups.io. Not much going on it at the moment, but when the season starts next year, starting in May, you can expect to hear up-to-date news and activities on that reflector.
Well, good. Well, it looks like something that really should be a great thing to start planning now for when the weather gets a little bit warmer in the spring. Bob, thank you very much for all the work you and your team do for ARDF. And
thank you. All right then. Cheers.
And now we're going to go over to GB3HQ and find out who they're working. And remember, if you do work them, then you can see your call sign come up on the bottom of the screen as well.
Next to me on the screen. Yeah, they're quite big. So many thanks for coming back. The operator name here is Mark, Mike Alpha Romeo Kilo, and this is the special event station for the RSGB conference.
Yeah, my pleasure to catch it, but this is at around this time a noisy frequency, but that's a skip between us. So thank you for your activity, and we'll be looking for you again. Delta Lima 8 Vector X-ray from the outskirts of Hamburg City going suicide. Dankeschön, bye-bye.
Delta Lima 8, many thanks, GB3HQ, QRZ. CQ, this is Golf Bravo 3 Hotel Quebec. GB3HQ, special event station for the RSGB conference from Milton Keynes. QRZ.
Yeah, QRZ. We call it Oscar Zulu, Papa Juliet.
Oscar Zulu station, go again, please.
Yes, mein Ruf nummer is Oscar Zulu, Papa Juliet.
I'm sorry, the huge signal next to you is causing a little bit of distortion in the audio. Could you go again a little bit slower, please?
Yes, okay. Mein call is in Denmark is Oscar Zulu, Papa Juliet.
And the number again, please. I've got the Papa Juliet. What was the number?
Number 4. Oscar Zulu 4 Papa Juliet.
Oscar Zulu 4 Papa Juliet. Many thanks for calling back in.
Yes, it is correct.
You're coming up to a 5 and 9 when that signal lets you. Yep. 5 and 9 definitely. Lovely.
In South Denmark it's 9:10, 10 plus fighting in Denmark, and you have your good modulation.
Lovely. Many thanks for the signal report from Denmark. Have a lovely day on the radio.
Yes, okay. Yes, my radio is on ICOM. ICOM 7300, and the tribal microphone is on ICOM serial mic 8. And my antenna is the homemade end-feed antenna.
Roger, Roger. This is, we're working from a Flex 6400 into a KPA 500, pushing about 500 watts through a dipole up at about 10 to 12 meters.
Yes, okay. This is good. This is very good, yes. So, yes, of my ICOM 7300, I have 100 watts of my antenna.
Lovely, 100 watts. Well done, that man. Many thanks for calling in. Take care, and 7-3.
Yes, okay. 7-3. Take it easy, you and your family, and a good day, and thank you for your show. Bye-bye.
Many thanks. GB3HQ, QRZ.
Mike Whiskey Zero, Golf Whiskey Lima.
Mike Whiskey Zero, Golf Whiskey Lima, was that?
Roger, Roger. The name is John, Juliet Oscar November, location about 10 miles north of Cardiff, just at the start of the Rhondda Valley there, back here.
Roger, John, you're hitting me with a 59510, lovely clear signal. Roger, John, you're hitting me with a 59510, lovely clear signal into Milton Keynes.
Roger, Roger there, Mark. I was just about to say the same for yourself there. You're 10 over 9. Absolutely lovely signal, lovely clear audio from yourself. And yeah, well, I wish you good luck for the rest of the day, Mark. I'm not going to hold you with you. I know lots of people will be calling you there, Roger.
Many thanks for the contact. Have a great day on the radio.
Thank you, Mark.
GB3HQ, QRZ.
G7MNN.
G7MNN. Is that Mike November?
QSL name here is Simon, located down in the New Forest, just back from disastrous field trip to Spain. No, the weather was lovely actually, and you've got a lovely signal here, so just thought I'd get back on the radio and check in there, over.
Roger, many thanks for the nice report. You are 5 and 9 with a lovely clear audio into Milton Keynes. Apologies about the problems in Spain. That sounds terrible.
Yeah, you're a 5-9 plus 20 to me. Anyway, I'll let you carry on. 7-3, thanks for pulling me in there.
Many thanks for the contact. 7-3. Golf Bravo 3 Hotel Quebec, QRZ. There was an X-Ray Sierra in the mix there. Could the X-Ray Sierra try again?
Golf 0 Oscar Sierra X-Ray. Your 5-9 plus, lovely signal, and great to have a contact with the convention. Name is Norman, QT8 is near to Heathrow Airport in Ashford in the county of Middlesex. GB3HQ from Golf 0 OSX.
Golf 0 OSX GB3 HQ. You're about a 5 and 7 to me currently in Milton Keynes. Many thanks for the call. Golf Bravo 3 Hotel Quebec, special event station for the RSGB conference, QRZ. Mike 0 called in there. Could the Mike 0 go again, please?
Mike 0 Zulu Golf Yankee.
Mike 0 Zulu Golf Yankee. Good afternoon.
Yes, good afternoon. I think I popped in yesterday and just telling you all the band, so I thought we'd pop in and say hello again. You're 5 and 9, going to the county of Cornwall, top end, over.
Roger, many thanks for the 5 and 9 into Cornwall. You're 5 and 9, pushing towards 10, but not quite getting there, into Milton Keynes for the RSGB conference.
Yes, QSL, well, thank you for picking me out. You have a nice day, over.
Roger, Roger, you too. Many thanks for the call. GB3HQ, QRZ.
Golf 7 Bravo, Quebec, Mexico.
Golf 7 Bravo, Quebec, Mexico. Good afternoon, sir.
Yeah, good afternoon. Name here is Ted, Tanker Echo Delta. You're 5 and 9 plus 15, located 2 miles south of Watford Gap, so not that far away. Thanks very much for putting the station on the air. Back to you, GB3HQ, G7BQM.
G7BQM, GB3HQ, you are 5 and 9 into us, cutting through the noise beautifully. Many thanks for coming back to us and have a great day.
Well, for the second time this weekend, you join us in the special interest group room, which is actually just below where I'm normally sitting upstairs in the live stream studio. And it's a room full of special event groups, or special interest groups, rather, I should say. And with us first to talk about their group, which is the Work Tool Britain group, we've got David Brooks, G4IAR, and Paul Lewis, M1 AIB. Hello, both of you.
Hi. Okay.
So firstly, do tell us about Work Tool Britain, for those who don't know.
Well, it's cool. We've got a raft of awards within the scheme, but basically we're based on the Ordnance Survey map references and the trig points, for instance, on which the whole system is based historically. We've introduced a few new awards this year, such as the Historic Counties Award, Postcodes Award, Multi-Band Squares Award. So
tell us what the difference is between those and other ones. I joined you actually a couple of years ago from meeting you here, and I'm often you send me updates as well, don't you, of the books regularly as well. But so tell us about some of these new awards. What's the different about them?
Well, the Counties Award, we've revived it from we used to do it years ago, but we dropped them in 2009. Because of the consistently altering the county boundaries, renaming counties, creating unitary authorities. We've decided to go back in history a little bit and use the historic counties. Now there are utilities available on the internet which you can determine which historic county you're in, which we hadn't before. The Postcodes Awards we've never used before, that's totally new. The Multi-Band Squares Award, now we can count if you work a square on 40 and also on 80 metres, for example, and 20 and any other band. You can add those totals together, which we've never done before. So
new things you're adapting all the time, just like the hobby is adapting, isn't it?
Really, yeah. Try and keep it interesting, basically.
Yeah, I mean, Paul, what do you think is what's the next sort of thing that you're going to look at in WAB?
It's very difficult to say, actually. You're probably asking the wrong person. I mean, David really.
I'll go back to David then. That's
I hate to do it to him, but David really is the core of WAB at the moment. As the awards manager, he does so much. And he's certainly, and I don't know where he finds the time being retired, frankly. But
I know that feeling as well.
He spends his time just coming up with his ideas, and most of the rest of the committee, to be fair, we get these messages from Dave saying, I've had this idea, had that idea, and generally speaking, it's like, yeah, it's a great idea.
Well, it's obviously moving ahead. Just one quick before we move on to the next group we're going to meet. How do people get involved? How do they join?
Basically, find us online. Work Tool Britain. Just Google Work Tool Britain, you'll find us online. If you want to join, you can join online. It's, I think, £8.50 now for a book package. It's a lifetime deal, so once you're in, that's it, you're in. It's a bit like living in Northern Ireland in some ways. But once you're in, it's a one-time, lifetime. You get a book number, that becomes collectible as well as the squares, which is always a benefit. Come and join the mayhem on the nets.
Lovely, wonderful. David, Paul, thanks very much indeed. Now we move along, and I'm not going to stand with my back to you anymore. I'm really sorry about that. You looked at me daggers then. Anyway, about to talk to you both. So we're with Sharon Lewis, 2E0SHZ, and you're from Bailara.
Yes.
Now, from anybody who doesn't know what Bailara is or who it is, tell us what Bailara is for.
We are the British Young Ladies Amateur Radio Association, and we promote women in this very male-dominated hobby. We promote fun and friendship. We come along, we do as many rallies as we can every year, myself and Judith, and we try to get women to join us and just promote amateur radio. It's such a diverse hobby. I mean, you've got satellites and you've got the space aspect, the ISS, you've got RayNet, you've got all the IOTA activities, you know, on the air, OTAs and all of that. You could, so yeah, and hopefully in the next year we can reopen our contest section of the group. We're hoping to bring a young lady on board who's very, very much into contesting, and hopefully we can get some ladies interested in contesting.
I'm going to ask something. I hope it's not controversial, but
No.
it feels from a male point of view, and I agree, certainly it's male dominated. Just looking around this room, it's male dominated. There are more males involved or not. But the world in general is now, I think, it's changing, isn't it?
It is.
And it's becoming more balanced, hopefully.
Yes.
So that
before COVID, there weren't many there were ladies, but there weren't many. Since COVID, and with the RSGB's help, more women are becoming radio amateurs, and I suppose that's because men were having to stay at home during COVID. They got onto the radio more, and the wives inadvertently during the day, children at school, they could, oh, what's this? What's going on? Oh, that's interesting. And then they saw school children talking to Tim Peake on the ISS, and it's like, oh, wow, my child could do that. So yeah, I mean, I've just been upstairs and listened to the ladies' panel. Very, very good. And now STEM are helping to bring younger people into this magnificent hobby, and long may it continue.
And it is young people, it's not just boys, it's boys
it's
and
girls,
well?
yes. Can I just say that earlier on this year, while we were at Hamfest, a young lady came to Lara's stand, and she must have been about 11. And I said, hello, would you like to join us? And she said, yes, very much so. And I went, okay. And her dad came and stood behind her. He's a radio amateur, and he says, this young lady here holds a record. And I went, really? What's that? And she said, I am the youngest non-radio amateur to have spoken to the International Space Station. When the astronaut she spoke to came back down to Earth, he called her up and invited her and her family to Houston and gave her the tour around NASA. And this young lady was spectacular. She really, really was. She's joined by Lara with her dad, and hopefully, if she's not done already, she's got her amateur licence.
Wonderful. Well,
so we're thrilled with that.
Thrilled, and that's inspirational, and you're inspirational. Thanks for all you both do, and all of you do.
Thank you very
for
much.
Young people into the hobby. We've put the website up at the bottom of our screen now, so if
That's
anybody's
fantastic.
interested, a lady in particular getting interested in amateur radio,
absolutely,
do contact
absolutely.
Lara. Thank you very much for joining us.
Thanks.
Sharon, thank you. Right now, I've moved a long one, and here we're with the UK Microwave Group. We've got Brian Harbour, G8DKK. Hello.
Good afternoon, David.
So, Brian, tell us about the UK Microwave Group then. I think most of us would know what microwaves are, but maybe not what the group does.
Well, yeah, that's right, because there are a very large number of microwave amateur bands, far more than there are in the lower part of the spectrum. So we obviously promote operation on all of those bands up to the Ofcom limit, which is around 240 gigahertz, and some of our members play with frequencies above that.
Let me just say that again, 240 gigahertz.
Gigahertz, yeah.
That's quite high.
It is quite high, yes. So, but most of the operation, of course, or the majority of people in the group are operating lower than that. So what we do is build and provide propagation beacons, because we need them for each band so we can test out systems and propagation paths. And apart from that, obviously arranging contests for the microwave bands.
But I mean, for an absolute beginner who's just maybe a bit bored with HF or VHF or whatever, the usual sort of things, and wants to try something new, how would they get started? Firstly, they can join you. How much does it cost to join?
The annual subscription is £6. Right.
That's affordable,
Very
£6.
small, yeah.
Okay. And what are they going to get when they get their membership?
Well, they've got access to, obviously, I'll say a monthly newsletter. I think we guarantee 10 copies a year, which is downloadable. And they also then have access to some other facilities, something called the Chip Bank, which is totally free to members, including the postage. You can order chip components. There's I don't even know the quantity, but
it's a lot, is it?
It's a lot. Yeah.
Okay.
Most of it donated. So that's another facility.
And look, you've got a leaflet here as well, and you've got some other some of the bits and pieces. You make some kits, don't you, and things available. I'll get out of the way.
A slightly newer venture is to have a web SDR running, which many people will know is getting fairly common on HF and up into VHF. This particular one is new, and it's...
I'm looking at the frequencies at the top, which probably our viewers at home may not be able to read.
It's at 24 gigahertz.
Yes.
And this one is a beacon, which is at on a Martello Tower at Clacton in Essex, and the web SDR is on top of a high-rise building in Margate in Kent, so it's across the Thames estuary, and that signal is what we're receiving. Yesterday it was quite weak, today it's quite strong. It would be fun, but it won't happen if a big tanker went down the Thames, and that would disappear for a bit.
Wonderful. Well, it's a great group. I know. I've joined myself, again, from coming here a few years ago and just seeing what you do. It's a great way of learning about microwaves. As I say, we'll put your website up and everything, and thanks very much for all you're doing for the hobby.
And we also have loan equipment for new people as well to try out.
Useful as well, because it can be quite expensive, some of it, can't it?
It can be, some of it, yeah.
But you can also build things quite low cost.
You can.
Right, lovely. Thanks very much.
Okay.
For joining us today. Now I'm going to move along to BATC, I think, straight away to BATC, which will be this way. Hello. Gareth Evans, you're the new chair of the BATC. I know that because I'm a member of the group.
Yep.
Good to see you.
Yep.
So tell us a bit about BATC. Again, for people who don't know, British Amateur Television Club, what's it about?
Well, it's the new wave of sending television pictures with audio and full colour in reduced bandwidth, basically. There's a whole range of self-build stuff based on Raspberry Pi 4s, touchscreen control. There's free software for them and the PC. You can operate on all bands, right the way up to 24 gigahertz and beyond. Very much accessible. Difficult PCBs can be bought from the shop, and key components for the receive section, which is called a Pico tuner. There's also a very nice quarterly magazine and details about joining the club. On the back of the magazine there, batc.org.uk. Student membership is free, so we're trying to encourage younger members to join the ranks.
It's actually relatively inexpensive as well, because an online membership, I think, is £8, isn't it, a year?
Yes, that's cyber membership.
Yeah, but the paper magazine's a
little bit more, yeah, but student membership.
Can you take us through some of these wonderful things that you've got on here? I think we can get in close enough, although we seem to have lost our cameraman, which I don't know why.
Yeah,
but anyway,
he's done a runner. Okay,
well,
this end is the international...
Stand back a little bit, Gareth. Sorry, then we can see with that camera. Yeah,
this way?
Yep, that's fine.
Right. Okay, so over here we've got the International Space Station television ground station. It's running on a loop at the moment from when Tim Peake was up there and gave a very successful contact. There's some pending. It is working now. We're just waiting for live video with pictures on it to come along. Along here we've got the development of the Pi 5 Portsdown. It's still work in progress. That's this one here, yeah. Same concept. It's touchscreen controlled. That's a Langstone running on the same hardware, which is a narrowband transceiver, really handy bit of kit if you want to play microwaves as well. Moving along, we've got FM drone TV. It's a very cheap way to get into the hobby. Lots of home-built gear, amplifiers, power supplies, antennas, casings, software-defined radio, a laptop running receive, all the accessories you can build yourself. PCBs available.
I mean, this does look, and it is very sophisticated equipment, but you don't have to know too much about it, do you?
No,
to build it.
The starting point is basically just a Raspberry Pi and a touch screen, and from there you can add on bits as you wish. It's a growth hobby.
Yeah, it is a growth hobby. I mean, it's changed an awful lot, hasn't it? When I started in BATC a long, long time ago, we used to meet, actually. I remember they had rallies at Bletchley Park. And
That's right.
And we were still trying to use basically FM for transmission, using lots and lots of bandwidth.
Yeah.
But these modern ways, you mentioned at the beginning, that it does take very low bandwidth, really.
Much reduced bandwidth, I mean,
really good quality signals.
The quality achieved, I don't know why the broadcasters don't latch onto it, because they're missing a trick here, I think. The bandwidth, so we can go down to 100 kilohertz bandwidth and have full color, motion video and sound in really quite remarkable quality, and just 100 kilohertz of bandwidth on 2 meters or upwards, right the way up to the microwaves. And it can be home built. It's very accessible. It does rely on software-defined radio as the kingpin, really, of generating that signal, but the control of it from a Raspberry Pi 4 and a touch screen, it really
wonderful. So just for a few £100 you can get started. Gareth, thank you very much for joining us. We've got your website at the bottom of the screen right now for anybody who's interested in it. Thank you very much for joining us today.
Pleasure.
And now we're going to have a look at a video.
Manic. There's nothing wrong with the dipole. Dipole is always a very, very dependable antenna. And thanks for taking the call. I'll make this my final because she who must be a maid has been calling me for lunch, and I am within the danger time because she has stopped calling. So that's a worrying time when things go quiet. So listen for your final, Marek, and then I'll say 7-3. Go.
Right, thank you for calling in, and have a good lunch. 7-3. Golf Bravo 3 Hotel Quebec, QRZ.
Bye-bye.
Hello, I'm here with Martin Baker, G0 GMB. Martin's a member of my senior team at the RSGB, and he's the RSGB's National Radio Centre Coordinator. Hi, Martin.
Hi, Steve. Good to be here with you.
Excellent. Now, it is an interesting chat, really, because you and I talk about the National Radio Centre all the time, of course, but I think it's a great opportunity for us to tell everybody a little bit of the background of what goes on at the NRC. We're always promoting the NRC, we put it in Radcom, we do everything like that, but it's good to have the behind the scenes chat, I think. So I just want to start off with, what sort of visitors do you see at the NRC?
Well, the visitors are very varied. A lot of the visitors are people who come to Bletchley Park for a day out, and that's one of the great benefits for the National Radio Centre being at such a prestigious location. We see anything between 100 to maybe 600 visitors walk through the NRC doors every day, and that could be up to around about 80,000 or more in the year. Obviously we get visiting radio amateurs, not only from the UK but across the world. I mean, American, Australian, Indian, Canadian. You name it, we get a fair number of visitors visiting radios.
Let's just pause and think about that for a second. Though 80,000 visitors a year on average. And that's, you're introducing amateur radio or reminding people about amateur radio to 80,000 people a year.
That's true.
I can't think of anywhere else in the world where that happens. Right?
And I find a number like 80,000, you can kind of quote it, but actually I was sitting the other day watching a football match and they panned around a stadium and they said there were something like 70,000 people there. And when you look around that stadium and see just how many 70,000 is, you realise how many people have been through the NRC.
It's a huge number, isn't it? So tell me a little bit about what we actually have at the National Radio Centre.
Well, we try and do a number of things there. The first thing is, for the visitors who have been to Bletchley Park, it's about giving them a degree of continuity, because they've come to Bletchley, it's a decrypting centre, but none of those messages would have arrived unless there'd been radio intercept operators. So when the visitor first walks in, we try and give them that degree of continuity. Why are we at Bletchley, and the type of equipment that was in use in the 1940s era. But of course that makes a really interesting comparison when you look at modern radio equipment as well. So there's that initial introduction.
So you're trying to have that whole range though, from the history through to the modern, is that right?
Absolutely, and we've got a timeline which talks about the development of varying technologies throughout the years. From the very early days through to space communication. We've got a technology area that explains the basics of how wireless radio works. Importantly, we've got a spectrum display which talks about the different uses of the spectrum, and I think it's really important today because people often are not thinking about traditional radio as you and I might have done, or our mum and dads might have done, tuning the dialing knob up and down. But the spectrum's in use by so many different aspects these days.
Wireless technology is a good term for it, isn't it?
Yes.
Really though, you never know who's going to walk through the door, do you? So if you've got a broad range of things, you can try and direct visitors towards something that will interest them.
And they can relate to as well. Yes, that's right.
Okay. And I know you've gone above and beyond the typical sort of museum visit, right? So I know there's lots of practical things to see. There's the active radio stations. It's not just one. There's multiple. But you've done some other innovations as well to try and give visitors something interesting to do, and which involves sometimes going around the rest of the site.
Yeah. So I mean, as an example, we developed this Find the Spy transmitter event. So that's a number of small transmitters that are located around the Bletchley Park site, and families come in, they take a receiver, direction finding. The spy transmitters are transmitting an amateur radio call sign in Morse, so they've then got to listen to the Morse signal, write it down, come back to the radio centre, look it up in qrz.com and answer questions. And it's a great way of introducing people to the radio side that maybe wouldn't have come in necessarily before, and introduce them to things like call signs, prefixes, countries, and
very gently with something that it interests them and a bit of competition. I know you've had instances where two different groups from the same family have been competing against each other.
Absolutely, we have to make it quite clear this is not there is no running. These transmitters are not hidden in dangerous places. So we have to.
I know you also do some visits for clubs and things like that. I know you've got a separate book for amateurs that visit. And when I'm over sort of in Dayton or Friedrichshafen, a lot of the international visitors say they absolutely, either they've been to the National Radio Centre and they love it, or they're planning on coming, and that's one of the reasons they want to go. But more closer to home, then club visits and things like that.
So we get some clubs that visit during the museum opening hours. And that's absolutely fine, because remember, RSGB members can download their free entry voucher, and that gets them not just to the radio centre, but it also gets them to the whole of Bletchley Park, which is a huge members' benefit. But some clubs want to actually get some more hands-on time and get a closer affiliation with what's going on. And then we will organise private evening visits for a club. Not just radio clubs, but we have Scouts, Guide and Cadet groups that will come in the evening.
And we even have YouTubers coming in to do live streaming
we did.
this last week.
We did indeed.
We've had somewhat of a busy week, let's be honest. But I think was it Wednesday? I think it was Wednesday, wasn't it? We did the live stream. So GB3RS was on the air from the National Radio
And wasn't
Centre.
that amazingly popular? I mean, it was just pile-ups that were coming in.
The two guys that were running it kept saying we didn't expect the pile-up to be that big.
Absolutely.
And I think we did. Because to be fair, GB3RS during the normal operations is there as a demonstration. We don't actively sort of work numbers of people or anything like that.
No,
but it's there to show people, isn't it?
It is, but with the new licensing conditions, it does mean we can actively get people involved in the radio. Of course, we were always able to get them to pass greetings messages under supervision, but now, of course, they can actually run the QSOs themselves. And we try and manage that as best we can. It's not for everybody. Can you imagine when you first started and first QSO, most of us were really mic shy.
I can think back quite a while, but yes.
but that's when we got the license. So you imagine a person who's just walked in for the day.
No, that's right.
So they can be really quite mic shy, so they need a little bit of help and feeding.
But I've seen people, when I've been there, fascinated by things like QO100. And you use that to explain a little bit of the science as well, don't you?
We do, and it's great because first of all you can say to somebody, has your voice been into space? Have you talked through a satellite before? And so therefore there's a little element of excitement about that. But then of course they hear the delay of the signal coming back, and that's a great opportunity to talk about the speed of electromagnetic waves. Now, of course, sometimes we can have a little bit of fun with the visitors because we will say, well, the satellite's that far up, and what do you think the delay might be, and what's the speed of electromagnetic? Because that's a great way with students that come in that are maybe studying physics or similar science subjects at school or college or university. They're quite quick to pick up about the speed of electromagnetic waves.
And you put them on the spot. I've seen you do it, and see if they can do the calculation at the time.
Yes, indeed.
Excellent. But I want to come back to, you never know quite who's going to walk through the door, do you? And I know you have lots of people with history and knowledge and things like that. You have other radio amateurs. The whole, pun very much intended, the whole spectrum of visitors.
And that makes it interesting because we then have to be a little bit careful about how we talk to these people, because you don't want to start in a very simplistic way only to find that you've got a very knowledgeable person coming. But also, on the other hand, you don't want to talk too high a level to a visitor who knows nothing. So there's a lot of gut feel about this.
You've had lots of people over the years who've come in with little snippets of history for Bletchley Park as well, haven't you?
And we've had people bring in where they found artefacts in their father's or grandfather's lofts, and then they bring them in and say, well, do you know what this is, or how did that work?
One of the biggest attractions, and I know because you and I both speak to Bletchley Park and the management team there and all of the visitors that come in, is they really appreciate the conversations with the volunteers that we have there, because they're very knowledgeable as well. They're all hugely enthusiastic about greeting the visitors.
Knowledgeable, passionate.
And so we go above and beyond what you might call the modern museum, where you press the button and you watch a video, and great displays, and that we've got some of that, but actually having that personal interaction with people, that really pays dividends, doesn't it?
It does, yeah, very much so. It means you engage with the visitors and you can inspire them, and so often they want to know that much more.
But the feeling that I get whenever I go there is those volunteers, they absolutely love doing that. They love meeting the people. And I hear the same from the visitors. And you got an award recently, I think.
Yeah, we did. We got a TripAdvisor award for being one of the top 10 sites across the world for visitor reviews.
So again, let's do that. Let's pause. You get 80,000 visitors a year. TripAdvisor are saying it's a fantastic place to come to. And we're talking about something that's showcasing amateur radio, right? nowhere else in the world, I've said it before, nowhere else is doing that.
Nowhere else is doing it. And you know what, in some respects, the most kind of inspiring thing is it's the Americans which say we have nothing else like this, and, you know, and to hear them say that.
Absolutely. They want to come, they definitely. When the ones at Dayton, as I said, they want to come. So I know you're always, well, it takes, is it 65 volunteers you've got
We've
now?
got more than 65 now, yeah. So we're open every day of the week.
Yep.
We try to have between 3 and 4 volunteers on duty each day.
Yep.
Some come in once a month, most come in once a fortnight, some come in once a week, but to do that it needs a very strong and very dedicated team of volunteers.
So we're always looking for volunteers that are very keen, because there's usually quite a turnover, but we're always looking for volunteers to do that. And we would encourage anybody that wants to volunteer and is good with people and wants to share that enthusiasm.
And that's the thing. You don't have to be hugely knowledgeable.
No.
You have to be enthusiastic. You have to be able to engage with the visitors. And one of the great things the volunteers do is they enjoy the camaraderie of working with other knowledgeable people, and they learn. Amateur radio is such a diverse hobby that you can learn from your fellow volunteers.
I know there's some competition between the different teams as well on the different days as to...
Oh yes, one class is themselves the A team, the next is the A+ team.
Absolutely, brilliant. Okay, Martin, it's been fantastic talking to you. Here, when we've had the opportunity to sort of share publicly all the work that you do. So a huge thank you for what you do and the volunteer team that works with you. I think the whole amateur radio community appreciates it.
Well, that's very kind, thank you. But we really appreciate all the work the RSGB does to support the NRC and to promote amateur radio.
Yep, absolutely. Okay, thank you very much.
Thank you. Welcome to the RSGB's National Radio Centre. We have a great team of volunteers who are always happy to explain more about the displays. They'll also tell you how you could get involved in amateur radio and give you tips about taking your foundation licence.
I think the best thing is the people.
The NRC gives me a chance to explain to people, to educate people, to entertain in some respects. But we also merge that with the history behind amateur radio and radio in general that goes way, way back to the stuff that Marconi played with all those years ago.
And then I learned from the visitors as well, because some of them, their fathers or grandfathers have worked at Bletchley Park or with the Radio Security Service, and it's very exciting for them to see, say, the radios that perhaps their grandfather had worked with during the war.
I volunteer here because it gives me the face-to-face contact with other radio amateurs and the visitors here, and to see how much delight they take in learning more about radio and how it underpins such a lot of their daily life and the technology they use.
I like to ask the children if they'd like to send their names in Morse code. I coach them through the process. Most of them can do it very well, almost instinctively, and then we give them a little certificate at the end. And that allows them to take that home and to say that they can send their names in Morse.
We're using the new licence conditions by enabling the public to actually go on the air themselves, say a short contact on D-Star of the United States, and hopefully they'll be stimulated to go away and get their own licence.
I explain about amateur radio, what it is, how to get into it, and how cheap it can be to get started.
The National Radio Centre is not just about radios, it's about the social side of it, to get visitors to meet the technology, sometimes for the very first time.
Yes, the team here at Bletchley Park, or the NRC, is very friendly team. Lots of knowledge across lots of different aspects of amateur radio. So I've particularly learned things about the satellite systems, low Earth orbit satellites, and using the Oscar 100 various other aspects of the hobby. There's a lot of knowledge and you can learn a lot about amateur radio and different aspects of the hobby.
Volunteering at the RSGB's National Radio Centre is hugely rewarding. Perhaps most importantly, you will be giving something back to the hobby by helping to encourage a new generation of radio enthusiasts. You don't need to be highly skilled, just have an enthusiasm to talk to people and explain about amateur radio. We'll give you all the training you need and you'll be joining a team of volunteers with a great team spirit. Interested? Get in touch.
Engaging.
Very stimulating.
Involvement.
Delightful.
Fun.
Brain-wise, but yeah, the call again is Golf 8 Juliet Kilo Romeo, G8JKR, over.
Yeah, QSL, I've got it now. Golf 8 Juliet X-Ray Romeo. That's absolutely fantastic. Yeah, like I say, it's my years putting letters together which don't exist. But you're a fantastic signal. 5.9 plus 20 to me, to be fair, to Kent Hills in Milton Keynes for the RSGB convention. So fantastic to get you in the log. Name here's Ben. My normal call sign Golf Whiskey 4 Bravo Mike Lima, but I'm using Golf Bravo 3 Hotel Quebec today. G8 JXR GB3 HQ, over.
Yes, GB3HQ. Yeah, you may have got the call wrong again. The middle letter is Kilo, so it's Golf 8 Juliet Kilo Romeo. But yeah, report on your signal. You're 5 and 9. We're not too far away from you, actually. The location is just to the west of Bedford, about 3 miles from the centre of Bedford. So I think that, as the crow flies, probably puts us about, 18 or 19 miles away from you. So it looks like the signal is going straight up and coming straight down again. But yeah, subject to you getting my call sign, I won't keep you. It's good to get you in the log here because the GB3HQ is quite a rare one to have. But I couldn't resist the temptation to give you a call. So back to you, GB3HQ G8JKR, over.
Yeah, QSL G8JKR from GB3HQ. Yeah, all noted now, and the correct call sign's been put down. Yeah, no, it probably is because you're quite close, hence why the signal. But yeah, you're fantastic signal and great audio. Well, thank you ever so much for giving us a call. You're right, GB3HQ is I suppose a bit of a DX. Some people will say. You take care, all the best, and I'll wish you 7-3. G8JKR from GB3HQ, over.
Yeah, thank you very much for the contact there. I hope you enjoyed your time on the radio. It must be good fun at the convention. I did call in yesterday, spent most of the day there, so quite a good convention again this year. Okay, 73.
QSL, you take care, all the best, 7-3. Okay, Golf Bravo 3 Hotel Quebec, standing by.
Oscar November 1 Kilo India.
And station with November 1, go again please.
Oscar November 1 Kilo India.
Okay, just struggling on the last bit. I've got Oscar November 1 Kilo. Oscar November 1 Kilo. If you'd like to just repeat the rest of the call sign a few times, over.
Yes, certainly. Oscar November 1 Kilo India. Oscar November 1 Kilo India.
Yep, QSL, all noted now. Oscar November 1 Kilo India. Yeah, good afternoon. I hope you're keeping well. Calling from the RSGB convention at Kent Hill in Milton Keynes, and you're 5 and a 5, 55 to me here. Over and over.
Roger. Well, I'm receiving you 5.9. It's very solid 5.9. Very well above the noise level. My name is Chris, and I'm receiving on a full dipole. That's in the Arctic. I'm running at the moment about 25 watts power, so maybe that's because you don't have the full 5.9 on the other side. How do you copy now?
Yeah.
And welcome back to the Livestream studio here at the convention. We're now going to have our penultimate talk of this afternoon, Polar Modulation SSB, High Performance and Efficiency at Low Cost with Hans Summers, G0 UPL.
And welcome to this lecture on Polar Modulation SSB by Hans Summers, G0 UPL. This lecture is about to introduce you to the concept of Polar Modulation SSB. If you're at the gala dinner last night, you'll have heard the painful progress that was made by Hans in achieving this. So we're going to hear about Polar Modulation SSB, along with the story of the practical implementation of Polar Modulation SSB in his QRP Labs, QMX and QMX Plus transceivers. The significant benefits of polar modulation will also be discussed, and it all leads to higher efficiency, lower cost and higher performance, I understand. So Hans was first licensed in 1994 as G0 UPL. He's a keen home brewer. It may surprise you to learn that he's never touched a commercial rig. Never operated a commercial rig, and after a 22-year corporate career in IT banking, Hans now runs QRP Labs full-time from his home in Turkey. So Hans, over to you.
No, it is working, okay. Yes, I shall try to explain some technical details behind polar modulation. It's not a terribly easy thing to understand, but we'll see what we can do. So just a little bit of history. Back in 2017, the RSGB were looking for some suggestions for the YOTA Summer Camp Buildathon in August 2017, which was hosted by the RSGB, and ended up building the QCX, which is the one in the middle. At the time it didn't have an enclosure, that was the later edition, and that led to the QCX Plus and the QCX Mini on the left there. Those are single band analog monoband CW transceivers for QRP, so 5 watts output. And then in 2021 I did a very high performance embedded SDR digital transceiver, which was called QDX. Very small, it's about the size of a pack of cards. I won't say pack of cigarettes, but something like that. And it covered 5 or 6 bands with diode switching between them. So very economic, very efficient, very high performance. And then later in 2023, I married them together and made QMX. The M was for marriage, and marvelous and magnificent and all kinds of different things. And the idea originally was that it would cover just CW and digital, and later the SSB was added to that concept. Initially there were versions that covered 5 bands from 80 meters to 20 meters, but now we have also 60 to 15 and 20 to 10 meter versions. This is a nice picture of that. So 3 to 5 watts of QRP, and includes all of the features that happened in QCX, like the dual VFOs, full break-in, S-meter, but it's also got S-meter, power meter, SWR meter, all kind of built-in test tools. It also is very good with the computer because it's got built-in USB, 24-bit USB sound card, and 3 USB virtual comm serial ports for CAT control. So you can do very easily digital modes with WSJTX or other digital software, very easy to configure. That's a picture of the inside of QMX, and you can see it's pretty complex, compact I mean, and it can be done carefully. I don't think you quite need to have a Swiss watch fetish to get there, but you need to be careful. But then in 2024 I made a larger version, which was QMX Plus, which is essentially the same schematic, but it has twice as many filters, switched filters. So it covers all the way from 160 meters to 6 meters. And runs the same firmware as QMX, so all the same features. But it also has an optional GPS module you can add inside the enclosure, and a battery for real-time clock backup, as well as lots of space for expansion that you can add your own modules. And people have done modules for a charger, ATU, and speaker, for example, that slots in on top and have it all in the same box. I don't yet have an option for that, I have an official option for that, but I would like to have one. This is a quick picture of the inside, and this was actually the revision 1 board, so the current board has a lot less that you have to do. So for example, it doesn't have these switch mode power supply boards, they're integral on the board, and the through-hole capacitors are now SMD as well, so it has less to do on the current version. There are really nice CW filters, selectable filter bandwidths from 50 to 500 hertz bandwidth, very clean sounding filters. Low latency and good break-in performance was always important to me. I'm CW operator, not an SSB operator. Not particularly good at CW either, but better than I am at SSB. I've never had an SSB QSO, except with myself when I was developing the polar modulation SSB. And it has very clean envelope shaping, Blackman-Harris shaping. So I did this comparison that you see here at the bottom right from QST reviews of the spectrum of the keying. And QMX is extremely clean there in the middle compared to some of the other transceivers. Even looks very good compared to the Ellercraft transceivers. Also has built-in iambic keyer memories CW decoder. As I mentioned, the digital side of QMX has the built-in USB sound card and virtual comm serial all over the single USB cable, so it's very easy to interface. It also has a special method of counting the audio frequency and then transmitting that as a clean synthesized wave rather than SSB modulated FSK. So it produces a very clean signal. Anyway, that's the background of the whole thing. Now onto the SSB side of things. And this SSB was a kind of promise from the beginning of QMX 2 years ago. And everyone took it as a firm promise and was continually asking me, when will I be able to deliver it? And there was this built-in microphone that you can see there in the middle, of the small microphone on the board, and you could also plug in a microphone and PTT. And the plan was to use envelope elimination and restoration methods to generate SSB, which is another word for polar modulation method. I actually first came across this in 2019 at the Dayton Hamvention. We had in those days ClearSpan tent, and I was a latecomer compared to all the major producers. So I was in the ClearSpan tent with the QRP Labs booth, and Tony had his own desk about 3 along from me, and so this was a picture of his 500 watt transceiver that he demonstrated his prototype at Dayton in 2019. I didn't hear any more since that in the last 6 years until this year, when suddenly Flex announced their 500 watt transceiver, the Aurora, which was basically developed by Tony K1KP from his prototype. So that was very nice to see that he did find development opportunity for that. So here's a couple of pictures from 2025. On the left, that's me talking with Tony, and we discussed for about half an hour very nice details of polar modulation. And then the Flex founder, Gerald Youngblood, there on the bottom right, and 2 of his engineers. It was a great honor for me to demonstrate QMX to these guys from the big American company Flex Radio. The next thing that was important was microSTX, which was designed by Guido PE1NNZ, originally on a QCX. So he took my QCX monoband CW transceiver and he made his own special firmware version, which made it behave as an SSB transceiver with polar modulation as an SDR. Numerous others were involved, so Manuel DL2 Man, he did a lot of work on Class E filters and the output stage. Barb WB2 CBA was involved. Later there were a lot of Chinese versions of it as well, which was a bit controversial, as always Chinese versions of everything can get, and people start arguing about whether they're legitimate or not. So that gave me the idea, basically microSTX gave me the idea that rather than QMX just being CW and digital, the pure marriage of the QCX and the QDX, the CW and digital, I could also add SSB because I had the envelope shaping in there, so I could use that envelope shaping to produce amplitude modulation, and I should theoretically be able to produce polar modulation SSB just like Guido had done. And so it was kind of a huge act of faith because I had already sold about 10,000 QMXs before actually releasing the firmware for QMX SSB, and there would have been some unhappy people had I not succeeded. And so I had hoped to be able to do that, but the fundamental thing was I was using a much more powerful CPU. QMX has a 168 megahertz 32-bit ARM Cortex M4 processor with DSP and floating point instructions. huge amounts of memory and all these peripherals, so it's a lot more capable processor. The micro SDX just used the Atmega 328, which was a very sort of minimalist implementation. But it really all goes back originally to 1952, where Kahn proposed in this IE paper to split SSB into amplitude and phase components and modulate these two components of the SSB signal separately, and it magically results in SSB, so the unwanted sideband and the carrier disappear. The big advantage is you don't need a linear power amplifier. This is an advantage both in terms of efficiency, but also in terms of performance, because I'll come on to this more later. A linear power amplifier is trying to get these curves in the data sheets of transistors and make them into straight lines, and that's always a losing battle. You're fighting against what the transistors want to be. And so the big advantage here was you can use a switching amplifier for the RFPA, and that results in very high efficiency and simplifies the design of the PA for a given level of performance. So here's a diagram, don't worry if you can't read it very much, from the 1952 paper, which is basically explaining on one slide how polar modulation SSB occurs. So you start off with audio from the microphone, and you do a 90-degree phase shift on all that audio, which is a Hilbert transform in DSP terms, and that gives you the real and imaginary components, which we call I and Q. The phase angle between those is just the arctangent of Q divided by I, and the amplitude is the square root of Q squared plus I squared. And then once you've got those two components, the angle and the amplitude and the angle, you can then apply them separately. The other way I like to explain this, if you think of our typical way of looking at coordinates where we have north, south, east and west, and you want to specify how far is it to London. You might say, okay, travel 50 miles east and then travel 50 miles south if you're a bird and you could fly and you weren't stopped by roads and buildings. 50 miles south, 50 miles east. Or you might say, okay, travel 70 miles in a straight line at an angle of 120 degrees, and it would take you to the same point. So coordinates can be expressed in multiple different ways. You can have a simple XY coordinate on a piece of graph paper, or you can represent the same point in space in polar coordinates as a distance and an angle. I'm sure some of you have big towers and rotators on the top, and you're used to having beam headings that you steer your antenna rotator to point at the DX station you want to talk to. Same concept. It'll be 5,000 miles that way on a heading of 180 degrees or something. So we can represent any point in space when we're looking at a 2D surface as either X and Y coordinates or as an angle and a distance. And the same really applies to voltage signals in a transceiver. We can represent them as an amplitude, or we can also represent them an amplitude that varies in time, or we can also represent them as an angle and an amplitude. So this is my attempt to explain how polar modulation occurs. In QMX, the amplitude modulation was, this is the CW shaping circuit that was added there. It's basically an amplifier with a power transistor and it just scales up the digital to analog converter output of the CPU to a supply voltage for the power amplifier. And the big advantage of doing your amplitude modulation at audio is that you don't have to deal with a lot of effects that you have to deal with at RF. So you can have multiple transistors and you can have feedback mechanisms, as you see here in this feedback mechanism here, which provide a much higher linearity. It's much easier to get linearity at audio than it is to get it from an RF power transistor. Then on to the phase modulation. We generate the actual signal in QMX and in QDX, even in QCX, with a marvelous PLL synthesizer chip called the SI5351, or its Chinese version MS5351M. And you can ask for any frequency out from this thing and it will give it to you. It's on an I2C bus on the processor, and you can update that at up to 16,000 samples per second. Now, the very important thing to realize is when you're applying, what you apply to the synthesizer chip is a frequency change, not a phase change. So you have to think about how to get a phase change indirectly. And the way I like to see this, if you look at this diagram on the bottom right here, if you had two signals, which I've indicated here with the red and the black sine wave, if they're offset by 1 hertz, so for example, one of them has 10 million cycles per second, and one has 10 million and 1 cycles per second, if you start them both at the exact same point, at 0, so they're in phase at time 0, by the time 1 second has passed, they'll come back into line and they'll be at exactly the same voltage again. They'll both be at 0 again after 1 second. But 10 million of one of them will have passed, and 10 million one of the other one will have passed. And so the important thing is, if you decided you want, so you've got then a 0 phase shift after 1 second, or a 360 degrees if you like. If you wanted to have a 180 degree phase shift, you could stop the situation at half a second. If you wanted a 90 degree phase shift, you could stop the situation at quarter of a second. Or if you wanted a 180 degree phase shift in quarter of a second, you could have a 2 hertz frequency separation and just run it for a shorter time. So you can play around, and what you end up with is applying a series of frequency changes which are calculated that at the end of each sample they've produced the desired phase shift, just by how the signals drift relative to each other. So this was the very powerful concept which Guido PE1NNZ developed for the micro SDX, and which we also use in QMX. Now a little bit about how we test SSB and how we judge the quality of an SSB modulator. There are always 2 tones, and conventionally we use 700 Hertz and 1900 Hertz. They have to be non-harmonically related. And we put those 2 tones together into an SSB transmitter and look at the output on the spectrum analyzer or an oscilloscope. If you put an oscilloscope, you see something like on the left there. But you can't really make any decent measurements from that of how good or bad the transceiver is. It will look like that even if it's fairly bad. It will still look okay on the oscilloscope. So the real thing you need is a spectrum analyzer. And you see these 2 peaks in the middle, which correspond to the 700 and 1900 Hertz tones coming through. But then you also see this forest of nonsense on either side, which are the intermodulation products which occur because of non-linearities in the SSB amplifier. These you don't want. All these side products you don't want. And if you look at one number which expresses the decency of a SSB transmitter, it's the 3rd order intermodulation product, which is the first of these spikes as you come down from the 2 wanted signals in the middle. So you look at the height of that spike relative to the height of the wanted spike, and that's the IMD3 in dBc, dB relative to carrier. The ARRL have a slightly different method of specifying it in their QST reviews, which involves dB PEP, which is just 6 dB more than dBc. So you have to be careful that you're comparing like with like. There was a web page by VK2IHL where he gave his opinion, which I gathered was fairly consistent with what was generally consensus. And minus 40 dB he said would be really excellent, minus 30 dBc was good, 20 was poor, 10 was very poor, and 5, minus 5, was what he measured on the micro SDX. So again, this is not a criticism of the micro SDX. It tried to achieve a lot with a very rudimentary amount of hardware and CPU processing. So now on to how I actually made this work, and I'm not going to talk about pain or torture. You heard me talk about that last night. But to start off with, well, I'll talk a little bit about pain and torture. To start off with, just feeding in one single tone into the system results in a nice spike like that. So it's a good start, and it was nice to see that basically something is working in the system. The amplitude modulation was also working very nicely. I was able to provide a signal to the digital to analog converter and see that reflected in the RF envelope, which is the blue trace at the top on the oscilloscope. So that was good. When I applied an audio signal to this amplitude modulation, I also got something that was okay, that's how AM is supposed to look on a spectrum analyzer. These 2 little spikes down here are not what you want, but they were quite a long way down, so that was again a great start. But when it came to SSB, I just couldn't make this work at all. And this was where I spent my 3 or 4 weeks headbanging and despair. And so these were some of the scope photos I took during those horrible 4 weeks where I started to doubt whether I would actually manage this or not. and started preparing all the apologies I was going to make to people who had bought QMX with this promise that it was going to have SSB. So I couldn't make these nice 2 peaks appear no matter what I tried. And I started to think that maybe Guido was making everything up. Khan had been making everything up. Even Tony K1KP had been making everything up. And I started losing optimism completely and working in the middle of the night, and it was, it was a very difficult time. And you know, if you were a kid and you made one of these 1 transistor FM bugs, and you could just about decode it if you were in the other room next door, and it wasn't really very good FM. Even if you'd had an AM receiver in the room next door, you would also be able to decode it. And I kind of thought maybe it's like that, you know. But then I had the idea to compile in Guido's code, and it was actually, I was talking with my friend Ross, EX0AA, on the phone, and we kind of were discussing the problems I was having, and we both came to this same conclusion. I could just take Guido's open source Arduino project and paste it directly. And he was using 16-bit integers, I was using floating point. He was running at a much slower update rate of only 4.8 kilosamples per second. He had approximations for everything because he didn't have time in his CPU to calculate arctangents, square roots, and Hilbert transforms to a high accuracy. So, but I was able to convert my floating points from the microphone system into integer and then on from there into Guido's code. And magically I saw these 2 peaks. When I fed in a 600 hertz and an 850 hertz signal, I got the 2 peaks come out. I wasn't terribly impressed by all the rest of the stuff, but at that point, I finally saw 2 peaks, and it was a great moment. And this is, you know, my favorite photograph from the whole project for that reason. But of course, I was hoping to improve on that because all of this other stuff around the side would not sound particularly good on nearby frequencies. So as I went through line by line, changing 1 line of code to the next until I found the problem, and my friend Jamal, TA2BG, who's a university physics professor at Ankara, he came over. He has a holiday house nearby to where I live, and we discussed this for literally 8 hours solid. Every now and again, my wife would call me on the phone, "Where are you? What are you doing?" Still talking to Jamal. And we figured out everything, that because I had used the arctangent function, and tangents repeat every 180 degrees. They have this kind of shape like this, every 180 degrees, whereas sine waves repeat every 360 degrees. So when you come to do the arctangent, which converts back from the tangent to the angle, you get a result in the range plus 90 to minus 90. So I was losing half of my polar modulation. It's like if you imagine on a latitude-longitude description of coordinates on the Earth, if you said, okay, my longitude is 45 degrees, but you didn't say whether you meant 45 degrees east or 45 degrees west, you've lost half the hemisphere, you've lost half the information. And so that was the problem, that was all it came down to. So Jamal told me in the math.h C library there's another function, atan2, where you pass in the 2 parameters and it divides them and it takes into account the quadrant and returns a function in the an angle in the range minus 180 to plus 180. So it was a great moment. Then I started working on all the other problems I had, and I had this distortion in the modulator where it had several issues. The first one was the overshoot. So you got these kind of spikes here. When you made a big step change in the amplitude, it would overshoot and then come back. Correspondingly, on the way down the amplitude on the other side, you got this kind of slow decay. And then it didn't go quite to 0 in the middle either, which was another problem. So I started trying to solve all of these problems, and again, they were huge weeks of work. And I solved the overshoot by amplitude interpolation. So I ended up with 28 linearly interpolated points between each of the original points, and it produces a much nicer. You can still, if you zoom in, you can still see these overshoots, but now you've got 28 little steps on the staircase with little overshoots, rather than one big overshoot on a big step. So that was a big improvement. And then at the 0 crossing, I was able to switch off the signal completely when it was below about 1 volt peak to peak, and that improved that situation. A key fundamental requirement of the whole project was that I couldn't change the hardware. So if I had discovered that something was a fundamental blocking for the whole situation, the whole SSB project, I couldn't go back to the 10,000 people and say, can you start soldering SMD components and making modifications? So that was, luckily I had no showstoppers, but I had all these little wrinkles that I had to work around. The next thing I looked at was phase pre-distortion. So when you have a signal passing through your power amplifier, even if the amplifier is in Class D as in QMX, you end up with a variable phase delay which depends on the amplitude of the signal. And I was able to correct for that by measuring it using an oscilloscope. So I fed in one oscilloscope channel the signal at the beginning of the PA and the other one at the end of the PA, and I was able to then freeze the oscilloscope and measure the phase change. And that was something that I really didn't want to have to measure by hand and code into the system. The Polar Explorer article in QEX 2017 had a shape very similar to mine. So mine is there on the bottom left, and they had seen something that you see there on the right. That's taken from the QEX article. And Polar Explorer used the AD8302, which even in quantity was a $19 chip. Whether or not they still have that in the Aurora, I don't know, because Mike, I'm trying to push him for details of this, but he won't give me any details of the schematic. We can ask you, Mike, all these people all these people might put pressure on you. So they had this very expensive chip to measure phase and amplitude distortions and to correct for it. But I was able to come up with a way of measuring the QMX to measure itself. So there's a transmit-receive switch, which is shown here on the right-hand side, and it kind of mutes the receiver during transmission, but it only has about 30 or 40 dB of attenuation because it's just a simple transistor. It's not really a mute, it's just to save the receiver downstream from a huge signal which would fry all the components during transmit. And the interesting thing is that if you operate the receiver and the transmitter at exactly the same time, and you start both the transmitter signals and the receiver signals in phase at the same time, and then you suddenly offset the receiver oscillator by 5 Hertz, you can then count the zero crossings, and you can see how long it takes you to count, say, 5 cycles. And you also know how long it should take to have 5 cycles, because you know at exactly what point you change the frequency by 5 Hertz. And the difference between what you measure and what you thought you were going to get is the phase delay through the system. I couldn't believe that that would possibly work. I'm sure none of you can believe that either, or most of you can't believe. But it actually did work, and I was able to obtain very close to what I measured on the analog measurement by hand. So I had to do all these tricks, like because the signal was so huge, in some cases I had to run the receiver at 1/3 the transmission frequency, so that I would be receiving the third harmonic to reduce the amplitude. And in some cases using different bandpass filters to the correct one for the band, so that it would just reduce the amplitude. But this was an example left and right by my manual method, which I did on the 40-meter band, and by the method that was measured using the self-measurement internally in the software. So I was very, very happy with that. I was also very happy because you could do that at 40 meters, but by the time you come up to 10 meters or 6 meters, unless you have a gigahertz oscilloscope, things starting to look very difficult to make any decent measurements at those high frequencies. But with this method, you can do it. Then the next question was about amplitude and phase synchronization, the modulation. Because when you do the frequency command to update the frequency for a new phase, that phase only comes to fruition at the end of the sample. By that time the phase has slid to where you expect it to be. And there are all kinds of delays, like how long it takes to send this serial data over the I2C bus to the PLL chip. All sorts of delays everywhere, which is very hard to calculate for or predict. So my next question was I going to be able to have an automated method to determine this optimum synchronization? Now on the left you see a poorly synchronized phase and amplitude modulation. On the right you see a well-synchronized one. And you can see that the well-synchronized one has very much lower intermodulation distortion products compared to the one on the left. I was actually able to do this by transmitting a two-tone test into the transmitter to produce this spectrum analyzer plot, but then running the receiver at a 2.7 kilohertz offset through the transmit-receive switch, which was switched off, and then summing up the content of what came through in the receiver. So when the receiver was off by 2.7 kilohertz, it's receiving the section of band in this white box, which contains the 3rd, 5th, and 7th intermodulation products. So I was able to sum those up and obtain some kind of relative measure, at least, of the intermodulation performance of the transceiver. And so with that, I was able to vary the synchronization between phase and amplitude in steps of 1/28th of a sample, and plot the internally plot the amount of 3rd, 5th, and 7th harmonic, and find out exactly where the minimum was, and use that then as the synchronization delay between the two. So these self-calibration tools provide maybe 10 dB of improvement in intermodulation performance when you run them. And of course, they're measuring your own particular radio, which may have different component tolerances to someone else's. So in my final implementation, I had to balance everything up, and even 168 megahertz CPU, you quickly run out of time. And I had, in the end, my transmit logic was using 93% of the CPU. And I had run the DSP at 12,000 samples per second with 28 points interpolation on the amplitude, and using the direct memory access to peripheral in the processor to stream these samples very accurately. And it results in about a minus 35 dB for the IMD3 product. By comparison with other transceivers, the Elecraft KX2 and K3S have approximately the same IMD3 number. So I was quite pleased with this result, considering I originally expected to do better than the Micro SCX had done, but I didn't expect it would be that much better. So a couple of other things I'll just try and skip through quickly, because I think we're running out of time, and polar modulation was the main point. Controlled envelope single sideband is another thing which I implemented in QMX. Basically, when you SSB modulate anything, you get an amplitude overshoot of the amplitude RF envelope, and a conventional transceiver will then reduce the gain, probably automatically using ALC, in order to prevent that RF clipping, which would cause SSB splatter into adjacent channels. So controlled envelope single sideband is a method for controlling those overshoots and removing them without causing distortion. So that was a picture of a typical SSB. So you start off with perfect audio, perfectly bounded plus minus 1 notional amplitude, but when it comes through on the output, you can see my blue dotted line here. That's the full amplitude. So you get these considerable overshoots, which would cause horrible splatter in practice. On the left side is without controlled envelope, on the right hand is with controlled envelope, and you can see the big difference there. And what it typically means is that a 5-watt CESSB transmission has about the average power of a 12-watt normal sideband transceiver, because it increases the average power without the distortion. You can choose the audio source for QMX SSB audio from the internal two-tone generator, or from the microphone, or from USB sound card if you want to do digital modes. There's also parametric equalization. So DXs say you should boost the treble part of the audio and reduce the bass part of the audio, and you can set all of that up exactly how you want it. You can see on QMX, you can see this on the LCD screen with a miniature kind of graph that you see there on the bottom left. Or if you have a terminal emulator and log into it with a terminal emulator on a PC, you can plot the graph shown there on the screenshot. So just in summary, the CSSB feature the transmit equalization. We also have compression, so you can control the amount of compression between 0 dB and 99 dB, which would of course be utterly ridiculous, but anywhere between 0 and 15 or something you can experiment with varying levels of distortion. There's microphone gain and AGC, voice-operated transmission, noise cancellation, noise gate, phase pre-distortion, and all of these self-calibration tools. So why I love polar modulation? Well, I'm so excited about polar modulation. I may not look very excited, but that's because I'm English. So I'm understated. But it gives a very surprising level of performance. I got minus 35 dBc. By comparison, I had previously designed a 10-watt linear when I was working on the QSX project, which has now been cancelled because QMX Plus does everything that QSX was going to do. And this performance level is about 10 dB higher than we had in that. Of course, IMD3 is only one measure, it's not the only thing, so there's still a lot of potential for further improvement as well. But the most important thing, I think, is that you have these curved characteristics in the data sheets, and for the last 75 years or whatever people have been using transistors in power amplifiers, engineers have been fighting to make those curves into straight lines, and it's putting a square pole into a round hole. It doesn't really want to happen. It's unnatural, and so it's an abomination really to do that. So a linear amplifier is really not the way. And so with this method, polar modulation, your amplifiers are operating in class D, which means that transistors are completely on or off, and you don't care about the curves anymore. You don't need to buy any expensive transistor which has had its curves nicely tweaked to try and be good for SSB. You don't need any of that. It just needs to be on or off. Guido, I have to mention again, because we stand on his shoulders. I know that Flex were developing from Tony K1KP as well, and but Guido really showed how you could do it on very simple hardware. So the long battle was really worth it, and I want to emphasize again 3 huge advantages. The higher efficiency is one of them, because you can use switching amplifiers, class D, class E amplifiers. You don't have to use a linear amplifier. That results in lower cost, cheaper transistors, smaller heat sinks, smaller power supply, smaller enclosure. And for any given level of skill and expertise, which mine is not very high, we have a higher level of performance. So you can imagine if it takes 20 RF engineers to make a good linear amplifier, it takes one clown like me to come along and you can just about manage to make a polar modulation SSB. And so I think it's a real game changer for the industry, because it's not just very high efficiency, but the lower cost and the shortened development time to achieve a given goal. And you can see this in Aurora's Flex's Aurora, which they have along by the Martin Lynch stand. The heatsink for their 500 watt transceiver is the same size as the one they use in a 100 watt transceiver. And the enclosure is the same size, but they've also included the power supply. And so it's an amazing, amazing technology. This is just a quick summary about this is the Shameless Commerce Division plug, where I show the QMX and the prices of the QMX. We sell them both as either a kit or as an assembled transceiver. And finally, we have our forum, we have our webpage, my email, and YouTube channel. And so I managed to get through all of that in a reasonable time.
Brilliant.
Thank you.
Any questions?
Thank you.
So does anyone have any questions? You were first hand up over here.
Hello,
can I just run away at this point?
It's Mike, G4CDF. Thanks, you gave us a talk at Reading and District Amateur Radio Club not long ago about this. I have a particular question. Is it possible to add a homebrew amplifier onto the end of your transceiver?
It is.
And gain the advantage of the polar modulation? And how would you do it?
Well, you mean to get a higher level of power output?
Yeah, say to make a 100 watt amplifier, but with using the Class D modulation. Is it possible to interface such a beastie into the QMX Plus?
That's a very interesting question.
I knew it. I knew it was.
I think that should be possible to do, and it's not something I've yet tried, but I think that should be a possibility to do. The other thing people sometimes ask me is for controlled envelope sideband. Do you still get the controlled envelope sideband if you run it through a conventional linear afterwards? Right. And the answer is yes, you do, because once you've got rid of those overshoots, they're gone forever. Right. And the linear is just amplifying what goes in and what comes out. But the question of going to higher power and how you do that, and whether you do it as an add-on amplifier or as a new device is an interesting one.
I think it'd be really cool if you could take your rig and amplify it up. Yeah. Even if you needed some feedback or
some feedback to measure the
special
phase
amplitude modulation output or whatever. Thank you.
No promises. I'm never going to promise anything ever again. So.
We've spent the last few decades getting our transceivers better and better on phase noise and getting them ultimately to decay away. and it's ultimate attenuation, which is very important. The third order is pretty much in your own channel. What target do you think you need to achieve with this method 20 channels out?
I don't have a number in mind, but I agree with you, it is a challenge. And you find with a conventional linear that the higher order intermodulation products decay quite quickly.
Depending where the bias is set.
Right, whereas with
low bias, they'll be very high. High bias, they drop away.
Which also makes it very inefficient, right? Whereas with polar modulation, these higher order products tend to decay much more slowly.
That's the problem.
And that is the problem. And so the solution, there are solutions to that, which is you can, there's a rule of thumb which says that your processing speed, your DSP sample rate, should be 5 times the maximum audio bandwidth that you want to cover for a 30 dBc IMD3 performance, but it also affects the higher order products. So the solution is to get faster, but that involves faster CPU, more current consumption, and as every time you go faster by a factor of 2, your CPU cycles increase by a factor of 4. So a lot of unpleasant things happen.
So it would be if that transmitter was a neighbour of mine.
Right. But I believe, for example,
you've been using the third order value of,
yeah, it's a single number only.
-5. There needs to be a stake put in the ground by users of this technology for the ultimate level it will be.
Yeah.
I think it's extremely challenging.
It is extremely challenging, and it should be. The aim should be to reach a comparable level that we get with a conventional sideband transceiver, I believe, a conventional good one. So it does need to be improved. Increasing the processing speed, I mean, I believe Flex do it at 96,000 kilosamples per second, which is a much higher rate than I'm capable of in my CPU. But they have FPGAs and all kind of stuff going on in there. So yeah, that's a very important consideration, and it needs more work, I agree.
Marek, M0JUR. So first of all, I'd like to thank you, because I've been watching QRP Labs rigs for quite a few years, but not being a CW operator, yes, I know, I'm really going to get to it someday, probably like when I retire or something. But yeah, I've really been looking at kind of the lack of SSB was a bit of a blocker for me, and now, well, I actually bought the QMX Plus in the summer. You might recall we had some problems with the wire delivery, but so I don't actually have to thank you or curse you, because now I have got no excuse but actually start taking that thing with me to SOTA, because before too big. But I really love the idea, the fact actually, of course, that's largely Guido's work, but the fact that this really shows that we can still achieve as improvements in amateur radio. Of course, I suspect there are probably some clandestine sets out there which GCHQ and the like use, which already use this technology for years, but this is something new. But yeah, question. What do you think you're going to do now? Are you got so fed up with this fight with the SSB that you're just going to hide for a year? And
I said just now, I said no promises, secrets only. The problem I made earlier with in 2018 when I did the QSX transceiver for Yota in 2018 in South Africa, the problem there was the pressure afterwards when everybody knew what I was working on. And everybody wants to know when will it be finished, what features will you put in, and it ends up mentally destroying you. And so I decided after that, everything I do will be by surprise. So I declined to answer your question.
Any more questions or comments before we wrap things up? Are you taking orders now?
For QMX and QMX Plus, we are, yes.
No, it's taking orders now.
So we've sold almost 13,000 of these two models, QMX and QMX Plus. We sell them as kits and as assembled radios, and so they're very popular.
Okay. Well, if you want to order one now, can you go to another corner of the room, because we have another lecture coming up. Would you give you a round of applause to Hans, and thank you. Remarkable. Remarkable. Thank you very much.
Well, in a moment, we're going to hear from 3 young radio amateurs who represented the RSGB in August at the Yota summer camp in Paris. But first, this short video.
It's different every day, and it's a lot of fun, very exciting.
It's the excitement of learning about electronics and getting my hands dirty, seeing how it all works. I've made a lot of friends for amateur radio.
I can speak to people all around the world. It's fun and will probably help out with physics at school.
The only limit is your imagination.
Hello, I'm here this afternoon with Leon, Sophie and Emily, and they are 3 members of the RSGB team that represented the Society at this summer's YOTA camp in Paris. Here to have a little bit of a chat with them about how the camp went and what they were up to. So Leon, first of all, can you tell me a little bit about what drew you to wanting to be part of the team that went to Paris this summer?
Yeah, well, I got an email from sort of a mentor in amateur radio who I had explaining to me that there was this thing called YOTA Camp and I should have a look at applying. So I had to look online, I had to look at social media, and you know, I just finished, it was about to finish my A-levels, and I wanted to get back into amateur radio properly after exams and sort of really do something new with amateur radio. And the camp looked amazing, it looked like just my sort of thing, so I put in an application hopeful that I would get it. And then I got an email telling me that I was going to Paris. So I think it was just what drew me to it was the fact that I wanted to do more and more with amateur radio because I hadn't done all that much with my licence, and this looked like the perfect opportunity to do that.
Fantastic, and you all got involved with a wide array of activities, and I know, Sophie, you yourself had the opportunity to ask a question during an ARIS contact. Can you tell me a little bit about how the selection process came to be able to ask the question, and if you can remember what your question to Mike Fink was?
Yeah, so we got asked to submit questions just in the selection before the camp, and then I was really grateful that I was one of the people chosen. I just got told that morning, actually. I wasn't told beforehand, told just a little bit before, oh, you'll be asking one of the questions, and I was so excited. Obviously, it was such a great opportunity to have. And so my question was, I think it was something to do with how your body feels after you come back from space. Yeah. And so, yeah, it was just amazing.
Yeah, I watched the contact on the live stream of the event, and you could feel the atmosphere and the buzz from everybody that was there. And I don't know, Leon, if you can recall how many different national societies had representatives there, and sort of how many people were at the camp in total?
I don't recall exactly how many. We had people from all over the world. There was a huge amount of European countries, and we also had visitors from outside of the region. So we had people from Japan, from South Africa, from Argentina, from America also flying to come and say hello and take part in the activities. So it was so many national flags flying, and it was really nice to see.
That's great, and some of the photos that you sent over from the blog that you all kept was brilliant, and that's actually still on the website for people to see via rsgb.org/YOTA-camp. And during the blog, you shared details of some of the activities that you got involved with. Emily, I don't know if you can give us an example of one of the activities that you enjoyed most.
Well, the one I enjoyed most was the paper rocket launching, where we built paper rockets with the Irish leader, Anna, and we just sent them up through the... I saw the video, and I could sense Anna's excitement as the rocket launched, and I think it was one of the most successful launches of the day, wasn't it? So, and Sophie, are you able to tell me some of the other activities that you got involved with during the camp?
Yeah, so we obviously did a lot of operating. It was really great for me because I haven't been in amateur radio that long. I took my exam in February last year, so it's great to be at such an amazing station and have people there to guide me through it, help me along the way. And then we also did some kit building, so we did a CW key, key and paddle for that, and then also just discussions about amateur radio, about youth involvement in it, how to develop that. We had a really interesting workshop about weather balloons as well. That was one that I really enjoyed, how to hunt them and salvage the various parts from it, as well as lots of smaller presentations that people from different countries gave just about whatever they were interested in. So those were kind of shorter, just really bite-sized, but really interesting.
Oh, that's brilliant. And if I recall correctly, Leon, you also had the opportunity to take your FCC licence exams as well.
Yeah, so it was a bit of a surprise because I didn't know about it at all until I turned up and I was told, oh, there's American licence exams if you want to go get your American licence. So I thought, why not? And it was really good. So Sophie and Sam got their technician licence and I got the extra licence, and it's actually very useful for them because there's remote radios in the US that you can operate from your laptop at home, so that gives you more freedom to do it, and it's also just fun to get more call signs, so it was a little bit of extra stuff. It was great to have that kind of thing because because it was nice just to have sort of activities thrown at you. There was always opportunity there to go do something new that you just would not have thought would be there, because I had no clue that you could do stuff like that. So I think it was a really nice opportunity. Yeah.
That's great. And here today we've just got a short space of time to talk about some of the activities that you were involved with. But in, I believe on the 1st of December, you're going to be delivering the Tonight at 8 webinar, and you're going to be talking a bit more about what you did there.
Yeah, and it'll be great to do that, because we'll have much more time, I think, to go over in detail all the kinds of things we got up to, because it was a week that was absolutely full to the brim of activities. I don't think any of us stopped from the day we got there to the day we left. So there's so much to talk about and to say how much we enjoyed it. Yeah.
That's great. I can feel the energy and the sort of enthusiasm that you had about the camp.
It was definitely one of the best experience ever.
Brilliant. You know, and so to sort of any young radio amateurs that are watching this from home, what are your words to them to sort of say?
Apply.
Apply
for it. I almost didn't. I wasn't sure. I was still really new to it, and I just wasn't sure if it would be the right thing. But I'm so glad that I did, because I had the most amazing time, and it's made me really want to get involved more in amateur radio now. It's made me come back really inspired, and it's been great even so coming on to the convention again, seeing people who were at YOTA, not just Leon and Emily and Sam, but people from other countries as well who have come over to the convention, and really increasing youth participation in it.
Which is great, and sort of for people watching from home, there's been a few international radio amateurs that you met at the summer camp that have come over to the convention, which has been really positive.
That community, it's been a really nice community. It's great because we've got these friends abroad, and there's events, and we just get invited to them, and we get to go see people from all other countries and invite them back over here, and that's a really nice community to have, and it's definitely made a big difference to how being a young operator it feels.
That's great. And as well as the Tonight at 8 webinar in December, it's also YOTA month. So the RSGB is encouraging people to go to the website and find out about GB25 YOTA, and encouraging people to book an operating slot and try and get as many youngsters, young people on the air as possible. Are we going to be able to hopefully hear you on the air at some point, getting involved?
Hopefully, yeah. I think hopefully I'll either be calling in or helping to run one of the stations, but I completely agree and encourage everyone, even if they're just calling in, to find the GB25 YOTA stations and get in the log.
Brilliant. And I know, Emily, you're part of your school radio club up in Scotland, and Chris Aitken is your teacher there. And I know he'll definitely be getting you involved in December and operating the special event station. Brilliant, great. Well, it's been lovely to have you here talking to me today. The Tonight at 8 webinar, just to remind everybody, is on the 1st of December, and more information about the webinar is on rsgb.org/webinars. Thank you very much. As I said, it's been great to talk to you, and I look forward to hear from you in December.
Yeah, thank you very much.
Thank you very much.
Thank you.
Well, over the weekend, you've seen and heard some of the fantastic things that the RSGB has been doing during 2025. The Communications Manager will be bringing some of those together in a highlights video early next year. So for now, let's take a look back at some of the big numbers and achievements from the RSGB from last year. In a moment, we'll be going over to GB3HQ again, our special event station, where actually our president, Bob Beebe, is going to be there from 2:45 this afternoon. So time to make your last contacts with our special event station. Let's go over there now.
Yeah, 73.
CQ, Golf Bravo 3, Hotel Quebec, special event station for the Radio Society of Great Britain at Kent's Hill in Milton Keynes. CQ. Oh, goodness me, we've got somebody who's going to just go da 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 da. Oh, anyway, right, may I have it's a CQ, Golf Bravo 3, Hotel Quebec. Right, 2 India 0, 2 Echo 0, India Sierra question mark, over.
Yeah, 2 Echo 0, India Echo Sierra.
Oh, the wrong way around. India Echo Sierra, thank you very much. This is Golf Bravo 3 Hotel Quebec, the special event station, the headquarters station of the Radio Society of Great Britain. Thanks very much for calling in. 5 and 7:57 at the RSGB convention this afternoon. How copy, over? Right, yeah, sorry about that. Golf Bravo 3, Hotel Quebec. I've got had to put a notch in for our beeper person. And I don't know this radio very well. So, CQ, Golf Bravo 3, Hotel Quebec, over. Charlie Alpha Sierra again, please, over.
Oscar November 4, Ocean Nancy 4, Charlie Alpha Sierra.
Yeah, got you. Ocean Nancy 4, Charlie Alpha Sierra. Nice to have Belgium into the clock again this afternoon. Thank you very much for calling in. 5 and 9 at the RSGB convention. So how copy? Name this way is Simone, Sierra India Mike Oscar November Echo, over.
Roger, very fine. You're 5 and 9 here. I'm an RSGB member, and you're 5 and 9, no problem at all here. 25 kilometers north of Brussels. Name is Egbert. 73, thanks for the contact. Bye-bye.
Yeah, 73, thanks for calling in, and catch you further down. QRZ, this is Golf Bravo 3, Hotel Quebec, over.
Golf 4, 0, NEY.
November Echo Yankee.
Yeah, very good afternoon to you, Simon. It's Golf 4 November Echo Yankee. The name's John, and I'm located at Munsley. I'm physically located at Munsley, but my radio is back in Willingham near Cambridge. And it was great to get to the convention yesterday. And hope the weather's okay with you today. From Golf 4 November Echo Yankee.
Yeah, Golf 4 November Echo Yankee. Well, the weather's okay. It's not exactly the warmest, and it is grey and overcast, but it's dry, and that's the main thing when you're outside all day, as I am. So thanks very much, and nice to have you working your radio over the internet. Very clever. So I've got plenty of stations. I'm going to put you in the log and say thanks for calling, and glad you enjoyed the convention. See you soon. QRZ, Golf Bravo 3, Hotel Quebec, over.
Golf 6, Victor Zulu Delta.
I've got a mobile station. I'll take the mobile.
Yeah, thank you. It's Golf 4 November X-Ray Golf Mobile.
I missed that mix. November X-Ray Golf Mobile. Yes, there we are. Golf 4, November X-Ray Golf Mobile. Good afternoon. Thanks for the call. My name is Simone, Sierra India Mike Oscar November Echo. I'll do your report on the next over. How copy? This is Golf Bravo 3 Hotel Quebec, over.
Sorry, I didn't get the report or the name. Could you repeat it, please?
The name is Simone. The name is Simone, Sierra India Mike.
And now it's time for our last lecture of today. Was that Solar Cycle 25? What did we learn from Steve Nichols, G0KYA.
Hello and welcome. We're about to hear Steve Nichols, G0KYA, with the lecture called Was That Solar Cycle 25? And what did we learn? And Steve's going to look at how the solar cycle developed, including the high points and the lows. You sometimes wish the sun had just did a little steady stream, don't you? He'll also look at official predictions and how they panned out. For those who don't know, Steve is the chair of the RSGB Propagation Propagation Studies Committee with an interest in HF and the ionosphere, and he wrote the RSGB book Radio Propagation Explained, and he also prepares the weekly propagation segment for GB2RS, and he's a regular here. I think that's the third or fourth time I've introduced Steve. So Steve, it's over to you.
Thank you. Yeah, they always give me this slot. I don't quite know why, but it's the
keep
one
us awake.
It's the one where people generally want to fall asleep, including me. So just don't snore too loud. That's all I would say. Right, solar cycle 25. Is it over yet? What have been the highlights? Well, where are we? This is a chart showing. Ah, no, it's not.
The low point.
Ah. We'll go back one. There we go. There you are. Is it over yet? Hooray. So this is where we are. And you can see we had a peak in August 2004. Well, it looks like a peak in 2004. But just keep your eye on this little peak here as well. That might be relevant later on. This is based on the solar flux progression. We can also look at it based on smooth sunspots numbers. And again, so we've got August peak 24, 216, and then this tiny peak here, which may become relevant. We'll see. Now, let's go back to what we expected. Well, the official Solar Cycle 25 prediction panel thought that Solar Cycle 25 would be similar to the last cycle, i.e. not that good, but was consistent with a maximum sunspot count of about 115, they thought. And that was the official NOAA/NASA Solar Cycle 25. And this is a graph of the previous solar cycle. So I don't blame them for suggesting that it was going to be less than 22, 23, and 24. I mean, it did look that way, didn't it? But there we go. No, they then did an updated prediction, and they said, yes, still, solar cycle 25 will be slightly weaker than 24. And we're currently at the beginning of the midst of the modern Gleisberg cycle, which is a bit of a minimum, a bit like the Maunder minimum. But they said it was too early to determine whether this was the case or whether the sun would actually wake up or go back to sleep. Another, this is an analysis by Carl, K9LA, Carl Lichelswab. And he looked at 27 predictions. And they ranged from somebody suggesting that we had only a maximum of 50 sunspots up to 229. That was the record, I think, in terms of cycles. And that was Scott McIntosh who came up with that one. So this just shows we don't really know. We're guessing a lot of the time. So 27 ideas of what solar cycle 25 would be like. I think my opinion would be wait until it's over and then make a prediction. So this is a graph of the predictions for cycle 25. And you can see an average cycle that we've put an indicator there. And Scott McIntosh and two other groups were up here at the end here. Scott McIntosh predicted that solar cycle 25 would be one of the strongest ever recorded. The peak sunspot number 184 between late 2023 and mid-2024. And he based his research on what he called the Hale cycle, which is when the sunspots, they basically start at high latitudes, and as there's progression, as the solar cycle comes, they progress towards the equator. And then there's a polar reversal, a magnetic reversal, and it goes around again. The trouble with making predictions is that you're really out there, aren't you? I mean, I'm convinced that before the year 2000 is over, the first child would have been born on the moon, said Werner von Braun. that didn't really work, did it? And last year I said that, you know, another great prediction, which is very difficult to make predictions, especially about the future. So, you know, it's not an easy thing to do. Now, obviously, the sun's hemispheres are often out of sync. I say often, not always, but often out of sync. This is known as the Ganesky gap. And the offset can be as much as 2 years between having the peak in one hemisphere and the peak in the other. And it's a known characteristic of the sun's activity, which is why I said keep your eye on that small peak from a few years ago. Now, there we go again. Was this the first peak? Have we now had the second, or is there another peak to come? So here we go. This is, you know, got to put your head on the block now and suggest, you know, predict what's going to happen next. Is it going to continue to decline, or are we going to have another peak? I don't know. This first peak may have been the first peak of one of the hemispheres. But if we analyse that in a little bit more detail, this is a graph of the sunspot cycles over the last few years again. And you can see that on the whole, we do get these twin peaks of the northern hemisphere and the southern hemisphere. The southern hemisphere has been leading by a long chalk in this cycle. But we don't always get this happen. If you come back here to this 1958, which was obviously a brilliant sunspot cycle, the south and north hemispheres were pretty much in sync. That's probably why it was one of the best cycles. So the more they're split, okay, the cycle lasts longer, but it's not a good indication of high solar flux or sunspot numbers, really. So again, looking at this printout for 25, do I think that we're going to get a peak in the northern hemisphere? I don't think so. We may have already had it. So that's bad news, because we're on the way down, basically. This is, I got these images from NASA. Don't worry, the sun never looks like this. If we had this many sunspots, we'd be laughing, wouldn't we? This is over the whole year, the plot of the sunspots. And you can see that they're pretty now, in 2024, they're pretty evenly spaced across the equator. In 2023, there were still some high latitude sunspots there. So it looks like the northern hemisphere was lagging the southern hemisphere a little bit, but now they look fairly equal, which is why I think we're not going to get another peak. But if we do get one, I shall take full credit for it, don't worry. And again, this is a graph showing how they have peaked. So we've got the southern hemisphere, which has largely dominated the recent activity over the last year. I don't know. Do you think we'll get another peak? It's difficult to say, isn't it? It's very difficult to say. But what I did say in 2019 was we get increased maximal usable frequencies, upper HF bands will be open to DX, bands will be open later, fewer coronal hole issues, more lung path openings, and 6 meter band will be open. I think most of those things came true. I'm not so sure about 6 meter band being that far open, but we've had most of those. And then on the boo side, the not so good, increased solar flares, yes, we've had those. Increased number of CMEs and auroral events, yeah, we've had those. Absorption on the lower HF bands, yeah. Coronal holes increasing, we've had some massive coronal holes recently. And 40, 80, 160 meters not so good due to delay absorption. So it's actually quite easy to predict what's going to happen in a sunspot cycle, because it's just pretty much the same every cycle. So we know these things are happening. So where are we in cycle 25 then? Well, cycle 25 started in December 2019. It looks like the peak, as I said, was August 2024. I don't remember what year it was then. And we weren't really known that when we've hit maximum until about 26, 27. So we've still got a good 18 months to 2 years of this cycle left. So it's not all bad news. But this is a graph of the cycles that we've had recently. The red one is cycle 25, which is still in progress. As you see, it beats the previous cycle, but it's not a band killer. It's not a. This is 1958, this top one, which was everybody who's been around. Everyone I speak to tells me about what they did in 1958. You know, well, I was hearing taxis in America, you know, amazing. Yeah, good, thank you. We haven't been quite so lucky recently, but it's better than the NOAA/NASA prediction. 25 was better than the official NOAA/NASA prediction. Not quite as good as Scott McIntosh's prediction, but he was on the right side. Let's put it that way. He did better than the official prediction anyway. So how did propagation improve? I heard a lot of complaints this summer that propagation wasn't very good. Well, that's a seasonal thing, I'm afraid. This shows you the path from UK to New York in August on the left, which gives you a maximum usable frequency of, well, about 20 megahertz. So 17 meters, 20 meters open, but that's about it. And on the right is how 10 meters suddenly comes into its own. So this is October. So from now you can see that from about 11 o'clock, 12 o'clock onwards through to about 6, 10 meters should be open to New York. Not seen an awful lot of it yet because we've had some disturbances, but there are signs that it's now waking up. So yeah, when I hear, oh, propagation's not very good this season, is it? No, well, that's probably why. It's a summer thing. You know, we really need the autumn or spring to really make the MUFs climb. Now, just going back, I want to just touch on this Auroral event. We had massive Auroral event, 2011-24, sorry, May 11-24. And I wrote for GB2RS 4 X-class solar flare events on May the 8th and the 9th, prompted CMEs which could join together to impact the Earth this weekend. We can expect a strong G3 event, perhaps on Saturday, with a KP index rising to 6 and the potential for visible aurora in the UK. Then I promptly went to bed and missed it. This is what the KP index hit, nearly 9, 8.5, I think 8.6. So we don't often get it that high. This is what PropQuest looked like the day before. So nice pattern there, MUFs of 20 megs, 21 megs, 24 megs, over 3,000 kilometers. And that was the day after the aurora. So absolutely nothing until gone 4 o'clock in the afternoon. So this was from Quebec, and this is from Norfolk. So I missed this. Not that I'm bitter. That's my fault. Honestly, I was about to go to bed and I thought, oh, look, KPX. Oh, I'll go to bed. I'll be all right. It'll be another one. Yeah. So this was the great event that some of us will all remember when you could photograph aurora like this at our kind of latitudes. Will we get another one like this in this cycle? Possibly. Possibly. Keep an eye on solarham.com. Can't promise it, but we might, or we could get an event like that. If not this autumn, maybe next spring, but we'll have to see. So as I said, in that big auroral event of last year, it seems at 50 megs and above, there was too much auroral spread for FT8 or FT4 to work. There was lots of auroral CW, and there's just some of the places that were worked on 2 meters CW. Now, why has October 2025 been so bad? I mean, recently we've had quite a lot of K indices very, very high. But if you check the records, there's no CMEs, there's no solar flares, there's no coronal holes. So what's been causing this? I think it's something called the Russell-McFerran effect. This is a scientific explanation that came out in the 1970s that describes how the Earth's tilt makes a big difference to how aurora can occur. And obviously in March 21st or thereabouts, September 21st or thereabouts, the Earth is pretty much, well, it is straight up and down. The pole is straight up and down. So this means that the flow of the solar wind, which can easily hit 800 kilometers a second, just bear that in mind, 800 kilometers a second, not an hour. I think it's, yeah, I wouldn't want to be an astronaut out there when that hits, to be honest. So anyway, these 2 times a year, the magnetic field is more easily interacts with the magnetic field of the plasma coming off the sun or the solar wind coming off the sun, and you're more likely to get effects, which is why the K index has been quite high recently. That should now be tailing off. So we then go back to just the K index goes up when we have a CME, coronal mass ejection, or other event such as that. But if anyone says, oh, well, why has it been so bad? Well, you can say it's the Russell-McFerrin effect. Now, just want to go through some highlights for me, anyway, 2024 highlights, and also just point out the VOACAP point-to-point 24-hour charts on the right-hand side that you can produce yourselves. So this was UK to Christmas Island, FTA, unfortunately, not CW or USB, but this was quite happy to work this, more than happy to work this. I get very surprised when I work this anyway with wire antennas, with a flux of 187 and a KP of 4 or 5, which is a bit on the high side really. But these are very useful charts, these 24-hour colour charts. You can easily see the best time to work the area that you've selected, and that's in voacap.com. Kiribati, that was FT8 as well, 17-metre FT8. Solar flux index 222 KP of 2. But so that was another one. And where are we now? 17 metres. Yeah, it's a kind of orangey red. So that's a good one. Indonesia was an unusual one for me to work on FT4. And that was with an SFI of over 120, only 120, and a KP of 3. So, yeah, if you really want to work, I mean, I was talking to somebody at Newark who said, can you help me? He said, I want to work Wyoming for my work to all states. And I said, oh, right, I've got just a chart for you, and sort of produced this chart. He said, that's good. He said, how come you've got that? I said, well, because I needed to work Wyoming last year for my work to all states. And it showed that he worked, if you want to work on 10 metres, there's basically a half an hour window to work Wyoming, and then that's if there's any hams there, because they're not exactly known for, you know, being hundreds of them. But there we go. So Indonesia FT4, that's one chart. So I really encourage you to have a look at VOACAP and see how you can use these predictions. This was Mike in the Commonwealth contest, 15 metres. I should have said I was only running 5 watts, so I think that's 5 watts. From a wire antenna to a wire antenna, so it's not a beam to beam. So I was quite chuffed with that. But didn't do too well in the Commonwealth contest, but there we go. Blame the sunspots, there we go. And New Zealand, which I don't work New Zealand very often. So 20-metre CW contact with an SFI of 205 was, I thought, quite good. So again, we now have VOACAP and VOAPROP. No, beg your pardon, VOACAP and PROPI, as we call it. It's ITU RHF prop. So we've got 2 models that you can use for modelling where you want to work. And the details, I think, are on the RSGB website. But it's basically www.rsgb.org/PROPI or rsgb.org/VOACAP, and that will take you to the relevant sites. Good. Now, what's this saying? Oh, do I want an update? No, go away.
Remind later.
Yeah, remind later, go away, never. This is my laptop, so yeah, ooh, yes. What can we expect for the rest of the cycle? Well, this is a graph of sunspot number versus the number of disturbed days. And as you can see, the number of disturbed days compared with the sunspot number, generally one lags to the other. So we generally have more disturbed days on the downward portion of the cycle. And I think that's been pretty evident over this last 6 months or so. We've had a lot of geomagnetic disturbances. The coronal holes have been quite massive, some of them. Do we all know what a coronal hole is? I don't know, I shouldn't use these terms without explaining. Well, a coronal hole on the sun is an area of lower energy. That's why they're black when viewed in ultraviolet or extreme ultraviolet. And there are areas where there's less magnetic field lines, so the solar wind can escape more easily. And so that is a big contributor to the solar wind, which again pushes the K index up, which brings down the maximum usable frequency, and so hurts propagation. But yeah, so as you can see, we're on the downward slope now, I think. So we are seeing more disturbed days, and it will probably continue like that now for another year or so. It's a doom and gloom talk, isn't it? So as I said, it should have good DX for at least another year, maybe 2. October's one of the best months for DX, so why are we all sitting here having a lecture when you could be working the bands? 10 meter DX generally needs a solar flux index of over 100, and geomagnetic disturbances are generally worse on the downward portion of the cycle, as I said. Will we get another major auroral event? Possibly. There we go. I'm not going to commit myself too much, but there's every chance we could. Whether it'll get up to KP 8.5 or what it was the night I missed it. Not that I'm bitter. We'll have to see. Now, okay, couple of quick news updates really. What are we doing with RADCOM predictions? Well, you may recall that we changed it recently, or a year or so ago, to have letters as well, because people were saying, well, what about FT8, FT4, whisper modes that are kind of below the noise? And so we introduced this system of having letters, A, B, C, D, E, F, for signals that are less than S1. Well, I don't think that's really worked, to be honest. Talking to people at Newark, someone said to me, well, can you help me with this? Because I don't understand it. It's just gobbledygook. And it's got BBC on it. What does that mean? So I can hear the BBC? And no, you can't, but there we go. So anyway, we had a long chat about this. Is John BAO here? He's not, is he? I don't think. Yeah. John said, do you realise you were talking about this for 50 minutes? He said, I was listening to the football instead. Right. So, but anyway, we put our heads together and we decided to change this so that all of these letters, all of these signal strengths less than S1 would just be represented by a colon. So this doesn't show you very well, but this would be coming in either next issue or the issue after. But so you'll have a colon now for this is a potential contact you could make on FT8, FT4 whisper. So we've taken all the letters out. Now I think it makes it look a lot cleaner. But as I said, we had big discussions about whether we should do it or not, but I just said it's not working. There we go. Right, now the other announcement I need to make today is that the UK is going to have its first national personal space weather station, which is being set up by the Propagation Studies Committee at Ofcom in Baldock. I'm very pleased to announce this. This project for a personal weather station, space weather station, has been on the cards now for about 2 years, but trying to find a location for it, somewhere that's electrically quiet, where people were not transmitting. We looked at Bletchley Park, but obviously they do transmit, so that's not going to help. But we eventually settled on Baldock. We just needed to persuade them that this was a good idea, and they've gone with it. So they've been very, very helpful for us. I think you'll agree with that, won't you? Yeah. So what is a personal space weather station? Well, it's an SDR receiver. This is us testing at Baldock on last Monday. It's an SDR receiver that is set to receive signals on certain frequencies. So it will cover all the FT4 bands, FT8, and it will also cover things like WWV, CHU, all the time stations, so that we get a continuous 24-hour recording of the both the spectrum and also the signal strength of these signals. I'll show you what sort of thing you can do with it in a minute. Why has it been difficult to put it at Baldock? Not really that difficult, but they didn't want us to connect it to their internet, which is fair enough. So we've worked out we're going to use 4G cellular modem, and couldn't believe it. We went in this little shack which they've set up, or they've given us, and got 5 bars of 3 mobile. So that was very good. So we're getting the throughputs we need. We've done a site survey. We just need to sort the equipment out, and an active antenna, active dipole antenna, vertical dipole antenna. And I think this will be up and running by Christmas. So there we go. And there'll be more about this in RADCOM in due course. But I think the thing was to get permission to do it, and then we'll set it up and then talk about what you can do. And meanwhile, I mean, we were helped there by Nigel Squibb. I'll come back to that one in a sec. So this is some research that Nigel G4HZX has done. He's monitoring the CHU time signal from Ottawa and how it varies. So it shows you multiple propagation modes going on there, which he's looking at, and evidence of off-great circle propagation paths. But again, this is going to benefit the Americans as much as it's going to benefit us. We will have access to it, everyone will have access to it, but the Americans are now able to do research from transmissions of American stations into the UK, which they've never been able to do before. So it's very good. It's going to benefit the whole of the ham community. This is another one. He looked at the transauroral Doppler path from Hawaii to the UK to see through the signal going through the transauroral oval, looking for Doppler and frequency spread. Again, that's not something they can do in America. So this is, as I said, a big boon to ham sci in America. So there we go. It's been very pleased to announce that. It's been a long time in the coming, as it were. So, and finally, though, I've left about 10, 15 minutes for questions if anyone's got anything. But in conclusion then, I think we're past the peak of cycle 25. Can't be totally sure, never know. Expect more geomagnetic disturbances, I'm afraid, as we progress it. Probably another 18 months to 2 years of good propagation at the moment. And the recent problems we've had with a high K index is probably due to the equinox effect. But there we go. Open it up to you guys.
Thank you very much, Steve. So any questions, any comments? Because we've got a long way to the raffle.
Steve, thank you very much for that. We started with the sun and we're left with the sun by the look of it, but nothing to do with the newspaper, of course. But anyway, I understand that there is also an 800-year sunspot cycle. I'm wondering whether or not there's any coincidence of that cycle with what's going on right now, if you know about that.
No, I don't. I mean, yes, there are cycles. I mean, for starters, there's an 11-year sunspot cycle. There's a 22-year sunspot cycle, which it really is because the magnetic field of the sunspots changes in every 11 years. So it's actually a 22-year cycle. There are other cycles within that people have identified. I'm not sure about an 800-year one. I don't really see much evidence that we're getting brilliant at doing sunspot predictions, to be honest. I don't blame NOAA/NASA for predicting that this cycle was going to be worse. It looked like we had a declining trend. And I thought when Scott McIntosh put his head on the block and said, yes, it's going to be the best cycle ever, as it were, it was a risky statement to make. But it's better than the last cycle. So in some respects, he's more right than they were wrong, if you see what I mean. Yeah, I don't know about an 800-year cycle.
Leading up to the beginning of this cycle, when these predictions were being made, there was one of the predictions that was predicting a fairly high level, which is what we've actually seen, was based on a hypothesis that the sunspots, the solar activity was influenced by the position of the planets and the position of the planets in the orbits. Has that gained any further traction at all?
I don't think so. I know the one you're talking about, but it just seems odd how the gravitational effects of the planets, especially the outer planets, could possibly affect sunspots. But I don't know. It needs more research. I know it sounds a stupid thing to say, but we're fairly new at this. So in terms of how long the sun has been producing sunspots, and we know an awful lot more. If you go back, to the 1900s, 1800s, 1900s. On knowledge of what's going on. But I mean, who was at Lucy Green's lecture on the first day? I mean, she said herself that they don't know much about the solar corona. And so they're trying to plan a mission that will tell us more about that. And I think we just build on our knowledge as we go. I've forgotten what the question was now. It was about, the planets affecting sunspots. Yeah, well, maybe. Yeah.
Steve, Tony Canning, Golf 2 November Fox. Thanks for your presentation. I wonder, over the years, has there been any improvement in extending the propagation studies to look at top band at all?
Ah, right, top band.
It's been like this for a long time.
Yeah.
We're not seeing anything movement at all.
I don't think so. I mean, we can basically come up and say, right, you need a dark path between you. Grey line is good, but in between that, no. I mean, it's very, very difficult to find out what the factors are that are affecting top band. I mean, yes, we've got K indices and whatever, but sunspots don't really affect top band other than absorption. I mean, top band, I think propagation, that the MUF is always above 1.8 megs.
I want to know when it's a good time to get up in the morning.
In the winter, definitely, yeah. But on a day-to-day basis, predicting good conditions on top band, that's why I winced a little bit, because yeah, it doesn't really work like that. Don't know.
All right, thank you.
Too tricky. Sorry to be.
Any more comments or questions? Anything you need to add, Steve? Because we've got a few minutes before the raffle.
Yeah, I probably stopped a little bit too early for the questions, didn't I? Yeah, do use these two URLs at the bottom here, the rsgb.org/vocap and /proppy, because they allow you to tailor your station. I mean, the trouble with Radcom is it's 100 watts to a dipole and SSB, I think. But people always say to me, oh, well, I can do much better than that, or I do much worse. So we worked out that it's impossible to get more information on one page of Radcom. So we worked with the developers of vocap online and ITU-RHF prop, or proppy as we prefer to call it. And so you now say exactly where your location is, how much power you're running, what antenna you've got, what mode you're using, all these factors. So you can actually produce a set of predictions that are accurate for your station. And we've duplicated it. It was easy because we just we went to the guy who was doing proppy, James Watson in Saudi Arabia, and said, could you do this? He did, yes. And then we went to the developers of vocap and said, can you replicate this? So I'm not saying that vocap is better than proppy or proppy is better than vocap. We just took the line of there are two main prediction methods or tools available, so we will produce tools for both of them. We're not going to say, oh no, we're not going to touch vocap anymore, it's too old. And both programmers have done fantastic work. It's OH6BG, I think, is the vocap programmer. And yeah, they've done marvelous things for us. So yes, you can. If you use these URLs, that will take you to the page where you can just come up with monthly predictions based on the locations that are in Radcom, or if you just go in directly to vocap and proppy. Soundbites.asia is where proppy lives. Yeah, you can do everything. So you can do the point-to-point, you can do the area calculations, you name it, you can do it. The vocap rotary 24-hour charts, I don't think they've duplicated that in proppy yet. So you can go direct, but if you just want to do a list of the 27, I think, is locations around the world that are in Radcom, you can go to those two. But I thoroughly recommend you use the products that we've made, because it's going to make your life a lot easier and just help with, I want to work this particular state, and how do I go about doing it? As I said, NUIC is great for Propagation Studies Committee because you talk to people, obviously, and some of the people there don't know that much about propagation, which is fine. But what we learn is, what do people actually want? And they say, questions like, what's the best time to work Wyoming? It's a valid question. So it's actually better to talk to people like that and actually sort of work out how we can fulfill their needs.
You mentioned seasonal variations in your talk, the summer, we all know doldrums. Yeah. Fair to say we are coming into the period now where 20 metres may stay open until we've gone to bed, or?
Well, it goes the other way. Over the summer, 20 metres stays open up to 24 hours a day in the summer, but this time of year now it starts to close around sunset. So yeah.
How about daytime then?
Daytime, daytime's good. Daytime's good. The higher solar flux numbers are not so good for 20 metres. They're good for 10 metres and 15 metres, but you're probably finding 15 meters is working better for you than 20 is at the moment, due to higher levels of absorption, delay absorption. So 20 works very well when the sunspot number is lower, but it's not so good once it climbs. But we're not, I mean, at the moment, what's it, about 130 thereabouts, solar flux? It's not that high. I mean, we've had over 200, 300, you know, is a sort of limit or level I think we got to in the last cycle. So 20 meters is not bad. It's working okay anyway.
Hi Steve, Makita 2E0LBG. Interesting site for the new solar weather station.
Well, Ofcom, yeah.
Yeah. Do you think it would have been better suited at the, say for instance, Mullard Radio Observatory near Cambridge, with them dealing with that sort of stuff, looking in space? And also, what kind of data do you expect to find once it gets up and running?
Okay. Firstly, I've no doubt. Have you been past Baldock, by the way?
I have.
It's the middle of nowhere, isn't it? That's what we liked about it. And there's a couple of radio hams who work there who've been really, really helpful and have to muck in. So that's one of the reasons Baldock was chosen. It was a case of just proving to the Ofcom management in London that this is what we want to do and this is how it could benefit you, because they're going to use it as well. What data will you get off it? Well, I think we've got Gwyn sitting in the audience. I mean, do you want to comment on that, Gwyn? Or? Hang on.
So it will gather daily spectrograms of WWV, WWVH. They're on the same frequency, so that's a challenge of interpretation where VOACAP and PROPI can be used to separate them out. And also the unique frequencies from CHU Ottawa. So from 2.5 megahertz up to 25 megahertz, those standard time stations. And there is a HamSci web page that links through to the database. So each day you would see a spectrum with the exact frequency at 0 and then the Doppler shift, as was shown in those green and yellow plots. I don't know if you want to go back to those, Steve. So there we are. They're the spectrograms that show the Doppler shift on the y-axis with the signal strength coded as color. And there's the example of an eclipse. And they are automatically generated. So you see that set for the station the day after they have been received. It also, and this is a single RX888 Mark II SDR using KA9Q web radio. So as well as doing that, the single SDR monitors all bands from 2,200 meters up to 6 meters for FT8, FT4, Whisper, FST4W, and sends those to the relevant databases. So that's whispernet.org, PSK Reporter. And it operates KA9Q Web, which is an SDR-like interface that will be able to be looked at by both the Baldock people and the Propagation Studies Committee. And all of the spectrum data and the WSJT spots data is, of course, publicly accessible.
Thank you, Gwyn. It's so much easier to ask Gwyn to explain it because he's been actually using the damn thing, so he understands it way more than I do. Okay, any more questions?
A very quick comment on Mullard, because I wasn't involved in the project directly, but I am local and the university, so there were some noise issues.
Yeah.
I won't dare explain the details that the people actually did that,
yeah.
But there were that was looked at Mullard. There turned out not to be quite suitable.
Mm. We went to Baldock to do some tests, noise tests, and I think we were both impressed by just how quiet it was out in the field. It's just nothing around it. That's the thing. So when they said, "Well, yeah, do you want to put a station here?" Oh, yes, please. Yes, yeah, good. As I said, it's been a long time in the planning. There's been issues with the chipsets that were unavailable, I think, initially, and then finding a location that was accessible, that nobody else was going to be using for transmission purposes, which is why Bletchley couldn't be used. So yeah, I wouldn't say it's been a pain, but it's not been easy. But the question came up, well, what about Baldock? And I said, well, we really need a contact there. And somebody, John BAO, knew somebody there, so got a call in, and from then, that's been history. But we had telephone calls and Zoom calls with them, didn't we? And they had lots of questions to be answered, but I think we got through all of those, so that's good.
Thanks very much, Steve. Very interesting. What's your view on Tamitha Scove, WX6SWW, the space weather woman?
I think she's great. I think she is enthusiastic about the subject, turns it into kind of a weather forecast, doesn't she? She knows her stuff. I mean, she's very well qualified. Anyone who raises awareness of propagation, in my eyes, is very good. I did wonder about getting her to come over here as one of the speakers one year. I might suggest that. Yeah.
Have we exhausted the questions and the comments?
Just exhausted, I think.
Just exhausted, yeah. Well, we'll wrap up at 5 minutes early then, and the next presentation in this room will be of prizes for the raffle.
Yeah.
I've bought tickets too. God knows, God knows what will happen if I pull out a ticket. But thank you very much. Would you give a warm round of applause for Steve?
Well, thank you very much for joining us here from the live stream, both days at the RSGB convention in Milton Keynes. You've been coming actually mainly from this live stream studio, and now you can actually see. We thought we had a few minutes, so we thought we'd actually show you around some of that. So if I stand up, and you could see probably as Kevin, our cameraman, zooms out, you'll see some of the cameras set up here for the live stream interviews that we've done at various points over both days. And then if I walk a bit further forward, I actually have the continuity, as it's called, or PRES, which is the links between all of the lectures. When you've seen me with an RSGB background, that's when I've sit here. We can't really show you that very easily from the camera that we've got over there, but there's a camera and light and stuff like that here. But the real control center, as it were, of it all is down here. And we thought, as this is a technical hobby, and a lot of you are going to be technical and maybe interested in what we're doing. By the way, we are all volunteers for the RSGB. We're just interested in video and these sort of aspects of the production. Then we can show you what some of this is. So Kevin at the moment is operating a remote camera, a PTZ or pan tilt zoom camera. And you can just about see his right hand is on that joystick. And if he turns it clockwise, for example, he can zoom in and you can get closer tight. Quite close-ups for things, and you can pull out as well. And then looking around, if he pulls further out, you can see quite a lot of computers in here, a lot more than you would normally see for things. And that's because all of the different lectures around this conference centre, and they're miles away, well, not miles, but they're a long way away in different areas of this big building. We've actually, each of those rooms has a video server implemented in software on a computer, and we're using the infrastructure of all the cables, the intranet, if you like, of this building to send the pictures and sound from each of the lecture theatres to us here in the live stream studio, where we select whatever lectures we're going to take and broadcast them. So that means that there aren't bundles of big cables going between all of the rooms. So we've got several computers doing that sort of thing. Now Tammy here is the video director, really. You're the one who chooses all the shots. This is Tammy M0TC. You can see in front of her, if you've been interested in video and you've ever done anything, this is a video mixer. This is unusual because although this is an 8-channel video mixer, that's not enough, because we've got 4 cameras here in this studio, we've got one over there, we've got one downstairs in the SIG room. You've probably seen we're using the mobile camera at various times. Plus, of course, we've got all the feeds from the different lecture rooms as well. So Tammy's also got a sub-mixer here, a smaller mixer, which takes the feeds from individual lecture rooms to feed in for her master feed onto this mixer here. And finally, there's a graphics computer here. That adds a lot of the things, the captions, the lower thirds, and the graphics of various graphics that you've seen over the weekend. That's this computer here. Another computer here, I can't see what that does. This is the media, so this is where we're going to, if we play you a video, if we say we're now going to take a look at a video, we've been storing them and playing them out all from this computer here. And finally, the computer on the windowsill is probably the most important for you watching at home, because this is our live streaming computer. It's a fairly powerful Mac Mini, if for those of you interested in this stuff, and it's running a streaming software, and that's been streaming it now, and the very fact that you're watching this now means that you're watching the output from this computer. So it's quite an interesting workflow. We also have things like called in-ear monitors, which is quite an interesting thing we've used here, because it goes around all the building, and the various people working in the various lecture rooms, we can take cues, and they can also hear what we do going out. So when we introduce a lecture, or when we say we're now going to go over to lecture room 1 or 2 or whatever, they can also hear me saying that, and that gives them a cue, which is hopefully why most of the time I think this weekend we've been on time. Anyway, I think that pretty much wraps it for a short look round the Livestream studio and all the work that we do here. Thank you very much for joining us over the live stream. We do love to see you though in person. Maybe you think about coming here next year, because there's a wonderful community. I think especially guys, you'd agree as well, it's been especially lovely this year. A lot more younger people as well, and just a lot of generally a really good atmosphere here. And of course there's the bar in the evening and meals and everything else. So wherever you're watching this though, thank you again for joining us, and we're now going to go over to our GB3 HQ special event station for the last time, when we've got the RSGB president, Bob Beebe, GU4YOX, making those last contacts. Good evening.
Mike 0, Mike Alpha Radio.
Mike 0, Mike Alpha Radio 59.
You're fine on mine, thank you. Bye.
73, QRZ, Golf Bravo 4, Radio Sierra. Golf Bravo 4, Radio Sierra, President of the Radio Society of Great Britain, listening on this frequency.
Echo India 11 Whiskey Alpha Tango.
Echo India 1 Whiskey Alpha Tango, you're 59 over.
It's actually Echo India 11 Whiskey Alpha Tango. You're 59 plus 10 into the south of Ireland. I'm just activating the first activation of our Scout Group call sign, 11th Water Scout Group, in preparation for next weekend's Jota.
That's fantastic, and thanks for calling in. We've had Echo India 4 Lima here this weekend. John, your president, and it's been great fun. So thanks for calling in, 7-3. And I'm just going to take one more call now, and then we will bring our operations to an end. This is Golf Bravo 4, Radio Sierra. One more call.
Golf 4, Echo Romeo Foxtrot.
That was a big pile-up. Okay, try again, please.
Golf 6, Juliet Mike, Romeo Foxtrot.
The Golf 6 again.
Golf 6, Juliet Mike, X-ray.
Okay, Golf 6, Juliet Mike, X-ray. Really sorry to everyone else who's just called in there. This will be the last contact today from Golf Bravo 4, Radio Sierra, President of the RSGB. My name is Bob. You're 5 and 9, G6 GMX, 5 and 9, over.
Golf 6, Juliet Mike, X, returning. Yeah, fine, Bob. Handle is Barry, Bravo, Alpha, Romeo, Romeo, Yankee, and your 5 and 9 plus 20 is me. And thank you for everything, all everybody else has done over the weekend for that. Back to you, 73.
73, and thanks for calling in. And really sorry, everybody. That concludes the contacts today from the Bletchley Park, from Milton Keynes, the RSGB convention for 2025. Thanks for calling in. So 7-3s, and station now closing down. And so that's it. We've had a fabulous weekend here, and we're going to close the live stream now. This is the RSGB convention. I just want to say a big thanks to everybody that's made this event so successful. We've had so many people visiting, we've had so many volunteers helping out, and of course, the most importantly, we've had many, many guests and attendees. Nearly 50 lectures this weekend, and it's been very entertaining, great fun, and I look forward to seeing you consider coming to the 2026 convention next year, which should be even bigger and better. So from me, GB4RS, Bob Beebe, President of the RSGB, thank you very much and goodbye.